of what's been a year of exciting activities for our capstone students. They've worked exceptionally hard, and we're really excited to get this going and to give you a chance to share in all their hard work that they've spent for the whole year. As we just wait for a few more people to come in, we will have some introductions to a number of special guests who are here today. But we will be starting shortly with a particularly special guest. We have Jane Goodyear, our Dean from Lassonde, who's going to give us a welcome for the day and also start off with our land acknowledgement on this important day. So over to you, Jane.
Good morning, everybody, and it's great to not see you. I can only see Franz, which is good. Franz, I love to see you, but yes, it's a bit strange because I can't see everybody. But so I'm going to be doing the welcome and the introduction. But before we begin, I really would like to do our land acknowledgement. And so as this meeting is virtual and we are not all gathered in the same space, I recognise that this land acknowledgement might not be for the territory that you and myself are currently on. So we ask that if this is the case, you take the responsibility to acknowledge the traditional territory you are on and the current treaty holders. Now, as a member of the York University community, I recognise that many Indigenous nations have long-standing relationships with the territories upon which York University campuses are located, and that precede the establishment of York University. York University acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and also the Huron-Wendat. It is now home to many First Nations, Inuit, and Métis communities. We also acknowledge the current treaty holders, the Mississaugas of the Credit First Nation, and this territory is subject to the Dish with One Spoon, Wampum Belt Covenant, an agreement to peaceably share and care for the magnificent Great Lakes region. And on that note, I would just really want to echo what Franz has been saying. This is going to be such an exciting day at the Lassonde School of Engineering as we celebrate the capstone. I mean, even though I'm not in the same room with you, I can actually taste the excitement, but also the trepidation, because I know that you've worked so hard over the entire year, and you're going to be assessed as well today. and so I really hope that your nerves don't overcome you, that as a team you really do really put together and put across all the amazing work you have done, because let's face it, capstone is the culmination of your studies. You've really used what you've learned in your programs, come together and try to solve a quite complex problem. And at Lassonde and at York, we've had the capstone from Lassonde and also the C4 project. And it's so special to see how engineers and others work together to solve the problem, because let's face it, the problems we're seeing today and in the future, they're going to get far more complex. We need more interdisciplinary thinking around how we solve these problems. And so, it's going to be great to see you. And I also really want to thank our judges, and also, let's face it, the assessors, because you've got a big job ahead of you today, because I think the quality is going to be out of this world. So on that note, I really do wish you a successful day, calm the nerves, and really try and enjoy it, because again, this is like the showcase of what you've achieved through your 4 or more years at York University. So on that note, I wish you every success, every one of you, and yeah, ooh, I'm excited. So thank you very much. Thank you, and over to you, Franz.
Thank you ever so much, Jane, for kicking us off. And just to reiterate, so it's a great way to start the day, to ground ourselves in the place that we're in. And for many of you, this is, as Jane said, the end of your journeys here at Lassonde, and thinking about this space and this place is something to reflect on during the day. And then don't stress too much about the assessment piece. Today is not really about that. It's about celebrating the hard work that you've done all year. We're obviously keen for you to be able to do the best, share the best of everything that you've done all year, and we know that's going to happen today. We have a busy agenda. Just to let you know, there are actually 3 webinars happening today. We have this room today where the ENG 4000 teams will be presenting. We also have a space today where our friends from Civil 4000 will be presenting, and there is also the C4, the cross-campus capstone classroom and York Capstone Network webinar that's happening as well today. Some of the ENG teams have entered in for some of the York Capstone Network Awards, and those will be those teams will be participating in both ENG panels and going across to the York Capstone Network panels as well. So there are lots of things happening in parallel today, and we're excited to see all of that happen. There are some logistics that we just want to run through for the panelists in this room. We have 6 panels running today, and in order to ensure that teams get into their panels quickly, at the start of every panel, we will be asking anybody in a team in that panel to raise their virtual hands so that we can very quickly get you promoted to a panelist. That will allow you to be able to enable your videos so that we can all see you. It will, to Jane's earlier point, we don't want to see me all day. We want to see you because you're the ones who are celebrating. We also will then, at the end of a panel, put you back into the attendee role so that you can watch, and we have the right people who have their screens available for the panels. When you're a panelist, we would like you to have your cameras enabled. The other things that we will need to be sharing during the day, there will be an opportunity for a poll at the end of every panel so that we can work out the crowd favorite best presentation in each panel. So at the end of every panel, we will have a quick poll that we're wanting all the attendees to participate in. That'll let us know who the crowd favorite is at the end of the day. So we can keep a track of that. There will be at lunchtime a set of videos showing the reflections that all our students have made on what they wish their September selves had known before they set out on these great capstone journeys. So if you want to grab your lunch and come back to this Zoom room, you'll be able to watch those September videos and get a sense of what our capstone students want to share with you about the journey that they've been on this year. At 3 o'clock, we will be having a trivia session whilst the judges who are judging, who've looked at all the videos that the teams have put together and will be judging the awards for the engineering capstones. The judges will be off finalizing their decision on who's going to win the prizes. During that time, as I say, there will be a trivia session available for everybody. So do come and join in, and that will be a chance to sort of unwind at the end of this day before we go into the awards presentation. We will have a common awards session across the whole of Lassonde. We'll have the civil and ENG 4000 teams coming together for the awards ceremony in Lassonde. And then directly after that, we will switch over to the YCN awards room for the campus-wide award ceremony at the end of the day. So a lot of things happening. And before I get us ready for the first panel, I do want to just mention some of the judges that we have with us today. We have had a number of people involved in looking at the videos. Not all have been able to join us today, but I'll give a shout out for those that we're looking forward to having us join. Either they've joined already or we're looking forward to them joining over the day today. We have Anton Gallego, we have John Unlusoy, Gabriel Dekoto, Hassan Haji Ismaili may not be able to join us today, but has been participating in background. Jason Thomas, who has also been somebody who we've had in a number of our meetings over the year when we've had our external panel sessions. Joshua Abraham, one of our alumni, along with John. Kishon Webb, Steve Jar, Tom Granat, and Hania Ali, who's also alumna. So very much thank all the work that they've been doing over the last little while, looking at the videos that you've all submitted. We've been really impressed with the quality of the videos, and we really appreciate the work that you've put in on that. They've provided some questions that we'll be asking you throughout the day. We will be waiting for their final judgment at the end of the day for our ENG prizes. So before I dive in to get us ready for panel one, I know that a lot of the panel one students have already raised their hands to be promoted to panelist. If you are in one of the teams in panel one, if you could now raise your hands, then we can make sure that we get you into the panel one panelists as soon as possible. Are there any other notices, Claudia, that we need to be sharing, or Sandy?
Nope, you're good to go.
Great. And just to give a huge shout out for the enormous amount of work that's been going on behind the scenes. We'll do it again at the end of the day, but to Claudia for making this possible. Without Claudia's work all year, we wouldn't be able to do this. And with Gayatri and also all the student support that's been helping with that. They really are the glue that makes Capstone the whole year round possible. Thanks to the IT team who've been frantically taking your 1-minute videos and gluing them all together into our introduction reels for each panel that we're going to have all day. They've also prepared our lunchtime reel for the what you would have told your September selves if you had the chance. And also they're the ones who are managing our webinar today and making sure that it's streaming out to YouTube. Don't forget that you can share the YouTube link to family and friends so that they can follow along. And we also have this year, first year for a couple of years now, a watch party going on in Vary Hall. Some of our students have been able to come and support their colleagues in person. We've got rooms set up so that the webinar can still run and people can be participating in panels, but still come together for the first time in a couple of years to celebrate Capstone Day. Is it possible as well to share the link to the Capstone Day website in the chat just to remind everybody where they can find those links to the YouTube and so on. If you're looking for the Capstone Day website to share this with family and friends, if you go to lassonde.yorku.ca and search for Capstone, the 2022 Capstone site is up there, and that will allow you to share that information. It gives you the link to the Civil 4000 YouTube link as well. And then at the York-wide level, if you go to yorku.ca/capstone, you'll find information on how to find out about the YCN Capstone Day as well. And as I say, all three of those are running all day today at different times. And if you do want to drop into those other sessions, that would be great. But we have a full packed session here in the ENG 4000 room. As I mentioned earlier on, we have 6 panels. Our first panel will be on societal computing challenges, primarily software-focused projects. Our second panel, which will start at 9:50, is focused on space technology and the challenges that our space technology projects have been tackling. Panel 3 is really focused on medical devices and things to support patients. That starts at 10:40. Our panel 4 is looking at automotive challenges, and we have that kicking off at 11:30. Lunch with the reflection reel will be from 12:20 to 1:20. That's what we're going to try to stick to if we can keep on schedule. And then at 1:20, we kick off with panel 5, looking at environmental challenges. And our final panel of the day will kick off at 2:10. And this is looking at mechatronics and instrumentation related projects. At 3 o'clock, we will then have the judges adjourn to a judging Zoom room where we will deliberate the final judging, whilst we have our trivia session in this room. So we are hoping that some teams might participate in a team way in that trivia. It'll be a fun way to wind down. And at 3:45, we'll be kicking off the award ceremony for the Lassonde Awards, for the ENG and Civil Awards. And at 4:15, we will then, as I mentioned, transfer over to the York Capstone Network Awards Ceremony webinar. We'll point you to the link for that, and that'll be a chance to see what's happened in the campus-wide capstone. So at this point, anybody with hands up should be people who are still needing transferring into panel 1. If you are a student in panel 1, make sure you have your hand up until you become a panelist. You can then put it down. We just want to make sure that we have everybody in for panel 1. And just to give you a heads up, we've got about 10 minutes to go before we kick off. We will kick off sharp at 9 o'clock. As an introduction, our panel 1 will cover 5 teams. We have a team, console tracking team, which is supporting gaming sites where organization wants to be able to share not just traditional game consoles, but game consoles that don't have an easy software interface. They've created a mechanism for being able to control that the way they control all the other devices. We have a team focused on an AI education platform, thinking about how to improve the online learning experiences of all our students. We have a group who is proposing a webinar solution for future conferences. We haven't been able to use it this year, but it's a really interactive way of running a conference in a virtual space. Team J. We then have a group who's looking at a way to engage us differently in fitness and gym with a new way of having a virtual gym assistant. And our last team in our first panel is looking at a challenge that we may all relate to. How can we improve the public restroom experience, thinking about the challenges when we go and there is no paper towel or no toilet roll in the restroom. How can we better address that? So that's our first panel. We will be kicking off in about 8 minutes, and we'll be excited to get that going then. Any other information I need to share at this point, Claudia?
Actually, I just wanted to pop in to say, to reiterate something that Franz said, just in terms of housekeeping for the teams, just to make sure that you're renaming yourselves, if you can, by your panel. And to good luck. We have a couple more minutes. Just check on your teammates throughout the day, make sure everyone's ready. And to our panel of judges, thank you so much for donating your time today. And of course, early thank you to Franz, who is going to be with us this entire time with the screen. Thank you, thank you. And yeah, good luck. And to our audience, wherever they are.
Yeah, thanks, Claudia. And just a shout out as well to my fellow course directors, Marzia, Mojgan, and Hassam, who are busy in the background. Hassam and Mojgan are going to be running around in Very Hall, making sure that everybody who's here in person has a good experience on site. Marzia is here with me in the room all day and will be following along with the questions. And when Jane spoke earlier on about assessment, we want to assure you all that team engagement on Capstone Day always has a positive impact on grades. It never has a negative impact. So, but Marzia and I will be following along with that aspect today. So that's our side of the team. I know there are many other people I should be giving a shout out to, because Capstone Day is a thing that requires a huge number of people to make it happen. So anybody who I forgot, apologies in advance, but we really appreciate all the work that goes into making this happen. And on that note, we're still about 5 minutes out from panel 1. Just to run through some of the other highlights from the day. So panel 2, we have 6 teams. Our 6 teams on panel 2 are focused on thinking about social media platforms to engage people differently. A social network that's focused in on community, creating communities through a social network with interests initially around sports. So if I want to go for a cycle and I want to meet up with people, there's a way to make that happen. We have a group looking at how to support people in long-term care homes who may fall. How can we quickly detect anomalies around their movement? We have a team looking at how to better predict traffic in coming into campus now that we're back on campus more. Making sure that as we go about our daily routines, can we do better prediction of where the traffic bottlenecks are and how to get from A to B better. We have a team looking at how to improve our knowledge around public health data, COVID-19 data, data questions like that, papers, articles, thinking about how to share that with key stakeholders better. And we have a group looking at improving our position accuracy with smartphones. So at the minute, we often rely on smartphones to know exactly where we are, but if we want to do more precise navigation, then we can actually do better than smartphones currently do, just with algorithm improvements. In our third panel, the 5 teams in that are looking at how to improve cancer drug discovery by better automation with low-cost robotics. And so we have a number of teams who've worked on the hardware and the software for Terry Sacklos's lab, looking at ways to improve cancer drug discovery. We also have a team that's looking at detection of cannabinoids and things like that in oral fluid through a low-cost device. We have a team as well who's thought about ways to connect people in long-term care to their families through a simple device that's appropriate for those people who maybe have less ability to interact with traditional technologies. In our fourth panel, the 5 teams in panel 4 are focused on a variety of topics. We have a fuel efficiency enhancement system. So how can we take the engines that drive truck refrigeration and make them more efficient? We have some teams looking at solar vehicles, a team looking at how to keep medicines and things like that very cold, which has been a big issue in some of the COVID-19 vaccines, transporting them. And then we have a team that's been supporting our Lassonde motorsports group, designing a front suspension system, and a team looking at a different way to look at vehicle aerodynamics, recognizing that in a wind tunnel we have very clean aerodynamics, but in the real environment we have a much more complex aerodynamic flow because of the flow over it. I will go through the after lunch panels later on in the day, because we're a minute out from kicking off with panel 1. So as I get ready to hand over to the panel 1 video and then dive into our questions for panel 1, we just want to remind you that our first panel for the day, kicking off this 2021-22 Capstone Day, is on societal computing challenges. We have 5 teams: Team A, Team I, Team J, Team L, and Team Q. Console tracker, AI education platform, venue, jump for gym, and improving public restroom experience. And on that note, it is 9 o'clock. If we could roll the reel for panel 1.
We're Team A presenting Console Tracker. Gaming cafes offer access to high-end PC and console stations, where customers can purchase time to use on the machines. There's currently no way to properly manage and track time on non-PC consoles, as the kernel is locked to the outside software. Currently, workers need to manually set up consoles and tell people when their time has run out, kicking them off the console. There should be an effective way to automatically manage consoles the same way PCs can be managed. Introducing the solution Console Tracker. Console Tracker is a timer application that is able to power on and off consoles, enabling the customer to automatically pick any console in our app and begin playing instantly, tracking the amount of time a customer has used and warning them when their time gets close to running out. Once their time is over or they want to stop playing, the console turns off and the remaining time on their account is saved. Console Tracker allows us to save time for the worker and streamline the customer experience in the gaming cafe.
What is social computing? The execution of a successful project requires a complete understanding of the need for it to exist in the first place. Education has been the core of every generation, and it is constantly adapting to the changing world. So the question is, with all the available software that already exists, why do we need another one? Our project is AIM, an AI education platform. When we set out to make an education platform, we didn't want to overwhelm the system with complex features that no one wants to use. By incorporating AI into simple workflows, such as course offerings, recommendations, and student or instructor feedback, we were able to build upon the success of competing platforms while keeping our potential user base best interest in mind. Our aim is to bring students closer to the learning tools rather than spending all that time learning how to use them. And that is our solution to the social computing challenge.
After the 2020 shift to remote learning and remote work, it was no surprise that the conferencing industry took the same turn. But the biggest problem with virtual events today is that they lack a sense of organic networking and social interaction. Attendees don't feel engaged, and organizers are frustrated because of that lack of engagement. That's where we come in. We're Team J, and we hope to solve this problem with Venue, an immersive virtual platform that allows users to organize and participate in events that are equivalent to their in-person counterparts. Say goodbye to boring Zoom webinars and awkward automatic video pop-ups, because Venue is here to offer a much more authentic professional and social experience. With customized 3D spaces, live video avatars, and spatial audio, Venue creates a virtual networking experience that is immersive, engaging, and organic. Venue also offers a wide variety of room options to tailor to your unique event needs. Event spaces can be customized with promotional media from sponsors, and presenters can also host larger webinar sessions. In addition, there's space for more private conversations or coffee chats for one-on-one networking. For more information about our product, head to venueapp.ca.
Hello everyone, we are Team Q and our project is about improving public restroom experience. You may have walked into a restroom that looks something like this. Or this. We've all used public restrooms before and we believe that the overall experience can be significantly improved. We researched many different issues that negatively impact the experience of users in public restrooms. After extensive research, we chose to focus on improving maintenance. We want to tackle problems such as lack of stock, response to unpleasant events, health and safety, and overcapacity. As a group, we discussed how there's been many times we have gone into a public restroom and there was either no paper towel or hand soap available for use. We are proposing to create a system where public restrooms are constantly being monitored using sensors. This will give feedback to custodial staff with the help of an app. The custodial staff will be able to view different metrics and input feedback to keep public restrooms functioning in an orderly manner. Staff will be able to keep track of different restroom locations and respond to unpleasant events.
Thanks, panel one. So this is panel one. We've kicked off. So thank you for that. So I'm going to start with a question for each team in terms of where did you start your journey? What was the goal at the beginning of the project, and how did that evolve over the course of the project? So if I could kick off with Team A, What changes did you make as you went along on the journey? Who'd like to answer that for Team A? I will be picking on people if I don't get. Is there anybody in particular in Team A who would like to jump in on how your team evolved over time? Otherwise, I'm going to come to you, Tan, if that's okay.
Sure. I don't know if I can answer it as well as anyone else could. We've had to obviously adjust for some stuff, just I guess based on like stakeholder feedback and some. There were some things that we didn't really account for, so we had to change the direction we had to move in, and then some of the technologies as well. Sorry, I couldn't answer that as well as. Yep.
That's okay. You've kicked us off, and it's always difficult being the first. So I appreciate you for jumping in first. Thanks, Tan. So yeah, Team B, perhaps. Sorry, Team I. Perhaps you'd like to talk about what evolutions did you see over the course of the year? Who wants to jump in for Team I?
I can answer that for Team I.
Thanks, Sam.
Yeah, so the changes that we basically faced were regarding our sprint plannings. So like in the future, like in the very beginning, we try to manage our product, like how the different sprints would be for us. But as we were moving along the journey, like throughout 8 months of the journey, we see that there were a lot of changes that we need to make, and a lot of new things also that we need to incorporate as we were running different number of sprints. So like, for example, like in down the road in sprint number 5 or sprint number 6, we need to readjust for some of the changes or some of the features that we lacked. So I would say like one of the biggest changes were during the sprint plannings we were doing. So it was like a continuous changing process that we were doing throughout the journey.
And so using that agile process, you were very much to think, what do you now need to do, and re-emphasizing as you went through it. Great, thanks.
Exactly.
That's great. So Team J, obviously you've built a large platform. So how did that evolve over time? What were the things that you found you needed to change from your original foresight?
Well, at the beginning, I think our main goal was to build something that we were all incredibly proud of. That was kind of our top priority as a team. So it started with all of these grandiose ideas. And we were working with a technology stack that I guess none of us or very few of us had exposure to before. So it was what started off as a lot of big, seemingly infeasible ideas eventually became a lot more feasible as we learned over the course of the past 8 months. And so I do think that working on a lot of different moving components, a lot of different subsystems, and then piecing them all together, that itself was a learning experience. And that's kind of how we built our system into what it is, one piece at a time.
Yeah, wonderful. Thanks, Julia. And that sense of having this grand scope at the beginning and having to think where are we going to actually get that real value out at the end of the day was something that a lot of teams experience. So thanks for that. Team L, what are your thoughts as you evolved your Jump for Gym platform?
Yeah, we had a similar experience, Team J, where we had a lot of ideas and it was really hard to kind of string them together. A lot of times we felt that we were really missing the mark. Different group members had different opinions. It was really hard to congeal it all together. But towards the end, specifically the last few months, we got a really good idea of what the product needed to be. And we were able to create something that I think we're proud of.
Yeah, so it took a while to all see that vision. And when you got there, you were able to sort of all come together around it. So yeah, thanks, Kasim, that's great. And finally, Team Q, I know you've had some, you had a very open-ended challenge to start with. And so how did you see that evolving over the course of the year?
Yeah, so just like you said, we started off with a very vague question of how we can improve the public restroom experience. So over time, we brainstormed ideas on our everyday experiences and came to the conclusion that we all have problems related to washroom maintenance. we all use washrooms, so we've all had problems regarding hygiene, broken toilets, stock items running out. So we managed to narrow our problem down to topics such as these ones, and then eventually over time we sort of decided on one topic, on focusing on how we can better improve the issue on stock items running out.
Great, thanks. And I'm going to come straight back to you, probably Amir or somebody else from Team Q, around for the second question. So thinking about the costs of your system, what do you think the business model or business case for a product such as yours to track materials in washrooms would look like? Where did you go in terms of thinking about the business model for it? Who wants to tackle that from Team Q? I'll be coming and picking on people. Really what we're trying to think about is knowing that you've come up with a solution for a challenge and a need. How do you see that best meeting the need, and what implementation? Is this a service offering? Is it a product? How would you see that running? So maybe I could come to Ebad, if you're open to answering that one.
We see this as a service offering. So like make it cheap, make it available so that every restroom can have it, and it satisfies all the users that use the restroom. So there's nothing in stock or anything like that.
Yeah, so really thinking about providing the equipment on a service basis where you maybe put it in place and you run the system for people so that they can get the data to run it. Okay, thank you, Ebad, for that. Team L, thinking about your platform, obviously you have the app component. Where do you see that going? I'm not going to stick with this business model question for every team, but maybe Team L, you can pick it up as well.
Yeah, I can answer that again. We were in talks with a lot of personal trainers because, I mean, before I answer your question, some background, we didn't really have, we believed we had a good understanding of what a sufficient workout is, or what a good workout is in perspective of like kinesiology or biomechanics, but we were like totally off the mark. So after speaking with personal trainers, they helped us understand what we really needed to do in order to make this workout package that we're giving you excel. And from that, conversations went to how could we incorporate live personal training? Is there any way we could use this for our clients in like a paid subscription? So where we see it going is in one place while working with personal trainers. And really, if we could have had more time and use more resources, Franz actually brought up a good point of like helping people recover from injuries, like physiotherapy, using the cameras and the microphones to detect motion and make sure people are doing things correctly, and help them get back to normal shape.
And so that idea of other business opportunities that could come out of your basic starting point is something that you've explored. Thanks for that. That's great. So over to Team J. I think with your product, obviously you've been thinking about creating virtual environments. As we're coming out of a lockdown, hopefully, I'm not wanting to jinx anything, but have you given thought as to how your business model might account for combining virtual and real activities and what that might look like? So somebody from Team J.
Yeah, I can take it. So we have thought, I'm going to use something like the Ontario University Fair as an example of one of these types of events, because it is sort of a convention, if you will. And I think we've all attended one at some point, but there is a huge market now for just whether or not it's in person. International students cannot attend an event of that size in a physical location in Toronto, or may not have the access to do so. So with a product like Venue, we would be able to now bring that real experience, that entire networking experience, to the international student community. And so with that, students would be able to meet with each other, engage with each other, meet with university recruiters and university representatives face to face, rather than just kind of watching informational videos or hopping on a Zoom call, because it's a lot less engaging and a lot of times a lot less interactive.
Yeah, so that ability to sort of blend those two spaces is something that by making it feel like the real event, having people in the real event and in the virtual event in the same way could actually work. Yeah, great. Thanks, Julia. Team I. So obviously, with your platform, it's worth thinking that there are a number of educational platforms out there, and the pieces that you're adding could be wrapped up in many ways. So how do you see your product being integrated into the educational platform space?
I can take that again. So basically, our objective was to make a website that has like the basic features of a particular learning platform, and also we have extra features, like for example, we have like many features that are unique to our website. Like for example, we have like a feedback feature, which is currently using Google's natural learning API. And it is using the feedbacks from, like, for example, 500 or 600 students that they will gonna upload for a particular class. And it will gonna give or generate a report based on it, and it will gonna provide it to the professor. So instead of like analyzing like 500 or 600 feedbacks of each and every students, professor will gonna get a report which says like how was the class doing, how was what improvement can be made. So these kind of features. And other feature is like automatic checking, which will be using again the Google's APIs. So for long answers, so once the students can upload the answer, it will be automatically checked instead of like professor going through each and every answers. So it will be another way to save some time by the professors. And also like course recommendation. So our API is pretty efficient and how to give the particular course recommendations. So we try to incorporate like a special features in our particular website. And also like in the future, we are planning to give it in form of a plugin, so that even any other website, for example, eClass, if they want to use particular feature of our website, like for example, the feedback feature, they can just directly incorporate into their website. So that's another plan that we are having. So yeah, so overall, that was our main objective here.
So really thinking about that modular functionality and making sure that you can both do plugin and have your dedicated platform as well.
Yeah.
That's great. Thanks, Samyak. And over to Team A. So the way I want to ask you this question is thinking about other markets. So you obviously started with this gaming console market. Where else could you see your console management, power management type platform being used? Have you thought about those other markets that could also benefit from a very similar system at all? Who'd like to take that from Team A? Maybe if I can come to Eric, are you game to give that one a go?
Yeah, so I think in general, we want to have like a general solution that would be like applicable to any gaming cafe, not just the one that we made it for. So like when we discussed with the stakeholder, that's like the type of approach that he wanted us to take in making it. So since we did do that, we did it so that it could be like generally used for any system that may have like different needs that specific gaming cafe may have. So like possibly one has like special features to like to add promotions or something, or maybe other ones have like different rules or such that they have to follow by. We just made it so that like it could be like adaptable to any of them.
Okay, thanks, Eric. So For the next round of questioning, I want to focus in a little bit around some of the technologies that you worked with and where you had challenges or which technologies you found really were enablers for your product. And if I could come to maybe Team J first. So earlier on, Julia, you'd mentioned that a lot of the technology was new to the team. So where did you have particular challenges? Where did you find things that really opened up this possibility of this platform that you've created?
So I can take this one.
Great, thanks, Al.
No problem. So we worked with a multitude of technologies over the lifetime of this project. Primarily, our entire development was informed by Unity, which is a game engine. A few of our team members had prior experience with Unity, but the rest of us kind of had a bit of a steep learning curve as we were working out the idiosyncrasies, if you will, of the platform itself. We did that. Some other technologies we used were we were using AWS S3, for example, for media storage, for event and user media storage. We were using PostgreSQL. In the cloud, we had a 3-tiered architecture that can scale very well using an Nginx reverse proxy. So there were a lot of moving parts. And as Julia alluded to before, one of our challenges was to sort of tie them together and make sure that the dance is perfectly choreographed and synchronized. And you know, the S3 bucket does not return a response unless it is asked for a request in the first place. Those sort of questions. But Unity itself proved to be a bit of a beast throughout our development process, but we were able to kind of wrap our hands around it and learn to work with it and its various, like I said, idiosyncrasies.
And of course, where Unity gives you that powerful 3D visualization component, and it's, you know, a really good one in class, trying to find out how to plug together the best in class type of tools is often where those challenges crop up. Thanks, Sasha. That's
absolutely
a great answer. Maybe over to Team L next. So obviously you had both computational technology and human technology issues to address, but where would you say your key computer platform issues or benefits came from in designing your platform? You'd like to take that in Team L?
Yeah, I can take that.
Thanks, Brian.
So beginning this this project, part of the project description was using a React platform for the front end. So we understood that we could choose any that we wanted, but we wanted to take the challenge of using a completely new technology that actually no one in my team had worked with. This did bring a challenge because it is a framework that everybody sort of had to delve into to understand what was going on in order to help with the project. Because our application, we created a web application, we needed a team to also work in the back end. So we chose to work with MySQL, which is not something that was taught in school. So we had to also learn ourselves. Then we had to work with Node.js for the back end. And that was something that was not taught in school. So we had people designated to learn that technology. So across the scope, it was all very new to everybody. So it was interesting because oftentimes people would have to learn something specific and then also teach it to somebody else. So you had to know the intricacies of the frameworks and the language really well in order to explain it. So I found working with these new technologies definitely helped each member of my team just to grow, and we could definitely use that experience moving forward into our careers.
Yeah, so very much sort of evidence of that resilience and that self-directed and lifelong learning skill that you've acquired over the course of your Lassonde journeys you were putting into play in this activity. Thanks, Brian. That was great. Maybe over to Team Q. So in terms of technological choices, we've had a question from the judges around some of your choices around using Google Sheets, for example, for your interface between sensors and app. where did you find technology choices were easy to make, and where did you struggle to make them, or what drove your technology decisions? Who'd like to take that from Team Q?
I can take that one. So when we first started, we had the idea of creating an app that would communicate with sensors to keep track of stock levels in washrooms. We didn't have a clear idea on how we wanted the communication to work between the sensors in our app, but our supervisor actually gave us a great idea of using a Google Sheets document to do this. So we utilized the Google Sheets API to store data that is used by our app to monitor washrooms. The API was very helpful to us because it allowed our app to communicate what was happening in the real world. When we first tried to integrate with this, we ran into numerous problems involving such as credential issues that involve users being able to access the Google Sheets, but overall it was very straightforward to use because there were many resources online. So I think one of the reasons why we decided to go with the Google Sheets API was because of how easy it was to use and because of how many resources there were online to help us out.
Okay, great. Thanks for that. So on to team, perhaps we'll come to team A next. So thinking about your choice between off-the-shelf components and the pieces that you developed yourselves, how did you go about making some of those technical decisions as to whether to use an off-the-shelf smart switch or develop your own software platform? How did that process go, and what technology work best? Who'd like to take that one for team A?
I think I can take that one.
Thanks, Chandler.
So just in terms of deciding whether we're going to use off the shelf or develop our own, I think it was really just a question of whether we had time to do it during the school year. And we figured, just considering the scope of the project, our time would be better served developing the web application part of it rather than developing the hardware for it. So that's the reason we chose to go with off the shelf. In terms of deciding between all the different smart switches that were out there, we just looked for the one that was not only the most cost effective, but it also had like an open API already existing, so we could just jump right into development.
Okay. Thanks, Chandler. I think that's again that difficult choice between where are you best spending your energies, and thinking about that timeline, I think is a key driver as well. So thanks for that. And on this question, last team, team I. So thinking about maybe the AI components, how did you select? What did you end up choosing for that? And what did that look like? Where were the challenges working with those technologies? Who wants to take that for team I? I think.
Can you guys hear me?
Yep.
I can take that question. So starting out, most of our team wasn't experienced with web development, nor have we taken any courses related to that. So a lot of the initial part was just learning about platforms and getting information. And the end goal for most of our team was to, learn different technologies that we can probably apply in the real world after we graduate. So the primary things we came up with for our front end was React, and for our back end, we're going to use Node. And for our database, we're going to use MySQL just to get the base working on. And then as we later on, as we came up with more ideas to implement for our website, such as the feedback feature, we also made use of Google's natural learning API to be able to integrate that into which was pretty easy to do with Node for our project and get feedback that way. But the biggest challenge in this part was learning how to use it and how to make it all work together. Because like I said, most of our team wasn't experienced with any sort of web development. But yeah, so learning was the main part that took up the first quite a bit of time of the year.
Yeah, I think that's a common thread across all the teams, that even though you're coming to the end of your studies, that doesn't mean that the opportunity to engage with new tools, new learning, especially in a tool-rich environment like software development. This was your real opportunity to try out some of those tools that you're hoping to carry into your careers and that you hadn't had the chance to work with before. Thanks for that, Jahal. Great. So the next round of questioning is really wanting to focus in on your project management styles and what worked for you and what didn't. And whilst you're all primarily software groups, you didn't all follow an agile approach. We had a few different approaches in the room. So maybe if you could each share what project management style you applied and what your main takeaways from that project management style were. So I'll kick this round off with Team A. If somebody from Team A wants to pick this one up, maybe come to you, Diggin, if that works.
Yeah, can you hear me?
Yep.
Okay. Yeah, so we decided to stick with agile-based learning, I guess, or programming. So what we saw work best for us was like weekly sprints and kind of just like quick 1 week sprints of developing. We saw that like just having quick iterations of our project got the most work done, and it held the people accountable during the sprint meetings of just making sure everybody's doing something every week. It took a while to kind of get used to sprint like based developing at the start, because then most of us weren't really familiar with it. But once we got the hang of it, we really found that it helped us develop better.
And so as a team, you went for that really intensive 1 week, knowing that you're doing multiple other courses in parallel, but that 1 week pace of really keeping the pressure on to keep moving things forward every week. So thanks for that, Team A. Over to Team I.
Sorry, could you repeat the question again?
Absolutely, Joshua. So the question is, thinking about your project management style, if you could just share what your project management approach was and what you found worked well with it and where you had some struggles with it and what you'd do differently.
All right, so our main tool for project management was Trello, and we used that to assign cards to each person, assign tasks through each sprint. And with our agile methodology, it was good to work with Trello because it allowed us to be flexible with the tasks we assigned to each other. So we weren't constrained to a specific plan like we would be in Waterfall. And in each Scrum, and at the end of each sprint, we would have a reflection and talk about what tasks were left undone, what we could add to the backlog for the next sprint, and we would do that. We would repeat the process for each sprint and add it to our Trello. So yeah, that's our process for the Agile.
And where did you have any challenges in that? Did it work fairly smoothly, or what did you find maybe took a while to get used to?
I think it was fairly smooth. Like Trello was very easy to get a hold of, but as for any difficulties, I think I can't think of any difficulties we had with Trello.
Right.
It was very intuitive how to use Trello. So yeah.
Wonderful. Okay, thanks, Joshua. So over to Team J. So you, I think, are the only group in this team in this group who chose a waterfall project management approach. So maybe if you want to share your rationale and what worked well for you and what you perhaps would do differently. Who wants to jump in for Team J?
I can take that one. So we are a little bit unconventional. We did decide to follow a waterfall approach. And the reason being because this was such a big system, we really wanted to drill down our requirements right off the bat. We wanted to make sure that we had our needs were all aligned. We talked to our stakeholders, all of that fun stuff. And we spent a lot of time designing the system and all of its subsystems. And I think that was extremely beneficial for us because there were so many different subsystems and so many moving components that we were working on in parallel. So it was really crucial for the team to be on the same page right from the start. Rather than kind of iterating in sprints, we wanted to have a clear goal and a clear path. We did use dashboarding tools. We used ZenHub to track our tickets and assign tickets to everybody, to track our backlog. We still followed that sort of organization. But yeah, in terms of challenges, I would say the only thing that panicked us a little bit was the fact that all of these other software groups were building something right from the start, whereas we didn't start developing until January. So we built our entire system in 3 months, basically. But because we spent so much time on designing the system so thoroughly at the beginning, that 3 months, we were efficient in those 3 months.
Yeah, and knowing the complexity of what you were trying to build, having one of the risks with Agile is being pulled in different directions as you go through the process. And so you really wanted to pin that down before you actually went and did that intensive development cycle. Yeah, great.
And there were so many different directions to go for each of the subsystems. So that would have spiraled very quickly if we were to try them all out.
Yeah, great. Thanks, Julia. Great insight, I think. So, Team L, what was your experience with your project management approach, and where did it work well for you, and where was it a bit more challenging?
I'll answer that. I think our team had some issues. So a little bit of a different answer than everybody else who seems to say that it wasn't so hard or things were really smooth. It was pretty bumpy. It was very bumpy for a while. There was times where we're leaving the responsibility to individuals to just complete their tasks, and maybe some group members took it less serious than others, and they didn't get it done, or something came up in school. So actually, we found it very difficult to balance all the stuff that was happening outside of ENG 4K. But after the winter, we redid the way we did the project management. So prior to the winter, it was, hey, take a task, just get it done, no pressure. But then when January came, it said, hey, we've got 4 months to pull this off. So people need to be held more accountable. We did like surveys to get opinions on what people would like to do, and would they mind if somebody else did their task. We started introducing a point system where certain tasks would have more points, and we would tally the points up at the end of the semester. And those two things combined, I think, got people like a little flame under their seat, got them to actually start working. And then the ball just started rolling. Once it went downhill, it did not stop.
Great. So a lot of that was really around, team dynamics as well, which is a really key part of, project management. So understanding how the project management interfaces with the dynamics of the way the team works. So you did some great reflection on that from the sounds of things, Kasim. Great, thanks for that. And last on this, Team Q. So thinking about the ways in which the Agile process worked well for you, or challenges that you had with it. Who'd like to jump in on that for Team Q?
So I can answer this one. First of all, I would like to say that we've also had our ups and downs. Our project, we actually used the waterfall approach. So in the beginning, the first semester, we kind of worked fully as a group to just come up with a solution for our problem. But later we decided that it would be best if we could work in two different groups. A group would handle a software component and a group would handle the hardware component of our project. We found that worked a little bit better just because we've had a mix of software engineers, electrical engineers, and computer engineers. And then once we divided up the work, we started working a lot better that way.
Yeah.
Also, keeping up with the tasks, what we did is we just had to keep consistent meetings. Like we would meet up twice a week, just to make sure that everybody was following up and keeping track of their tasks and performing well. So yeah, overall, I think we did a good job just breaking up all the tasks and getting our stuff done. I know everybody towards the end just kind of had to push through, but yeah.
Yeah, thanks Raga. And a bit like Team J, where the challenge was a big product, you had a vague definition. So trying to pin down exactly what it was that you were trying to do, that waterfall approach probably was something that helped you tease through that idea and work out what it was that you needed to build. So Thanks for that. So we getting close to probably our last round. We might be able to squeeze in one quick one after this, but in this next round, I'd like you to think about the legacy, the impact of your project, what you are hoping that might be, whether it's individual for your team or for the product and for society, what you would like the world to know about your capstone experience or your project that you haven't had a chance to talk about. So for this, I'm going to start with Team I. So what would you like to share about the legacy that you hope your product has, or your capstone experience? Who wants to take that for Team I?
Yeah, so I can answer that.
Thanks, Samuel.
So basically, the legacy that our project that we are aiming for is to have our website implemented and some of the, like any of the university's learning platform, or either they can use our features, like the unique features that we have into their website to help professors and the students both to improve their learning platform more. So yeah, so one of the other things, like for example at U of T as well, so they have like a particular website developed which have some of the features that their students developed. So our aim is to have it done for the York University as well in the future, if we get a chance to have our website incorporated or some of the features taken from our website, if not entire website. So that's our aim. And also if any other university we can approach to who would like to take our projects into our into our features.
Great, thanks, Samyak. So that's a call to the audience. If anybody in the audience is interested in following up with Team I, Samyak's given you the call, reach out. Thank you. If I could come to Team A next, what would you like to share with the audience? What's the value that you see you'd like to leave the world? Who'd like to take that for Team A? Maybe if I could come back to you, Tan, on that question.
Sure. So I guess the thing about our project is it's not meant to be particularly flashy, to be flashy, to be noticeable. It's really an add-on to like an overall system. So as long as we work well and the system that our stakeholder is developing, sees the benefit to this thing, then it's all good for us, I believe.
Yeah, you want to have that quiet, efficient solution to the need without having to be seen as front and center. Is that fair?
Yes, much better put.
No, well put yourself. So thank you for that, Tan. Maybe over to Team L. What would you want your legacy to look like? Jump for Jim.
Yeah, I guess the dream product that we sort of had was a way to allow people to get the best advice to work out anywhere they are, whether they're in the gym or at home. So we really wanted to cater to people's fitness, staying in shape, especially during the pandemic, when it was especially a little more difficult. So our legacy, I guess, we want to leave just a good platform, an easy platform to use to sort of help people, because fitness is very important, not just for your physical well-being, but also for your mental health. It has a lot of benefits. So we just sort of wanted to create a product to help people grow in as many aspects of their lives that we can help.
I think that's a wonderful vision, Brian, and I think that your product is achieving that. It's that's the snowball effect that you're looking for. So I wish you that snowball effect. Thank you. Team Q, what would the legacy you'd like to see be?
I think I can answer this, and probably somebody else can jump in and also talk a little bit more. But I think for us, we really wanted to see like a change in the washroom experience, just because we've all had experiences like this. And because in a time like this pandemic, it is hard. Like sometimes we feel nervous just being in a public restroom, and I think everybody can relate to that. We wanted to do something that would make a difference, but also because we've had stakeholder meetings with custodial staff at York, and we've been validated. We felt validated just because they told us that they've had a try to implement similar solutions to ours in the past that have kind of failed. So we kind of use that as motivation to try to figure out something that would improve the past solutions that they've tried to implement. Yeah.
Great, thanks, Raga. Better washroom experience for all, I think, would be something that we can all appreciate. We're running a little short on time, but I do want to give the last word on this panel to Team J. So what is the legacy that you'd like to leave the world?
Well, I think the goal is to definitely continue with this project after Capstone. If it could turn into a startup, that would be awesome. But with Venue, we're really trying to address a niche that's not currently served well by Zoom. We're not trying to be the next Zoom. We don't want to be a webinar platform. We're much more tailored to networking events. We want to give an actual experience, not so much a video call. But yeah, I think definitely in the future, we're hoping to get there. And fun fact, all the big major event platforms that exist today are American. So if we could be the biggest Canadian virtual events platform, that would be a huge plus as well.
That's a wonderful call out as well, Julia. And again, people interested in Team J, they've shared in their video, their materials, how to get hold of them. Do reach out to them. They would definitely be keen to hear from the sounds things. So thank you for that. We have come to the end of our first panel. So just to let you know, we will now need a few things to happen. Firstly, thank you hugely to panel one for that. That was a great start to the day, and we really appreciated your inputs. Secondly, if we could have panel two folks raise your hand so we can quickly do the transition from panel one to panel two. And we are going to put up a quick poll for the best presentation in panel one. If all the attendees can vote on your favorite team presentation for panel one, that would be great. And on that note, huge thanks again to panel one, to team A, console tracker, to team I, our AI education platform AIM, to team J, Venue, to team L, Jump for Gym, and to team Q, improving public restroom experience. And we will get started with panel two in just a minute. So if we can quickly swap people over, that would be great. Don't forget to rename yourselves with your team name, panel and team name, so that we've got all the panelists lined up well. And don't forget, if you're in the audience, to vote on your favorite team presentation from panel one. So the poll should be up, and we will get started on panel two momentarily. You've got a few seconds left for voting on panel one. And we are now ready to close the vote on panel one, and it is time to roll the reel for panel two.
When it comes to social media, there's hundreds, if not thousands of options out there. There's social media for just about everything. But after doing a bit of research online, however, we found there wasn't really any social media for socially inept users, which is why we decided to create Icebreaker. Icebreaker is a new social platform that focuses on connecting users based on their interests and preferences. We utilize a machine learning algorithm that clusters users together based on their common interests, focusing on quality. We also use web scraping to gather news based on interests so that with the click of a button, you'll always have something to talk about. We also decide to integrate natural language processing, more specifically emotion analysis, through the usage of a daily questionnaire, so that we can help determine your mood and communicate this to those who you're talking to. We hope to help you break the ice with your matches when you sign up for Icebreaker. Thanks for listening.
Welcome to Radar, the new social platform to meet people in curated active sports communities. We built Radar when we recognized the problem of finding people to share those meaningful parts of your life with. Now, let's hear from some of our potential users and see what problems they're facing.
It's really hard to find people with the same goals and intensity that you're working at. There's nowhere to actually find them. I don't know where to go.
I want to find more women to bike with, but I usually find too many creeps on Facebook.
So, as you can see, we found different problems but with the same root cause. Current platforms don't provide a fast and easy experience to find the people you're looking for. Thus, we made Radar. Using Radar is as simple as making an account, entering an invite code, creating your profile, and then you can start connecting. So, say goodbye to creeps on Facebook, awkward meetup groups, and useless matches on swiping apps. Say hello to Radar and start finding your people now. You can download Radar today at radar.coffee.
How to construct a surveillance system while protecting clients' privacy, how to ensure live data anomaly detection. We collect data, apply random forest, and we build a web application to address this problem. Here is our user interface. After registration, our system allows us to connect to the user's cell phone and collect the data in real time. The surveillance page reports the information to the users. We use Fifox, which is a mobile app, to collect data. It reports users' motion data to the backend system. It also supports the multiple client surveillance, and the group behaviors can be generated. Our product will detect anomaly state based on our random forest technique. Here are the examples of the normal state and anomaly states. As you can see, there are 3 sections on our app that match 3 registered clients. Once anomaly detected, the system will report it.
A new study out today confirms what many drivers have already suspected. Toronto has one of the worst commutes in the world.
Result in 11.5 million hours of delays, drain about 22 million liters of fuel, and more costly to businesses.
Traffic's a problem we deal with personally, economically, and environmentally. Clearly, we need something to control traffic flow. Our team of 7 engineers has created a system that uses a EGCN model to take real and synthetic traffic data to predict traffic flow depending on the date and time. This will be used to give users the timeliest routes between their starting and finishing points, creating more efficient trips and reducing congestion. We are Project Nomad, and this is our capstone project.
Hi, you're probably at home with your electronic device, enjoying a variety of snacks and taking part in school from home. Surprised, I know? Well, this is because of COVID. Due to this unfortunate pandemic, students have had to switch from in-person learning to online learning, and it has impacted millions around the world. Whether it's switching to digital learning products, or even enduring internet connectivity issues, it's really been a challenge. Using resources and data sets online, our team at Digital Dev, comprised of 6 engineers, have created a solution, DataZone, for student users and for policymakers. So, if you're a student, take a look into our Wi-Fi hotspots, speed tests, and other features. And if you're a policymaker, check out our data analytics dashboard, Twitter feature, PDF extractor, and more. Visit our virtual booth to learn more.
We worked on a sub-meter position accuracy solution for smartphones. This improves the GNSS receivers in smartphones to perform higher accuracy positioning. Some examples with this improvement include immersive augmented reality video games, and better position tracking for road navigation to specify accurately exactly where you are on the road with respect to other objects like stop signs and other pedestrians. Not only does this project improve the GNSS receivers in any smartphone, but the program we developed can be applied to any satellite position technology to make more efficient use of its equipment. This will make smaller pieces of equipment have more useful applications compared to its bigger, impractical, and more expensive counterparts that you typically see in a field survey. I hope you guys are excited for what we'll show you.
Thank you, panel 2, for those introductions. Really great introduction to our next grouping. So we're thinking about social media, we're thinking about spaces and technologies to help us manage different spaces. So my question to kick off this panel is, why does the world need what you've produced? Where does that need come from? How did you discern what the need was? Those types of questions. And I'd like to start with Team AD, if you're ready to go. Who wants to jump in for Team AD on where the need for your product has come from?
Yep, so I hope you can hear me. I'm Ali, and I'll be answering the question, I guess, for our team. So basically, I mean, social media is something that we use every day. I mean, if any of you guys open up your phones right now, you'll see applications like Twitter, Instagram, maybe even some applications for meeting up with other people like Meetup. So it's sort of like a giant scope, which is what social media is. But we felt that after doing a bit of research and finding issues with social media currently, we felt that there wasn't really a niche or a product for socially in-app users. So that, for example, if a socially in-app user uses one of those applications, due to their poor social skills from before, they oftentimes don't have a great time using those applications. So that's why we felt that there was a business need for this issue. And that's why we decided to create this product, which is called Icebreaker, for that niche. We have to really take a look at what was the current really issue with social media in regards to why it was so bad for socially in-app users. And after finding our research, we came up with multiple different features in our application that sets it apart. It's not just like a one-part solution. So that's sort of the reason why we came up with the solution for socially in-app users, because social media is such a large-scale thing that we use every day, and we wanted to target these specific users as well.
Thanks, Ali. So over to Team AE. In your video, you showed some of the questioning that you'd had with the group, but how did you work out where the specific niche that you were going to tackle came from? Who wants to jump in for Team AE?
Cool. I'll jump in for our team. The main reason why we came to this problem, as you heard kind of in our trailer, was that there are definitely issues that exist when you're trying to meet people for meaningful connections. And if you consider any of the hobbies that everyone has, from sports to board games, to any other lifestyle thing like photography, it's hard to meet people outside of, Facebook groups, which are quite large, meetup groups, which are, operated by one person or a small group that have to be paid for, or you have to, end up going to places like Bumble, BFF. And none of these are adequate solutions really for being able to meet people, have meaningful connections, and share those important parts of your life. So we provide a method of community engagement for people and for the community advocates themselves to be able to engage, meet people, and develop connections that result in real outcomes rather than just chatting on an online forum.
Yeah, so thinking about that connection between the virtual and the real world and those experiences. Yeah, thanks, Al. Team B, so thinking about this technology and how you came to apply it to this particular problem space. Where did that inspiration come from, or how did you decide the world needed this technology?
Sure.
Go for it, Champion.
So there's one question. Yeah, people want to be protected under the surveillance, but they also care about their privacy issues. So we come up with that the non-visual data response time is less than 0.1 seconds. So so basically initially
unfortunately, you are breaking up a little bit.
this idea. We do some research and then we ask a couple. Yeah, okay.
Yeah.
So yeah, that
yeah,
can you hear me? Yeah.
We are struggling to hear you. It might be worth seeing if you can get a slightly stronger signal. I don't know if somebody else from Team B just wants to finish that off. We got a gist of what you were saying, but if you could get a slightly stronger connection, I think that would be good going forward. We got some of what you said though, Tianpei.
Okay. How about it now? Like, is it
slightly better?
Yes.
Let's come back to you.
It's good idea that
you're still a little bit broken up, so we'll come back to you. Thanks, Tianpei. Sorry for the signal quality. One of the challenges that we have with the online environment that some of our teams have been trying to address. Maybe I could come to Team C. Why does the world need Project Nomad?
Well, our project went through multiple iterations, and it all started from a core understanding that nobody likes traffic. I don't like traffic. You don't like traffic. I'm willing to bet all my money no one here likes it. And we thought of multiple ways about how we can apply machine learning to it. Some of them ended in dead ends, some of them not so much. And one day, from one piece of feedback from one of the course directors for our peer review, we realized that privacy is a big concern, legally, personally, and just kind of like while developing an app. So one of our teammates, Nina, had the great idea that this can be what we can give to the world. You see, traffic application and all that have been sort of in a stalemate where everyone acts like we just need more information, and realized we were stuck in that tunnel as well. So we realized something we can give to the world and to people who value their privacy is we can give you a similar type of service, but we don't want any information from you. And we hoped we can be like the first step in a mile to moving away from user data, to give people more freedom, more privacy, and you're less panicked when you press I accept terms and condition. So that's kind of like what we aimed for.
Thanks, Ahmed. It's really interesting to think about. We assume these days that our data is freely available, and actually questioning that and proposing different solutions is an interesting space in the market for sure. So thanks for that. On to Team D. So why does the world need digital dev?
So essentially, switching from in-person to online learning is something that we can all relate to, and is why we're having a virtual capstone day. So it's been a challenge and it's been tough, especially on, say, younger students, middle school, high school, etc. And it's been a tough situation for policymakers to assess as well. We decided on creating this product to create an innovative and interactive, but also convenient product for our student and policymaker users. The data offered in this pandemic situation was all over the place, and especially harder to find Ontario data, as well as Canadian data. A lot of the public data was data before COVID, and the data didn't really reflect what was going on currently. And we plan on providing real-time data using applications to extract info from, say, StatsCan, Data Ontario, and Twitter, for example. Students also face several problems in regards to connectivity issues. And within our student features, we plan on increasing access to alternative options to access adequate internet. We also offered features like our tweets feature, summary extractor, and data visualizations within our dashboard that would be helpful for policymakers. So overall, we also plan on creating dialogue and sparking change to maybe say change the curriculum or become more accommodating for students in terms of online learning.
And knowing that even though we're hopefully moving out of the sort of lockdown, impacts of this period of online learning are going to continue for many years to come. So
Yeah.
recognizing that impact as well. Yeah, great. Thanks, Ismail, for that. And for this first round, last team, Team E. So we all have GNSS receivers in our cell phones. Why do we need to get more accurate computation of our position? Who wants to take that for Team E?
I could take that. So especially with autonomous driving, it can be very expensive to implement GNSS technology within the actual vehicle and get it to decimeter level positioning. Whereas, as you previously mentioned, everyone has their own smartphone. And so by just working with the smartphones to improve the accuracy, we can transfer high positioning accuracy to many different spheres, autonomous driving, possibly for people with certain physical disabilities and navigating that, and also for augmented reality and gaming, such as Pokemon Go.
Yeah, so that step difference between, say, 10-meter accuracy and sub-meter accuracy is significant in terms of the applications that we can get to. Great, thanks, Nathan, for Team E. I now want to move into some technical questions for each of the teams. So I'm going to come straight back to you, Team E, if that's okay. If we think about the accuracy of our existing systems, what have you done to actually look at improving? What's the technological enabler that's allowed you to move on and actually create something that gets that high level accuracy? And what sort of gains are you expecting out of your work? So who'd like to take that for Team E?
I can take that again.
Thanks, Nathan.
So with our team, we were able to determine the solution based on combining more GNSS signals. So most of us are familiar with GPS, but there are also other global constellation systems, like a European one, Russian one, and a Chinese one. So by introducing more measurements that are captured by your smartphone, the receiver is better able to determine which are outliers, which are better measurements, and get a more accurate estimate of the actual position. And then we also were able to implement technology to remove outliers, so to once again drive the solution more towards the actual position. So we didn't have a hardware focus. We more developed an algorithm that more refined the actual measurements we had to toss out outliers and improve the actual estimation.
Yeah, so that multi-constellation and then really conscious thinking about your data pipeline and cleaning up the errors in the data pipeline can actually achieve significant improvement. And what sort of magnitude of improvement were you hoping to see or seeing out of your approach?
So one of the major problems with this problem was that the actual smartphone measurements were very poor just because of the quality of the receiver. So due to limitations with the project and our knowledge, we weren't able to actually work with the hardware. We were strictly working with the software. So we were able to get the meter level of accuracy, which is still fairly good. While it's not at the decimeter yet, it allows us to work more towards the decimeter level, and it definitely improved from the beginning when we started.
Great, thanks, Nathan. And maybe if I can now move on to Team D. So thinking about the different technologies that you brought to bear on this space of how do we help students and policymakers think about questions around online learning. Which technologies did you find you needed to bring to bear, and what value did they bring to the problem space? Who'd like to take that for Team D?
I can take that up.
Thanks, Christian.
So basically the technologies we used were Python's front-end and back-end framework Django. Django is utilized for both front-end and back-end. We style our site using the Bootstrap and CSS. We utilize Apex charts for visualizations due to the fact that it offers a wide variety of visuals for our user base. The user base exactly was students and policymakers, like you mentioned. For students, we built separate features such as Wi-Fi hotspot, speed test, and also showing them different speeds of common places to give them an idea in case they don't have access to internet. Our Wi-Fi hotspots feature is built in with the speeds of the locations, so students can get an idea and go to a particular location based on their needs. In terms of the policymaker, we built the Twitter feature, which extracts the tweets relevant to digital learning and shows them on our platform with also the URL of the tweet itself. The PDF summary extractor is also one of the features we worked on, which the way feature works is that we scrape Google Scholar, the PDFs from there. We extract the information, then we're using machine learning to extract a concise summary out of it. For example, if the PDF is like 100 pages, then our summary is going to be something somewhere along approximately 200 to 300 words. It's still going to be a little lengthy, but it's going to be much lesser than the original content. And this way, this can be a great tool for policymaker because they don't have to read hundreds of pages of a PDF. The other feature for our policymakers would be an interactive dashboard. The dashboard has been built, like I said, has been built using Apex charts. And the data we're pulling into the dashboard is from a wide variety of sources, including the Kaggle data that was provided to us. Some other sources include StatScan and Data.Ontario. We basically built a web scraper, a tool to extract the data real time, storing it into our database, and then using it to show to our customers.
Yeah, so thinking about for the student stakeholders, the key need of finding easily accessible, decent Wi-Fi connections and measuring that, and for the policymakers, finding the tools off the shelf that can give you the means to get in their hands the latest information, the latest data, and to visualize that. So those off-the-shelf components were selected based on their ability to do that. Great, thanks, Kasim, for that. So on to Team C. So thinking about your data, thinking about your architecture of actually analyzing and improving that. What technologies did you use, and how have they sort of helped you move forward compared to other solutions? Who'd like to take that?
I can take it.
Yeah, thanks.
So when it comes to our team, basically the way we decided is experimentation, trying out and comparing. We didn't really, because machine learning it's closer to cooking than it is to science. You never know what it's going to taste until you taste it. We tried multiple models and we evaluated their performance and how feasible they were. Our hardware was limited, so that was pretty much our two most deciding factors. It has to be feasible while still giving us the best performance. When it comes to the data set, we tried our best to have a data set that can support our main niche, which is the lack of user data. So we experimented with publicly sourced data, we experimented with simulated data, and we eventually decided to try out the simulated data just because we believe that will give us much more flexibility. Unfortunately, there was still some kinks to iron out in the final product, but we do believe it is something feasible. We're just not sure if it's feasible enough to compete with a real data set yet. So those are more or less where we stand on things.
Yeah, so even just helping policymakers know how many sample points are needed to support this type of thing is the type of capability that you've created with your simulation, and then showing how publicly sourced data can actually provide a different type of solution to the crowdsourced data is the other piece. So yeah, thanks for that, Ahmed. On to Team B. So thinking about the key technologies, and how they've helped you address this. Who would like to talk to that for Team B?
I'm going to try to, if my internet is not stable, please tell me. Yeah.
We'll give it a go.
Still, okay. It says my internet it's unstable. Can you guys hear me?
We're hearing you better than the first time, so give it a go, and if need be, we'll get one of your colleagues to jump in.
Okay, so basically, so technically, we are building a web application. So backend. So on the front end, just a simple login page with CSS and JavaScript. Backend on the server in Java language, and we also we can store the client. And then you know, for the connection, we are running on local area network, which is more easier, efficient, and safer trace, because the clients, we don't have to let the clients publish their data online, right? So basically, that's all the technical side. And the method we are using to detect it's the random forest. So basically, we run a bunch of if statement. And the reason we don't use the training data set and stuff like that, because that's not efficient to accomplish the live data collection. Yeah, that's all. Thank you.
Thanks, Tianpi. I think we again got most of that, so that was much better than the first time. And so, really thinking about security of the data, thinking about your core technology for the decision making being random forest. I wonder if you could just talk a little bit, and maybe I'll point this to Amaldev because of the audio issues. In terms of your quality of performance, in terms of detecting false positives, false negatives, I wonder if you could talk a little bit about that, Amaldev.
I believe one of my other teammates will be able to talk much detail about that. Vexon, could you please?
Yeah, I think actually Wensheng it's doing the testing. I think he's still in the waiting list. Can the host promote Wensheng?
I think he's just put his hand up possibly, so we might be able to get Wensheng in if somebody can promote them. I think they have just raised their hand in the attendee list.
Yeah. Okay. So in the meantime, I think I can answer that. So in terms of the false positive and false negative, those are the factors we try to minimize, right? So in our report, we actually have many factors. So we are doing the hyper parameter things. So we basically address the threshold that we detect the anomalies. So for instance, when the acceleration is existing about a certain amount, and if the average of our batch data it's existing certain amount, we are trying to adjust the combination of those data, and we come up with the best, not the best because they're unlimited combination, right? So we are trying to accomplish the ideal scenario that we have the minimum false positive and false negative. And then for the testing, it's very simple. We just run our system, and then we do the behavior that we are supposed to do. But there exists a bias, right? Because we are testing. For instance, me, I'm age 23 and I'm male, right? So there's definitely some bias on our testing, but that's something we can discuss, for the future work or something. Yeah.
Thanks, Tianpi, and your audio is much better, so that worked well. And we've also got Wenchuan and Jiahao in the room now, so that's great. So Team AE, obviously building a complete social media platform has a number of different moving parts. So where did you make certain technological choices, and what were the key choices that you think enabled your technology? Who wants to take that for AE?
I think I'll start off and then, some team members can pick it up based on, what their specific area was. I would say overall, you're right. Like we built a full application, which involved, creating our front end, our back end, our infrastructure, and the continuous, integration and continuous deployment pipelines to be able to, take our code, push it to servers, take our code, push it to app stores whenever changes are made. I would say that, overall, there were a lot of working parts. And one thing we were, I guess, able to learn was, how to integrate everything together, from development to production, between our client, our server, and our data repositories. And overall, I think we were able to achieve, a high degree of technical expertise, well executed, including, our development and developer operations in terms of code review and ensuring that we're pushing, code that is scalable, not going to, increase in cost as we would gain users. But perhaps maybe another team member would want to hop in, talk about either our infrastructure, our back end, or our front end. Otherwise, I think that should cover everything.
Talk more about the front end. So I was the lead of the front end team. So because we wanted to make both an app for iOS as well as Android to maximize the amount of availability for the app, we chose to use Flutter, which is a cross-platform framework, which makes it easy to develop for both iOS and Android at the same time, instead of having to develop both apps individually, which would take a lot of time. So that was another decision we made.
Thanks, Richard. Thanks, Alan. And I think that's really helpful to think about trying to get into the two key platforms. Finding that common tool that allowed you to do common development is a key enabler, I think, in that space. So thanks for that. Finally, in this round, maybe I could jump to icebreakers. So thinking about, again, your platform choices, your technological choices, where did you go? What were your challenges? What were the things that you found really helped technologically to move your project forward? Who'd like to take that for AD?
Sure, I'll take that, and then in case someone wants to jump in after, they can as well. So obviously, like with the previous group Radar, we also built an application. So there's a lot of different parts to it, the front end, back end, database, and infrastructure. I'll just talk a little bit more about some of the stuff that we created and some of our design choices behind that. So initially, we decided to create an algorithm that would match users together based on their common interests, since we found that a person has a bunch of interests, and those interests compared with another person's interest would provide a good idea of how good their match would be. So initially we had a hard-coded algorithm, but after doing testing, we realized this wasn't the right choice to go with. So we decided to integrate a machine learning algorithm that uses K clustering. So I think Brian could talk about that a little bit towards the end. So that's one of the improvements that we decided to make. I think the algorithm played a major part in our application and really solved some of the problems at hand. Along with this, another technological addition we made was adding data scraping. So a lot of the different applications we felt that are out there right now, once you're connected with the other person, you're kind of left on your own, you guys are kind of left on your own island. You guys have to come up with talking points and everything. So we wanted to kind of help the users with that, especially socially in-app users, provide them a few talking points. So to do that, we use web scraping based on their interests from multiple different websites online to gather, for example, a talking point. So let's say that a new movie came out, both these users have a common interest of a movie, it'll let them know about that new movie. Another addition we decided to add was natural language processing to the application. We felt that this was a great addition as well, because we wanted to tackle the problem of having to detect emotion. Oftentimes, I think everyone here can relate. If you're texting someone, it's really difficult sometimes to really gauge how they're feeling that day. It's really hard to detect social cues from that. So we wanted to be able to kind of figure out the user's mood before they start talking to the other person. We felt that this would enable them to be able to adjust their conversations accordingly, and so that they don't say something maybe that the other person would find offensive that day, depending on how they're feeling. So we decided to use natural language processing for this to detect the mood through usage of a daily questionnaire. So that's one of the other features we decided to add. Not to keep rambling, but another feature we also decided to add was to focus towards security. I think everybody can agree with this. There's a lot of bots, fake bots on applications like Instagram. So we wanted to kind of figure out a way to tackle this down. And though the solution is already posed, we felt that our solution added new ways of checking if the person was the person themselves. So we decided to add facial recognition into our software as well. So those are just a few of the features or technological features we decided to add to our application, which we felt really solved the problem at hand.
Okay, thanks, Billy. And that's a fairly full answer. I'll probably cut you off there. Apologies for
no problem.
Yeah, thanks. maybe you can pick up in the next round. So what I want to focus on now is thinking about unintended consequences and what you tried to do to be aware of them, or how far you got in terms of managing unintended consequences. And I'm in particular thinking of potential negative consequences to your technologies. So if I can maybe start with Team C, thinking about the traffic flow. So obviously with crowdsourced data, we might have bias in our data from where the data is collected. So I'm wondering what risks or challenges you see in your solution that you had front and center as you were developing your approach. What are the sort of practical implementation issues that you saw that you're concerned about as your project goes out into the world? Who'd like to take that for Team C?
I can take it. So when it comes to the data, excuse me, something that we were concerned about is if we are just using data that might be sourced with personalized data, did we really accomplish anything? And if the data is not scalable in a way where it would be practical for it to replace personalized data, how would we get around that? So some things we used to find those sweet spots, as I said, we were very interested in simulated data first, because if you want to gather proper real data, that's a lot of time, that's a lot of effort, it could be a lot of resources. But a simulated data, if you can create a proper simulation, you can run it on everything. So that's something we're concerned about. As I said, the results were not as good as we hoped, but we do believe there's potential there. Another thing that we considered is the amount of sensors that we'll have to employ. While we were training our model, we ran it on multiple sensors at different places and at different numbers. And we tried to see if our goal kind of like is maximum efficiency for sustainable resources, how many sensors will give us that sweet spot.
Yeah. So you're really thinking about the finding that sweet spot in terms of cost and effectiveness, and using that simulation allows you to think about where should the money be spent in the infrastructure and where are the key points, I guess. So yeah. Yeah, wonderful.
Just because otherwise then our model will be biased towards areas that do have the infrastructure, and areas that do not are just bound to that original data. So that's kind of like what we thought of. We wanted the model to be customizable for every area.
Yeah, and by having that simulation platform, you can basically do the informed decision making as to where to place things. Great, thanks, Ahmed. Sorry for cutting you short. I'm just trying to keep things.
No worries, I understand.
That's great. Maybe if I could come to Team D. So thinking about the potential for bias in data sources, or the potential for encouraging students or stakeholders in incorrect directions. What things did you take up in those questions as you developed your digital dev platform? Who'd like to take that for Team D?
I can take this question. So in regards to avoiding bias, we decided to use multiple data sets and real-time data. So in order to get a realistic picture of our past state, we use data sets available to us online in regards to information before the pandemic. And there was some information that was available in, say, 2020 to 2021. However, it was a bit more difficult to gain information from 2021 on. So using our extraction methods, we continuously obtain real-time data to explain our present state. And using these two, we tried our best to avoid bias. Also, gaining information and feedback from our stakeholders. was something that we also use to gain, say, a direct information on our current state and what's going on, since we did interview vice principals, teachers, people within school districts. We also implemented a data collector feature to gain direct input on our dashboard as a primary source of data. However, due to ethics and consent issues, we had to temporarily disable that. So those are the steps that we took to kind of avoid bias.
Thanks, Ismail. So yeah, again, recognizing having independence from any one data stream hopefully provides that increase in likelihood of avoiding some of those issues, and recognizing the ethical challenges of data collection for informing design versus data collection that could be shared in a public forum. So great, thanks. That's a good answer, Team D. Maybe on to Team B. So obviously thinking about in a care home, detecting anomalies around phone use. How have you tried to tackle questions around avoiding detecting a person who drops their phone, or a grandchild, say, that takes the phone and runs down the hall and does something? How have you tried to ensure the care anomaly system is providing valuable information to the assistants in the care space? Who'd like to take that for Team B? Maybe Jiahao or Wenhuan?
Yes, I can just take this question. So that's the case we're actually thinking about. So we first, for the instruction of the using our system, we provide a very detailed description in the product menu. So and also we would expect the technical person to actually help those elder people to set up every steps of the system. So the elder people will only have to use their phone, and to log in their system, they don't have to worry about it. The technical person would have to set up everything for them. And in the situation you just mentioned about, like, they drop their phone, or some kids just take their phone and ran all around. So this is the case we deal with in our model. We would detect some very, for example, the elder people would not like running so fast, so our model algorithm will detect such as the anomaly data, also report to the monitor system. But this will deal with the phone has dropped, or the speed are too high, so the monitor will know, oh, there's something happens, and the technical person will also go to check what happened. So they are also be recognized as an anomaly, but the report will be different.
Yeah, thanks. If I can come to Team AE on that question, thinking about one of the things in your video around people trying to avoid
creeps.
Yeah. Yep. Oh, yeah.
Yeah, absolutely. So I'll get right into it. So one of the features I actually worked to develop was a robust reporting system. So users are able to report users that they run into, either in the matching phase, the inbox, or once they've already connected. And so users can submit reports, provide reasons, and then we built out features to kind of create this chain of ownership where us as staff, or whoever would be working on this, can then respond and comment on reports, and then can as well take administrative action like disabling or re-enabling an account. And so that allows us to be able to manually intervene. Other areas that we've kind of have a bit of security also come from making sure people confirm, email or a phone number. And we've also looked at, what are other options like using like the AWS Recognize service to, make people upload a picture of their face. But, based on our, agile framework for looking at what user needs are, we felt that reporting would be adequate with the current user base. And, if there was growth, then we can move to an automated system that would help us scale user management. So it obviously is a big concern, right? Apps like Tinder have do some processing on messages before you send them and say, hey, this, might not be appropriate. Please look over your message. And, we kind of use that for inspiration. And, if we had more time, that's definitely an area we could develop in. But having a robust reporting system that we implemented is our first step to be able to manage user grievances and then be able to respond internally and then take action when needed.
Wonderful, thanks, Alan. I'll ask the same question to AD. If you can keep it concise, that would be great. I know it was a key focus, but thinking about some of your technology around celebrity checking to avoid people using images that are in the public domain, and also thinking about the tools and technologies for people who struggle with social media. How have you tried to address that? And if you could keep it concise, that would be great.
Sure, I'll just jump into it right away. So in terms of our facial recognition, that's obviously some software that we decided to propose so that we would ensure that the user is the user themselves. A lot of the checks that we put into place was we made this very strict. For example, when we labeled different objects and the person's face, we compared the verification image along with their profile picture to ensure that it's correct. We did a lot of testing along with like searching up the image on Google to ensure that it's not over there. So that's like one instance of some of the unintended consequences of our application. Another would be the natural language processing aspect, where we ask the user a questionnaire. Obviously, we need to make sure that we don't give the wrong information to the other person that they're speaking to, because this could result in ill conversations. So in that terms, we also did a bunch of testing. And what that really comes down to is that we had to compare whether we wanted to use a pre-made or a data set that we got online, or if we wanted to use something that was already pre-made to do the natural language processing, for example, on AWS Comprehend. So those are some of the different consequences to take a look at, and that's all.
Wonderful, thanks, and thanks for keeping it short. And final, the question to Team E. So thinking about the risks of your technology, how have you tried to ensure that you've addressed those sub-meter position accuracy risks in your design?
Yeah, we have thought about that, about how people feel like if people accurately know their position a lot better, feel like they have like safety concerns over that. But I feel like there's this like comfort in believing that, like, I guess if this was in like government government hands, like they wouldn't really care, I guess. Like it's not like the military is like actively like trying to find your precise location for some specific reason. I think it's just in the purpose of actually better positioning. But I would say more the concern is more with like private companies. I feel like with them we don't really know what they're doing with I guess the technology, but if it's within I guess government hands, like I feel like it'd be much more safer, because I guess we're already being watched in a certain way. I guess we just have to feel a little bit more comfortable about it.
Okay, thanks, Ryan. And some interesting interplay in this panel between, who has access to the data, who controls it, who has a say. So thanks for wrapping that up. We have come to the end of panel 2. A huge thanks to all our panel 2 panelists. If you're in panel 3, if you could raise your hand now. Melissa's already put the request in the chat. And we will kick off the poll for panel 2. Vote for your favorite team for panel 2. We will get started with panel 3 very shortly. So make sure you vote quickly. Again, huge thanks to all our panel 2 panelists, Team AD with their Icebreaker app, Team AE with Radar, Team B with the long-term care home anomaly detector, Team C, Project Nomad, Team D, the digital dev, data analysis on COVID, and Team E, the sub-meter position accuracy with smartphones. And we are at time. Thanks, Team AE, for sharing your website. And now that we're at time, if we can close panel 2. the voting for panel 2 and kick off the video for panel 3.
One eternity later.
Those conversations remained unfinished. However, not all connections are this casual. Some are much more important, like the ones with your parents, relatives, or a family member in a long-term care home. And while the waves of lockdown can keep flowing, one thing will remain constant: CareConnections. CareConnections is a digital solution that provides patients and family members with a platform to connect by providing patients a kiosk which can be navigated through a remote, allowing them to look through media and messages sent from family, call them, plan their day, and even call caregivers for help. It will also provide caregivers with a better and automated solution to store and maintain the patient information without the everyday manual hustle, and a web app for the family members to connect and see how the patients are doing from anywhere around the globe. So the next time you want to meet your loved ones, there's nothing stopping you.
Lateral flow assays, or LFAs for short, are a rapid testing method to detect the presence of a chemical compound in a liquid. You may recognize them from rapid COVID-19 antigen tests. These tests are binary, meaning they only indicate if the concentration is above or below the LFA's cutoff. Our team offers a low-cost device to quantify this concentration. Our device works using a process known as lock-in thermography. This process pulses a laser which excites gold nanoparticles in the LFA's test line. In response, they release heat, which our infrared sensor detects. After some data processing, we should see a peak in our graph directly correlating with the concentration of the compound. With this device, the resolution of every LFA increases. That means more details for field medical professionals when making their diagnoses, cheaper test results for pharmaceutical manufacturers, and easier tests for agricultural workers.
Imagine waking up feeling sick and discovering you have cancer, specifically acute myeloid leukemia, an aggressive type with a 25% survival rate that will cost tens of thousands of dollars to treat. This is the reality of approximately 60,000 individuals every year around the world. Here at York, we have an advanced stem cell engineering lab led by Terry Sacklow that is working to repurpose existing and more affordable drugs to help battle leukemia. Our team Stembotic is working to help them automate the manual process of drug screening, a task that typically requires thousands of tests to be performed on thousands of compounds, leaving a ton of room for human error. Our solution moves test plates between liquid dispensing stations. It comes with a friendly user interface that allows the user to control the experiments and keep track of the old ones. Traditional machines like this cost over $200,000, but our design runs a little under $2,000. It can also be easily adapted for other liquid handlers, giving its modularity.
Thank you, panel 3. So we have our range of videos, and we have 3 teams in this panel who've been focused in on enabling technologies for a cancer drug discovery platform. We have the Connections tool for people in care homes to communicate with their families. And we have that device to look at concentrations on those test strips that we're used to doing now for rapid COVID testing and other similar testing. So the question I'd like to kick off this panel with is around, again, that question of what is the key thing that you think you've added to the world by doing your project? So how has your project moved the world forward, moved technology forward, moved your key platform forward? And if I could start that question with Team AA, who'd like to take it up for Team AA? I'll perhaps come to Edward, if you want to take that one.
Yeah, sure. I think what we wanted to, I think kind of the work that we're doing right now is, speaks for itself in the terms of how we kind of want our work to be seen in the future. The main purpose of the ARM was to kind of help modernize and kind of make more efficient the current process in testing. So I think hopefully, that our project is able to kind of, make the waves, or maybe help maybe some group in the future kind of start to look at medicine in a more efficient and modern way.
Yeah, so it's taking that baseline platform that you had at the start of the year and thinking about how to move it to a space where it's more productive, I guess. Is that a fair summary?
Yeah.
Yeah, okay, thanks, Edward. And thanks for being our first panelist to answer for this panel. Team AB, thinking about your addition to this baseline platform, what was the key thing that you've tried to enable for this capability?
Yeah, so we've been kind of wrestling with what our identity as a team is and what addition that we have on a previous capstone project. So just to recap a little bit, 2 years ago, Spencer, a high throughput screening system was made by a capstone team. And this is to help the drug discovery process. Our addition is actually not just putting a wrapper of software on top of Spencer, but making software to basically democratize healthcare research. So if you want to build your own electromechanical system that supports high throughput screening, you can use our software. This enables hospitals, universities, low-funded academic institutions to also enter into the drug discovery game and not just restricted to big pharma companies.
Yeah, so recognizing the original project was primarily focused on mechanical components, you've really moved that software component fully forward, and then recognizing that as a key enabler for that low-cost entry into the space. Thanks, Ruben. Team W, what's your key addition to the world?
So I can take that. So basically, I would say initially, so everybody uses WhatsApp, everybody uses all the social media, but we know like the senior people, they don't. because they don't feel so comfortable with the technology. But we want to make sure that they're still able to use all the tools. So we created a kiosk. So now with the remote, it's easier to see, it's easier to understand what's happening. And at the same time, they can get the benefits of the technology. Similarly, now that the COVID hit, people couldn't come and meet their families. And now the point is, like, you can sit anywhere in the world and you don't need to be worried about your parents. For instance, for me, I can see my grandparents with a camera and see how they're doing in India. So we wanted to have that aspect, that the technology connects you from anywhere. Along with that, we also talked to some nurses, and people told us how they're still manually doing all the things, like keeping records and logs. And it's really hard now that they can't have volunteers inside, so the caregivers have a lot of work. So with this logs and having everything automated, everybody, all the doctors, all the physicians, and the family can see how the patients are doing. So I think adding these key elements and just using basic things that we have and making it easier and accessible to people who didn't use technology that much, that is our key addition.
Yep, and just to add on to that is that our solution is more like one thing that provides all the benefits in one package. It's like multiple things combined together, integrated properly, such that it gives everything that you need at your hand, be it from logging to connecting with your family members or video calling, or, it can be something as minuscule as giving them a reminder of what their family feels like with them, or giving them reminders of their family members and their memories. So it's like a combined solution that matches all these different things that you would have to have a dedicated product for each of them. Now you just have one solution that's going to do all for you, for especially family members, while also being, very user-friendly, especially for the elderly and the patients who have dementia.
Thanks, Niharika and Yash. And I think we can all relate, in the last couple of years, access to people in care homes has been challenging. And for a number of us, the international dimension is one that is an ongoing dimension. So there's value in both of those. And then the, capturing those records and sharing them is really important as well. So Team X, thinking about, we've all been through doing lateral flow tests for a while now. What's the key enabler, do you think, of your technology? What does the world gain from having this type of technology to actually do the analysis?
Right. So in terms of like lateral flow assays, worldwide, I believe the market for them in 2021 was $7.9 billion. So obviously there's a ton of these tests, and they test for a wide range of things, not just COVID-19. The one that we were testing was THC in saliva, pregnancy tests. They're used in a lot of field medical applications. And the benefit that our team really provides is, instead of just getting a binary, either positive or negative response, we're able to, through our device, actually spit out a number or a better estimate of exactly what the concentration is in that fluid. So if you can imagine all of those $7.9 billion worth of tests, and the data that you're able to get out of every one of those tests is now more precise, it's more accurate, it's more resolute. So we see a huge value added through just, and also to keep in mind that there's no change that has to happen with the lateral flow assay itself. It's just the way we interpret it. The data has always existed. We've just found a way to extract it, or improved on a way to extract it.
Yeah, and providing that rapid way to actually get the accurate information and actually change our way of interpreting the data, rather than just seeing that single line, actually determining the strengths and things like that is something that could move the technology on. So great. Yeah, thanks Derek. And so on to Team Z. So again, thinking back to this Spencer platform, what would you say is the key core functionality that you've enabled and added through your project? You'd like to take that for Team Z?
I think I can answer that.
Yeah, go for it.
The main functionality of our project that we've added onto Spencer is, again, automation. So instead of having a human or a lab technician moving test plates from somewhere to Spencer, we have created a robotic arm that can take the plate and move it onto Spencer. And all the user has to do is input the position of the liquid station that the plate needs to be moved onto.
Yeah, so in terms of accelerating the mass throughput, this is a significant move forward into a lot more mass throughput of the system. Great, thanks,
Exactly.
thanks, Peter. Round two, what I'd like to focus in on is some of your technology choices. So in each of your projects, you've chosen to buy off-the-shelf parts or build your own, PCBs or code. And so, what decisions drove you to a particular choice? And thinking about, if you could just describe the key technologies that you've created or that you've bought off the shelf, and how those two relate. So I'm going to come straight back to Team Z. So thinking about the core technologies that you've added, how much of it was off-the-shelf components, and where did you go in terms of building your own hardware or PCBs or code? Who'd like to take that for Team Z? Mustafa?
Yep, I can take that. So basically, we try to use off-the-shelf components and open source projects wherever possible, because they're usually kind of like battle tested, and the open source community is great and is very valuable to use their contributions as well as contribute back to them. And there are some places where we kind of like made our own custom thing, and that was for like a variety of reasons. For example, for our project, we had a fully custom PCB that integrated off-the-shelf modules like stepper drivers, because we felt like it struck the best balance between having to do everything from scratch and having like kind of the flexibility of having everything on one like compact module, where all the user has to do is put things in, right? Let's say if a stepper driver fails, all you got to do is go on Amazon or similar website and then purchase the stepper driver again, place it in there, and it should just work out of the box. So that's kind of like the decision that we made when it came to choosing whether or not to use an off-the-shelf part or making it our own. We generally chose going off the shelf, but we valued having the flexibility of also like having our own kind of solution that works the best. And we kind of made a compromise between the two before making our decision.
So you've got that sort of PCB as the integration piece, which allowed plug-in off-the-shelf components, which makes the end use of swap out and so on easy. And as you said, you're focused in on where's the fault, the devices are robust, the connections are the weak point, and that's where you've focused your energy on PCB. Great, thanks. Thanks, Mustafa. Team X, obviously you've got a relatively expensive system design. So where did you choose, a lot cheaper than it could have been, but where did you choose technologies off the shelf versus designing your own?
Well, actually, almost everything we've done has been off the shelf, with the exception of the casing, which was 3D printed by one of our members. And there are two main reasons for that. Number one, we just don't have the expertise and the time and the resources. I mean, we're not here to build a laser diode or to build like a small PCB to have like an IR sensor. That's not our interest. So that's number one. And number two is that we're here to build a low cost kind of handheld sensor. So the interest was to show that, hey, with currently commercially available products, right, they already exist, the manufacturing infrastructure is already there. We can take those, put them together and get good results out of that. And so buying off the shelf and showing that the price tag is reasonable. I think for our single bar device, it's around $200. That was a really important part of our project. So that's why we went this route.
Yeah, thanks, Alex. So again, that proof of concept, thinking about the skills within the team, that systems expertise, and demonstrating what can be done with existing technology rather than thinking about the perfect longer term design would be a more integrated one. Okay, thanks for that, Team X. Team W. Yeah, go for it, Yash.
Sorry, I'd like to take that on. So there were a few design choices that we made, starting off with using the Raspberry Pi as our system that will be running our kiosk solution. One of the biggest reasons for choosing something like a Raspberry Pi is it's not a very small scale product that's just used for just the kiosk purposes. The extensibility of a Raspberry Pi goes beyond just the kiosk scale. At a later date, if they're not comfortable with just using our software, they can always choose to remove the software and use the Raspberry Pi as a computing system as its own. It's very capable of surfing. So it's got that future-proof ability where, the consumers are not only paying for the product as is, and once they don't have a use for it, it's going to be useless. There's that future-proof ability from the consumer's point of view. Another thing is that one of the design choices for when building, technologies, when building the website, is we use the React framework. It is something along the logic of reinventing the wheel. We can always write our own HTML, CSS, and JavaScripts to build our own website from scratch. But that not only takes away lots of development time, but also many times introduces more bugs. This is a tested solution that's out there already. We can, build atop it, which will help us create better and focus more time on user friendliness and user preferability over something like reinventing the wheel. So those are one of the two main choices that we've taken. One of the final things that we've used is that we've used arcade buttons. One of the biggest things is that Raspberry Pi, again, it comes down to that it is very capable enough of handling modularity. One of the button fails, you can always remove it, add another button, and it will work just fine. It's got Bluetooth support, which will allow us to, in future, someday be able to allow for wireless remotes for the family members and long-term residents. So it's got way too much, higher scope, everything to build a top on it, and it's got the capable power enough while not being too expensive, so that the end consumer can still work. One of the last things that we worked by ourselves with was the video calling feature. We decided on working from scratch on it because most of the times the technologies that we use wouldn't allow us the restrictness that we want to provide, for someone like a resident of long-term care who might not be tech savvy. If it opens a Zoom link for them, they might not know how to get out of the Zoom link. It might be messy. Sometimes it goes out of focus. It can have a lot of repercussions, for which we decided to build our own video calling system, which runs on the software application itself and is able to make the communication possible. So that was mostly our choices with technology.
Great, thanks, Yash. A very full answer. And thinking about the robustness of the off-the-shelf solutions versus the where you wanted to actually make those improvements. So yeah, great, thanks. So for Team AB, again, thinking about the software components, where did you go off the shelf and where did you end up needing to develop your own?
Yeah, I mean, that kind of leads into a little bit of an interesting story. Our system is essentially three main software components. It's a front end that creates actions such as homing the device and calibrating it, using the device, dispensing liquid. Then there's a queue. Those actions are added to the queue, and this queue gets popped up. The items on this queue get popped up one by one and get handled by the actual electromechanical system. Now, we send these actions over Wi-Fi. That was our wireless choice of how we chose to send actions from the machine from the interface to the machine. Now, Johnny's basement, where the machine is actually kept, doesn't have the best Wi-Fi, at least at the time that we were originally building this machine, meaning that we had to architect and build for robustness and durability from the get-go, just because of the environment that we were in. So we found that if we were to self-host the queue broker, we found that we couldn't guarantee service level agreements and uptime. We would have to be responsible for that. And after we leave, and another team or club or Professor Sacklos has to manage this thing, they are responsible for that. And I don't know if Professor wants to hire like a 4-man infrastructure team to keep running this after we're gone. So instead, we chose to use a managed public service for a lot of our cloud services that we were leveraging.
Great. Yeah. So thinking A, of the environment, which was a great benefit in terms of building a robust solution, because you had the challenges right off in your test environment. And then thinking about that long-term maintainability, supportability, and so on. So thanks for that, Ruben. And Team AA, how did you make your choices between the off-the-shelf and self-built components?
So may I answer? So basically, from the start, we were planning to machine our linear actuators, but our designs were not bad, but we realized that if we want to have good accuracy and good precision, we cannot really depend on that, since machine shop was not available back then. And that's why we bought our linear actuators off the shelf. But since our gripper was custom, we had to make some internal parts, and some of them had to be precise and accurate. Some of them were not really that important. They were just an interface between the other components. So we used the combination of 3D printed parts and some off-the-shelf components in our gripper, and we bought our actuators from various websites. And so we just needed small machining to set the length for our actuators. And our gripper, since it was quite detailed, we had to make 4 prototypes. Initially, we started by 3D printing. Therefore, we could test 4 times on our gripper and finally get the good design out of it by combining it with some other off-the-shelf components, such as strong pins that had to transfer the force to the other components. And yeah, that's it.
Thanks. And just to check, you're actually in Team V, is that correct?
That's the thing. I couldn't find the link Claudia sent me. I'm Sina, by the way. So I used my friend's name,
Okay.
so to check in.
Just to avoid the confusion, so you are genuinely a part of Team AA. So
yes.
thanks for that. And just to clarify that for folks in the room. So what I'd like to move on to is talking about the project management for this group, where most of you are following a waterfall-based approach, but we have at least one team, possibly, yeah, who was following an agile project management. So thinking about what you found most beneficial or most surprising or most challenging with the waterfall approach to managing your projects, what were the key things that you noticed? And if I could start with Team W on this one, how did the project management run for you as a team?
So for us, we used Agile. So what we did is we try to follow what we have done in the industry, so following the whole Scrum. And the way it worked is we first of all bought Jira. So we paid for Jira, and that's the software that we use at work. So our idea was that once we go out of the capstone, everybody should be ready for work, and they should, people who don't have experience with co-op, they should know how this works, and it should become a normal. So we would have our scrums every Monday, Wednesday, Friday. We would do retrospectives, we would do demos, and then, for example, me and Yash, we were the project managers. So we were also the ones who were the product owners and kind of understanding our stakeholders' needs, doing those meetings, getting the requirements, and then coming back to the team with that. So I think the difficult part was that finding time for everything, making sure we actually follow along all the steps that we decided on, even though school got hectic. I think something interesting and something fun we did is that we gave our team breaks. So for example, if it's a winter break, if it's an exam time, we would give everybody a week off. We would delay a sprint, or we would shrink the sprint or make it longer to help the team. And then everybody was very feasible. For instance, if I have a lot of midterms happening, I will tell somebody else and they're going to take up my stories. And then next week when they're busy, I will take it. So I think that balance and kind of understanding the team and learning from the demos and seeing what the problems are,
following the testing, having a QA person, having somebody review, like following that whole procedure really helped us. And I think, Yash, you have something interesting as well you want to share, so go ahead.
Yeah, definitely. So, on top of just having project managers, we decided on having both sides, getting opinions on who wants to play what role. Me and Neha obviously wanted to be project managers because that is something that aligns with our career goals. And the other team members wanted to, be the people working on development side. So we tried to have a proper balance, even as a project managers, we're going to be facing situations where we had to accommodate for times for our team members who will be working on the project. So that is something that we also get experience on. One of the great things is that me and Neha, we both have had experience working at co-ops, fortunately enough, and we've learned how using industry tools like Jira and Bitbucket is something that's going to go a long way. I've personally been interviewing a few places right now, and I also already see so many companies trying to come up to us that, oh, you guys are using Jira and Bitbucket. It's a little bit of an overkill, but it also provides the team and us a great perspective on how the real life work would be. And especially the environment that we have set up at our team is sort of like a startup environment that, a startup company would have, we would definitely have developers, but they would also have to pick up some other tasks, sometimes working on finances or such. So everyone gets lots of variety of roles while also getting the chance to work on the specific items that they want to work on, being a developer or a project manager specifically. So that was one of the things that we aimed for as well.
Great, thanks, Niharika. Thanks, Yash. Maybe over to Team X. What was your experience with the project management, and what worked well, and where did you see some challenges?
I feel like we learned a lot about project management as a subject over the course of this project. We began following the waterfall sort of procedure. So we made up our work breakdown structure, we made our Gantt charts, and we sort of had an idea of how the entire duration of the year was going to look. But very quickly, and fortunately, we were able to achieve the results we were hoping for by the end very early on just because of the testing we were doing. Things happened to go really well, which kind of left us in a lurch because we've prepared this whole schedule for the whole year. So we decided at that point to somewhat transition to more of an agile style. And in that we would perform tests, we would analyze the results, and then based on those results, we would change the configuration of our test rig. And just iteratively over the rest of the year, we changed, and we basically wanted to see how much performance we could squeeze out of this technology over the duration of the year. In retrospect, I believe we found that was called a rolling wave style of management, which I think if we had started with that, knowing what we know now, that's probably what we would have gone with. But nonetheless, we learned a lot about the waterfall style of management. And we also had a team dynamic where we didn't as much require, say, one of us to be a team leader, making sure that everyone is doing the things that they need to be doing. We were all had a lot of faith in each other to continue working on the things that needed to get done. And because of the way that we had a great team dynamic, and it turned out really well for this type of project, or experimental type of project, I guess.
Yeah, where it was a somewhat research focused in that latter part and so on, that was where that rolling wave was good. And as a larger team, because of that good team dynamic, it was almost able to be run as a smaller team process. So yeah. Thanks, Derek. Perhaps Team Z, what was your experience with the project management?
Yeah, so for Team Z, we knew that our project was very involved and important to organize the execution phase. So we dealt with this by really planning on in the fall semester and dealing with the user needs and the requirements early on, and then outlining what will be done in the winter term. In addition to that, we had a lot of foresight. So we knew that we had to, a lot of our linear actuators would be ordered and bought out. So we planned that ahead of time, and we made that, we ordered it before winter break. So that way we can have all of those shipped and we can start early on in January. So that was really beneficial. So I would say having that foresight, having those Gantt charts and that all of those schedules built out ahead of time. So that way we can assign roles to each team member and get that work done ahead of time and not fall back behind. That was very important. And that's, I guess, what made our project successful. In addition to that, we also created like a risk allocation matrix. So I think that that showed a lot of details in terms of what specific tasks everyone was doing and were assigned to. So that was important for our project.
Great, thanks, Julia. So as a waterfall team, having that structure to give you the ability to do that long lead item ordering early and making sure you managed the tasks and pinned it down well, worked well for you.
Yeah.
Great, thanks, Julia. So on to team AB. So as you know, the other software heavy group, what was your experience with the project management?
We had a really interesting experience for our project management. We began, since we're all friends, we all kind of trust each other, have that like trust that we would be able to complete our parts. But we realized quickly, like really quickly, that Jira just didn't work for us. Jira was very hard to, the idea of just logging into Jira made us all upset, and it made us not want to work. So it was, I think we just weren't able to, as a small team, work on Jira with all the complicated like different parts and movement and stuff of Jira. So we moved to Linear, which is a little bit more modern, and I think met our needs in terms of like the integration with GitHub. So being able to automatically just move our tasks from to do to all the way into done just through pushing our pull requests and all that stuff. So that made it easier for us. Being able to see our cycle effort graph, so our efforts being like how difficult a task was. So being able to see that every cycle helped us keep on track. And we noticed when we were started lacking on our tasks, we noticed when the graph would go down. We're like, okay, guys, like, hey, we need to come back, regroup, figure out why this has happened. We've also had every 2 days we'd have stand-ups. We first started off asynchronously, realized that didn't work, so we moved to synchronous 2-day stand-ups, which really helped. And then we'd have our retrospectives after every cycle to kind of like catch up, see like what's done, what needs to be done, especially since our one mechanical engineer kind of had no idea what was happening software-wise. So we had to kind of meet up and be like, okay, so here's what happened in like layman terms, what happened with the software, and tell us in layman terms what happened with the mechanical. And it was I think once we switched over to Linear, we kind of got ourselves together and figured out and got more organized, meeting with our stakeholders and everything.
Thanks, Nuran. As an Agile team, I remember that moment when you discovered Linear, and it was a huge step forward for you. So, and I think you've shared a lot of those things, that finding the right solution tailored to the team is really important. And it sounds like you certainly got there. You found those tools that worked well for you as a group. So, wonderful, thanks. And Team AA, what were your thoughts on project management?
So our project management was quite bad from the start, because we had a design which was a bit optimistic, and after a few meetings with the TA and other groups, we realized that it wasn't working. I mean, in simulation it might have worked, but in reality it couldn't have worked. So we changed it quite late. It was in December, and because of that, our plans shifted a little bit to the back. And so, but fortunately, we could fix that to some extent. Our initial design was done back in January, and we had to fix it like 3 or 4 times in order to get the good response we wanted out of it. So that really impacted our project management, but we had other people as well. They were working simultaneously on other parts. So we could progress in some parts earlier than we thought, and some of the parts could not be done as we hoped. So fortunately, from the very start, we predicted that this might happen. So we had some amount of time that we could give it to any failures or any thing that was unprecedented.
Yeah, so ensuring that you had sufficient slack in your schedule up front was really important to guarantee that success at the back end when the inevitable problems do crop up. And you know, a capstone team that hasn't had problems is a non-existent capstone team, I think. So yeah, no, thanks, Tina.
That's the sorry if I may add. That's really important, because we while we were doing the project, we also learned more about the project management. In mini designs, we had some smaller projects, and this waterfall format that we used, we had some ideas, but we were not really good at it. So it was really important to do one stage and go back and redo it. And we had some requirements, and we had to go back and redefine our requirements. And that was really helpful, not for the projects, but also learning for other projects that might happen in future.
Huge. And, you know, that's the hope for Capstone, that it's that safe space to actually learn the process of actually doing the project work. So yeah, no, thanks for that, Sina. That's really helpful. So the next round of questions is focused on, so what next? So you've got to the end of this project. What are the next steps that you would like the project to take? How are you hoping to take them up? And I'm going to start with the three teams that were working on evolutions for Spencer, because obviously you took a project that had reached a certain stage and you've tried to move it forward. So what's your hope for what you've moved on in terms of what the next additions to the Spencer platform could be? So if I could maybe come to team AA first on this one.
Sure, if I may take this one. We hope for the next step that our product, we hope that the software side gets implemented a bit better. We were struggling from the software side, as mostly we were just electricals and mechanical students. Yeah, we'd like to see some modular design in terms of an interactive UI for the end users. So whoever's working on at the laboratory, for example, the graduate students working at Dr. Saklos's lab, a modular design that they can implement themselves, so we don't control the actual process. They can design the process based on the application. Is one of the it's just one of the sides that we think can be implemented much better. Yes.
Great. So as your focus on the electrical components, as you said, your hope is to have that software piece sort of catch up, which is a great segue into team AB, who was obviously focused on that piece. So what are your perceptions of what would come next?
Our perception would be combining our software with our sister team being the ARM, and how they would interact with each other. So that would probably be our main takeaway.
Yeah, thanks, Jonathan. So exactly that, taking the three different pieces that people were working on this year and taking the best of that and integrating it together could be a great step forward for next year. Thanks, Jonathan. And Team Z, your thoughts on what would be next?
So we agree with Team AB. Our next steps would be to integrate with Spencer and integrate into the biosafety cabinet at the stem cell engineering lab to make sure it all fits. It doesn't cover the vents. It's stable. And another major part would be training the staff at the lab to use the ARM. It is fairly simple, but you would probably need a tutorial on how to use the software, how to assemble everything if needed, and how to clean because it needs to be sanitized properly. So those will be our next steps.
Yeah, so recognizing that not all teams had easy access to the Spencer platform, and thinking about the integration stage with the existing Spencer, the physical space where it integrates in, and then that really important point, thanks Rita, talking about how to ensure the people who are going to carry this on actually know how to use it, and so on and so forth. So yeah, thanks for that. Team W, where would you want this to go next?
So take that on. One of the best being an agile team. Hello. Sorry, my internet was laggy. But yes, one of the best things about being an agile team is that we have that upscalability. The product is technically ready out of the box. You can use it. You can build on top it. It's got.
And unfortunately, I think Yash is broken up, and Yash is one of our people who's on site. So I think, Yash, your connection is a little bit weak. We're seeing it as red. I don't know if somebody else from team.
Yes, it is.
Jump in your place. I think we got a few points, but Harika, do you want to jump in?
Yeah, I think what Yash is trying to say is that because we're agile, so we can technically make any changes whenever, which is amazing. So I know for Waterfall, it's like you have a plan and then it'll take a lot of time to replan everything. But for us, we can implement features anytime. Also, the way our design has been done, it's like anytime we get new state, like for example, we were showing Dr. Susan some ideas and our final demo, and she gave us some ideas, and I think we can still implement those. In terms of where we see this project going now, so as we have already talked to people in the hospitals or in the long-term care homes, they have been very interested to buy our product or have it on there because they think it's not expensive. It's something they can buy. It's something they have already they have already invested in. So we are trying to meet those stakeholders, trying to see what their specific needs are. And if we find some common grounds, then we want to implement those features, and then probably our idea was to open a startup, so do something with it, or even if we are not able to create a startup or actually maintain the app fully, then have a good version of it and then release it for people to use, or give it to people for example, our Dr. Susan or Professor Rob, so they can kind of work with it. So yeah, that's where we're looking at it for now, but we have been trying to work on during the summer on it and kind of finish some other features and then release it.
Yeah, and just to add on to that is that one of the other things is that the product being a software product in a sense is that you can technically run it on a Raspberry Pi or your own machine as well. So it can have the potential to be open source where, the development can be done by a multitude of people and it can be built atop and the system can be used as is. So definitely a lot of potential where we can keep on adding features and there will be an endless loop of just new features.
Yeah, thanks, Yash, and apologies again for the internet access. I know you're in one of our rooms here. We're going to quickly go to team X, and we are getting close to time. So where do you see your product going next?
Well, as a team, our next step is we'll actually be applying for a conference in the summer. We'll be submitting our project for that. But in terms of the product development, there's still quite a bit that can be done in optimizing both the hardware and the signal processing that comes afterwards. There's a lot of robustness testing that needs to happen. We're going to test in a warm or cold environment, or all those sorts of things before we can actually say this is ready to be commercialized. But there will be a continued development. This project is continuing. I'm actually going to be doing a master's program with our supervisor to continue developing this product for the next couple of years. So we'll see where it goes. I'll update.
Thanks for that news. And that's a great way to finish panel 3. Thanks, Derek. If we could firstly quickly get the poll up for panel 3. And then I'll take the opportunity to thank everybody in panel 3. That was a great panel. If we can have everybody in panel 4 raise your hands at this time so that we can quickly get you into the panelist group, that would be helpful as well. I just want to say thanks again to panel 3, a wonderful panel. We had Team AA, the Biotronics Inc., Team AB, Owl Robotics, Team Z, STEMbotic, the 3 who were focused in on the Spencer evolutions, Team W, Connections, and Team X, the low-cost device for detection and quantification of THC in oral fluids, although as they pointed out, it has a number of other applications. So thank you for panel 3. We have the poll up. We will keep it up for a few more seconds. So make sure you get your votes in quickly for your favorite team presentation in panel 3. And we're about to move on to our last panel of the morning, panel 4. We have 5 teams focused in on automotive challenges and related themes. They're not all automotive. And it is 11:30, so we will close the panel 3 poll, please. And if we could roll the video for panel 4.
What's this? What? What is the purpose of this? Supposing you're a group. Hey, aren't we in the same group? Oh, okay.
Look, we're trying to find a way to improve the fuel efficiency of the Class A truck by recycling the heat waste from the exhaust gas and feed the turbine and power the refrigerator of the truck.
I see, so you're trying to make us lose money.
Actually, you need to save the environment. What have you done so far? Look, we have a theoretical design of a closed ranking cycle, then we scaled it up to a prototype design.
So you have a full prototype?
Well done, literally. For the scope of this project, we decided to prototype a heat exchanger since it's the most important component of the actual design and all the known speculates around it.
So this is what we were talking about?
Yes, exactly. As you can see, we were able to boil the water using the simulated exhaust gases environment.
What ratings did you get?
Yeah, we got the data, but who knows? It might work.
You son of a
What were the challenges? There were many challenges, but I want full immunity first.
So how does it work and how can you get it on your truck?
For Team AF, stay tuned.
We are Team O Solar Solutions. Our project is based off the American Solar Challenge, a yearly event that schools compete in. Students are tasked with building a solar vehicle under strict rules and regulations and compete in an 8-day race. Building a full-size vehicle is a complex task, thus we only focused on some modules, system modules relating to power consumption, energy storage, and the vehicle's body. Okay, motivations behind this project. Renewable energy is a mutual interest for everyone in the group. We believe that solar energy in particular will be the most influential in the future technologies given the rising environmental concerns over burning fossil fuels. Everyone in this group is interested in developing emerging technologies that will better the future of the transportation and perhaps expand into other areas as well. For this reason, the American Solar Challenge is the perfect place to begin to push the boundaries of renewable transportation and help us to hone our skills for the future projects as well. We believe our team's work, as well as the competitive nature of the annually held American Solar Challenge, can bring about great research and the opportunity to help develop the solar vehicle market.
Largest provinces to find out how much vaccine has been wasted so far. Only Alberta.
So nearly 1.5 million doses of COVID-19 vaccine in North Carolina have been wasted since December of 2020.
Hello, we are Team R, and our project is the front suspension system for Lassonde Motorsports. Let's begin with talking about what motorsports is. Motorsports is a competition in which formula cars race against each other. Various universities compete with one another with a car that they created themselves. Lassonde Motorsports is an up-and-coming club where they are preparing to build their own formula car so that they may participate in the competition in the upcoming years. Our involvement is that we would assist them with building a component of the front suspension system. We'll be focusing on one end so that the Lassonde Motorsports community has something to work off of in the future if they decide to change the design. We are responsible for designing the front suspension system and conducting FEA simulations to ensure that the design is safe and follows the FSAE rulebook, so that Lassonde Motorsports community may allocate their resources in other places that require more help.
Do you wonder what the airflow conditions are like near your car while driving? Have you ever felt the impacts of on-road turbulence while driving on the highway? Engineers design cars given their understanding of the physics and boundaries pertaining to their problem. But did you know, currently, aerodynamic tests are performed on cars with idealized laminar flow over them? And we know that's not a good representation of what the actual on-road turbulence looks like. This in turn limits the potential of making better vehicle designs. Our project's purpose is to better understand these airflow conditions by using a fast response velocity coil. In doing this, optimizations in aerodynamic design could help improve the vehicle's performance, reducing the energy required to drive through turbulent flow and making the vehicle more safe.
Thank you, panel 4. So we have our grouping of panel teams looking at thermal, mechanical, and vehicular issues. So for this panel, again, the starting question to kick you all off on is, in your own words, why does the world need your project? So for some teams, this will be an easier question. For other teams, this will be a little bit more of a challenging question that you might need to think about. So for team AF, what's the need that you're trying to address with your project?
Yeah, you know that our project actually utilizes the waste heat to power the refrigeration unit in the reefer truck. So then it will reduce the fuel consumption in that truck actually. So basically, what we are adding is first we are saving waste heat energy. So that's basically we're saving energy. So at least for me or for anyone who is really interested in the energy sector, it hurts them when there is energy waste anywhere. So just seeing all these trucks, driving on the roads and wasting.
We've lost your audio. I'm not sure what's happened, Yusuf, but we've lost your audio. But I think we've got the key point that wasting of energy is really the key thing that you're trying to address.
Can you hear me now?
Yes, we can.
Okay. So yeah, so saving the waste heat energy, that's the added value. Also, saving the environment because we're cutting also carbon emissions, right? And we are helping the government to reach their goal by 2050 to reach net zero emissions by then.
Yeah, and recognizing the need for a retrofitted solution for the foreseeable future, you're really sort of fitting that market, which is really important. So yeah, thanks, Yusuf. Team O, so where do you see the need for the particular components that you developed for your solar vehicle project? Who'd like to jump in on that for a Team O?
Here, I'll go for it.
Yeah, thanks.
So like one of the primary emissions from motor vehicles that contributes to negative environmental impact is carbon dioxide. And the emissions linked to numerous amounts of health problems has been mainly produced by motor vehicles alone. And like our design creates zero carbon dioxide emissions and will allow us users to travel in the same way as a motor vehicle. Yeah.
Great, thanks. Short and sweet. I appreciate that. As an electric vehicle driver, I can appreciate your your input there. So thanks for that. Team P. So obviously we're aware of the previous recent needs for transporting vaccines at low temperature. Is that the key need for your product, or do you see other needs out there as well?
So yeah, obviously transporting vaccines is the key need, but this also has lots of applications in different areas of medical industry, as well as with like shipping food for like fish or meats as well. So there are lots of different areas we can branch out to as COVID starts to recede.
Thanks, Team P, and it's great to see you all and your device in the Burj. So great to see you. And Team R. So obviously this is a slightly more challenging question. What's the specific need for Lassonde Motorsports is clear for your product, but more generally, what are you trying to do that we couldn't just do with an off-the-shelf solution?
That's a good question. I think it's important to understand that when we are working to design something for someone, they have specific requirements. Maybe for an off-the-shelf, it might not suit the requirements. So pretty much for us, our main goal is just to, like we discussed with Lassonde Motorsports early, like, can you give us, like we have our requirements list, and we're just trying to verify that. So yes, you can make the argument that an off-the-shelf is a solution. However, in my opinion, if that was a solution, then there would be no need for us to be doing this project. Lassonde Motorsports themselves would have just gone and done that. But instead they said, we want something custom for their club based on the requirements. So I think that's kind of the way I'm going to go about answering your question.
Okay, so understanding that customization space and understanding the process that you go through to do that customization is something that there's a need for in the world, that rather than just go to the off-the-shelf solution, actually understanding how we go about doing that customization, tailoring, and where it can bring value is an important process in and of itself. Is that a fair summary?
Yes, I'm actually going to build off of that a little bit more. So with an off-the-shelf component, typically like what you get is what you get. But since they're still in the design phase of, well, Lassonde Motorsports doesn't have a complete car yet. So they're still in the process. So when you go through the design process and you're giving like conceptual designs or final designs, everything we're giving them, it's still able to be modified. So let's say next year they say, okay, this is a good design. However, we don't like this component, or we want this to be changed. It's like they still have the ability to work off of it and improve it, or make adjustments if needed. Whereas if you have an off the shelf, it's kind of like, I mean, it's already assembled. You're not going to kind of break it apart and customize it and then reassemble it. So that's kind of, I think, the benefit.
Great. Thanks, Aaron. Great answer. And if we could come on to Team Y. So in the video, you've talked about some of the needs that we can address, but how do you hope that this type of probe could actually move society forward in terms of understanding those flows?
Yeah, so basically understanding those flows would actually help the manufacturing companies change the design of the vehicle, which in turn can help the consumers save money on fuel economy, and as well as make the vehicles safer, because when they actually test those vehicles, it's a more laminar, smooth flow, but in reality, it's not as laminar and smooth, and there's more turbulent flows from different locations. So it's really important to understand all the flows that are experienced by the vehicle, so they could improve the design of the new cars that are being built.
Yeah, great answer. Thanks, Govia. So for the second round, I want to really dive into, in each of your projects, there was a simulation component that you had to think about in terms of how to simulate the real world environment, how to do your design work to ensure that the design that you would then go on and build was going to achieve what you wanted it to. So I'm wondering if you could talk a little bit about, from a technical perspective, where did you emphasize it, accuracy, fidelity in your simulation? Where were your simulations perhaps simplified? And how did you go about designing your simulation space to ensure that you had a good designed product? So I will, as previously, go in reverse order now. So if Team Y, you'd like to pick up that question first, how did you go about simulating your rapid response nozzles?
Yeah, so basically the way our product is, there's not many loading conditions on our things. We didn't really simulate like an FEA simulation, but we were more focused towards the CFD simulation, seeing how airflow travels through and the roughness of the inside and how to smoothen it out. So what we did was we used sensors, like the actual sensors that measure the airflow coming in. We simulated those individually to see how each one is affected at different angles. And using that, we determine the lengths and sizes of the holes on our probe to ensure like the airflow that's coming in is the most effectively read instead of any disturbances in the readings.
Great, clear need to address the specifics of the problem, and you identified where there weren't particular challenges and where you would then therefore wanted to focus the simulation. Thanks for that, Govir. Team R, obviously there was a lot of simulation involved in your design work. So how did you go about it? Where were the areas that you wanted high fidelity, and where did you simplify?
So with simulations, like what we've learned in like the mech program, definitely in the fourth year, you kind of focus on either FEA or CFD. Now, for a suspension system, this is more applicable for FEA because you would want to do CFD analysis on an actual like complete car to see how the streamlines and how it reacts to oncoming flow. But for a suspension system, that's more of just you want to test like the stress concentrations due to loading. So we focus primarily on FEA simulations. Now, you could also, I've seen that you can do some work with SolidWorks. However, that's not the approach we took because I've seen before sometimes it gets a little buggy and that you can get a much more accurate simulation using a program like StarCCM. Now, to discuss about simplifications. So initially we had our design and we had a pretty high resolution mesh. We tried simulating under just loading conditions, and there was no stress distribution throughout the component or throughout the design. There's no distribution except for the point where initially the force was located. Now, this is an issue because obviously forces are going to distribute through the design and you're going to have different stress concentrations. So what we had to do is actually modify the design and come up with a simplified CAD model, kind of removing all complex interfaces and kind of making it as one component. So now we're simulating a rigid body rather than an assembly. This will allow for, well, pretty much what this did is it allowed us to get a distribution of stress and displacement so we can see how the design is reacting to the loading conditions. And now for simulation setup to discuss the loading conditions. This comes back to our requirements list where Lassonde Motorsports gave us the requirements to say, hey, we want the suspension to be able to withstand up to X amount of force or X weight. So then again, throughout the design phase, what you do is you use the requirement and work backwards to try and find design constraints. So again, we found the weight we need to withstand with the safety factor applied, found allowable stresses, and then designed components based on length requirements. For example, like this member has to be shorter than this length, or else now you're going to have an issue with failure due to the component bending. So pretty much we found our setup conditions, our simulation setup, based on that technical analysis. And then we ran the simulations like that.
Okay, thanks, Aaron. So Team P, obviously you had to design your box and then you built the thing and worked out how similar it was to your your modeling. So, or your calculations. Where did you find differences, or where did you simplify your design?
We did not do any simulations, but we did do calculations based on heat transfer of the system and how long the dry ice would last. Initially, we did plan on running simulations through CCM, but we later concluded that it would be much faster to simply do the actual testing. And as for the differences, in our calculations, we found that the dry ice would last somewhere around 20 hours. But with actual testing, we found that the dry ice would last longer than a day even. So we believe that these discrepancies in the theoretical and the actual results are related to the sublimation rate and the assumptions we made based on values we found through our research using internet and the textbooks. So they did not accurately depict the situation that was going on inside the refrigeration system.
Yep, so wonderful. So I was going to have asked you that follow-up question of where you thought the differences came from, so I'm glad that you gave that. But often we make conservative assumptions, and it sounds like that some of your data sources were some of those conservative sources. So the fact that you ended up with better performance is good. And it wasn't vastly better, that you were way off in your initial assumptions. So that's good as well.
Yeah.
Great. Yep. Thank you, Team P. If we could come to Team O. So in terms of how you were modeling your system, where did you focus the modeling? Where did you simplify? Who from Team O would like to take that?
Hello. Okay, I guess I'll go first for the electrical side of our project.
Thanks.
So for our electrical, we focused on the power generation over the days, using data that we gathered from websites and other trustable databases. We found out that, or we ended up deciding to simulate power with a great degree of accuracy, as you know, it's directly tied to the performance of the vehicle, which makes the vehicle appealing in some way, right? And when it comes to other components that we focused on for the scope of this project, we ended up just confirming estimations that, you know, like our battery system would be able to store the power generated by the vehicle. And, you know, after those initial simulations, we did compare the data to an extrapolated data set, since we were only using one solar cell for the testing, because, you know, we could not build like the entire array. But yeah, we ended up just comparing those two sets.
Yeah, so your focus was really on you did exhaustive testing, exhaustive analysis of the solar panels, where you saw that as the sort of key performance enhancer that you could sort of add to the vehicle design. Is that a fair summary?
Yeah, that is correct.
Yeah, thanks, Santiago.
No worries.
Yeah, great. Yep.
Sorry, in terms of the mechanical part of our solar car, so we first came up with the initial design of the body, and we did the CFD analysis on it using SolidWorks. But from the feedback from our professor and the TA, we saw room for improvement, like by excluding sharp edges. So we made a lot of changes to our initial model, and then finally came up with the final model. We did the same CFD analysis using SolidWorks on the final model, and then we physically tested it using the wind tunnel in the bird to support our CFD analysis results. From there, we found out that the theoretical and experimental results were pretty close. And then in order to do the testing, we had to scale down our final model by 1/20th of the size in order to fit it in the wind tunnel. Yeah, and that was our approach in making our body more aerodynamic.
Thanks, Tanvir, and that's was an important part of your project as well, clearly. So thanks for that. Team AF. So obviously there was a lot of calculation of what could potentially be achieved for the pieces that you were focused in on. Where did you find challenges in coming up with the modeling of what you were expecting?
So a lot of our system involved phase changed heat exchangers, and it became apparent that simulating those on a full scale was going to be unfeasible. most of our parameters were found through calculations or research papers, and pretty much the entire system was an unknown at the beginning. We had very little boundaries to start with, and we needed to calculate almost all of them. One place we were able to use simulation was calculating the airflow over some of our heat exchangers by making a simplified model of the truck.
Thanks, Daniel. So that's wrapping up that section. What I'd like to move on to is thinking about the process of going through the project. Oh, we've got somebody's mic still active, but the process of running the project this year. What was the thing that you found most useful or most surprising when it came to development of your project? And you can focus in on management, you can focus in on technical, whichever aspect you found most helpful for a successful outcome. And what was the thing that you found most surprising on this capstone journey? And if I could start that question on Team P, so thinking about what worked best for you and what surprised you most in this journey that you've been on. And as you're in a room, I feel free anybody to jump in on Team P.
Sorry, can you repeat that?
Yeah, absolutely, no worries. So the question for you is, what did you find most surprising on this capstone journey that you've been on? And what was the thing that you found most helpful in terms of the process that you went through to come up with the box that we've got in front of us?
The actual testing was the most helpful.
Yeah, I think the testing was quite challenging, but the most helpful was probably our supervisor, because he gave us tips such as you should keep it simple and you should keep the ball rolling in terms of like building and not wasting time on like, for example, we were 3D printing a lot of parts at the start, but he said just get them ready made and start putting stuff together so you can move on to testing, and that really helped us meet our timeline requirements.
I also think that moving on to a simpler design really helped us, because at first we were talking about the two-stage compression system, and honestly that was way beyond the scope and like the budget that we had for this project, and would take them way longer. But to see like us having like a final prototype which works and that we can look at and be like everything that we wanted it to achieve, it does, I think that was really good as well.
Yeah, I think the analogy that came to my mind when I was looking through your project was the challenges of making the pen that works in space, but you've built the pencil. But
for sure.
Yeah, and so that's great. Thanks, Team P. If I could come on to Team O, so what would you say you found most surprising or most helpful on your project?
So one of the things that I would say was most helpful for our project would be that we split our team into two separate groups. Mechanical part and an electrical part, and it really helped us with both the design and integration together when we come together during our team meetings.
Yeah. So really understanding those strengths in those two different areas and allowing the teams to actually work to their strengths, and then just working out when to come back together again.
Yeah.
Great. Thanks, Hani. Team R. What did you find most surprising or most helpful on your capstone journey?
Okay, I'll start with what we found helpful. I think definitely conversations with Professor Ronald Hansen, even though he's not our supervisor. And this was due to, because he teaches the simulations course in the first semester of fourth year. And during that first semester, when obviously we're working on the capstone, you have the CDR at the end of the semester, right? Where we have to start actually doing some like simulation testing. So our initial simulation, like I said earlier, how there were some issues with the stress and displacement not distributing throughout the design. So that was a big problem because we know we're not going to get accurate results moving forward like that. So I had a discussion with him, and he provided a lot of guidance on how we can kind of just move forward and have better results from the simulation. So from a technical aspect, that was the most helpful. Also, another thing I want to talk about that was helpful is our supervisor, Professor Malenka. We initially had the idea of physically manufacturing the suspension system. However, he kind of stemmed us away from that, and not in a negative way, but he said that it would be better if we focused more on the simulation-based work rather than having a physical prototype. That was also very helpful because the way the second semester kind of panned out for us, obviously very negative. Well, sorry, not obvious, but it was very negative. So if we had to actually manufacture the suspension system in the second semester, that would be, I don't even know how that would turn out. So that's what was helpful for those two aspects. Now, what I found surprising, again, not to sound like mean or anything, but there's a lot of negligence with some people. Because this is a big project that everyone wants to work together for, but obviously that's not how it panned out. So a lot of work shift and a lot of hard work for other people, but it is what it is. So that's all.
Yeah, so the surprise of managing a capstone in a final year with a lot of things going on and a lot of external challenges. And then sounds like from the helpful side, timely advice from important voices seem to be useful for you as a team. So.
Oh yeah, no, absolutely. From the helpful aspect, that was extreme. That was very helpful. I can't imagine the project going in the other direction if we didn't get those two pieces of advice.
Great, thanks, Aaron. If I could come on to team Y.
Hello, good afternoon. I think that I found really helpful this project was the way we structured our meetings. Each semester we kind of spoke about our availability and try to book in frequent meetings every week. So we had 2 meetings with our group for 2 hours each, and these are slotted so we could all understand ahead of time what time we need to allocate for the project. We also had a meeting with the supervisor, which was really helpful because we would kind of give him an overview of what we discussed through the week, any things we need to move forward with. And then after the meeting, we'll debrief and discuss again. So that was really helpful because the more contact we had about the project and the more we talked about it, the better we were able to define things. Because a lot of the times in this project, individuals will go one way, others will go another way. But because we met so frequently, we're able to be together on most of our thought process. So that was actually really helpful. That frequent meetings and being open was really good to the success of a project.
Yeah, so that team connection aspect really changed things for you. Great. Thanks, Jordan. Team AF. What would you say was the most helpful or most surprising on this journey that you went?
I would say having a group of 8 did not make it easy. Everyone has different schedules, different timing. Everyone is busy with school, so it was a bit hard to coordinate with each other. And then I would add on that the school did not really, the course load we had did not make it easy for us. We had other projects along the year. We had so many deadlines. So I would say we expected that we were gonna have a little bit easier year to start with, so we could focus on capstone, but it was not the case. I would then, if we want to talk technical, what we found a bit hard, our scope was a bit large, and I would advise on narrowing your scope for everyone. Narrow your scope. Try, you don't have the time that you think you have. Then talking to advisors, talking to your supervisor, always talk to him. They know, they've been there. They are experts in your subjects. I think we got a lot of help from Roger. Then we got a lot of help from Dave from the machine shop. The machine shop, when opened, made our transition to prototyping way easier. Another issue we had is storage. Our project is huge in size, and thanks to Roger, he secured us a room. And for the machine shop training, we were able to actually build it and move on. But that was very like a very late stage, I would say. Like we were able to prototype everything probably the last 3 weeks of school or month, which made everything hard at the prototyping stage. I actually, thanks you, Professor Hussam, I believe 2 days before the deadline, we had a problem and he helped us with it. So I would advise everyone just knock on doors and talk to professors. They know what they are doing and they are willing to help, most likely, I would say. Yeah, that's it.
Thanks, Mahmoud. The idea of, again, that punctual calling out to the help that's available, making use of it. And that's something that will happen in industry as well. So that's important to recognize. The challenges of this year with access to the machine shop, access to spaces being really, really late is something that we haven't heard a lot of today. And I think you've spoken to that really well. That it hasn't necessarily been the easiest space to work in. And despite that, you've had these great successes. I think I might have skipped Timo, but I do want to move on to the next question. So thanks for that round. What I'd like to pivot to next is the question of legacy, question of next steps, question of what was the biggest impact that came out of this project for you personally or as a team, or for society if you want to talk about legacy. So I really want you to think about what is next for you based on this, or what's next for the project. And if I could start with Timo, what would you want to say about the legacy from your project and or the legacy for you individually or as a team? Who wants to jump in for Timo?
So I can answer that. You guys can hear me, right?
Yes, thanks.
All right, so on our project for the American Solar Challenge, our legacy, we knew that from the start that we wouldn't be able to make the entire vehicle, not by a long shot, but we believe that in the end, whoever's able to build up and finish the solar vehicle, I believe, has a really good chance of helping not only represent New York at the American Solar Challenge, but also for potential stakeholders who are looking to research into the potential of solar vehicles as more of a consumer market, can look at some of the results of our vehicle and in the competition as a whole, and really help progress that consumer-based motion as a viable alternative to that of traditional, more fossil fuel-based vehicle emissions.
Thanks, Harry. And so both the idea of this could be the start of, just like we have Lassonde Motorsports, we can actually have this as piece one of our vehicle for the American Solar Challenge.
Yeah, and it's sorry.
Yeah.
Yeah, and it's small steps. We can only move forward. We can't move back. So whatever we can do, whatever research, it will help progress the solar vehicle industry, we hope.
Yeah, great. Thanks, Harry. Perhaps move on to Team R. So obviously you're part of a project that has some legacy and you've provided some work for the next piece. So what would you hope comes from your project, or what have you taken from this into where you go next as a team?
All right, so yeah, like you said, I think it's kind of difficult to give a really strong answer since we are kind of helping someone achieve their goal. But even with saying that, I think it's like, again, our next steps is we're going to have a conversation with Lassonde Motorsports and say, hey, look, this is what we have. Here's all the files and everything. so that you guys can use it as you see fit, make changes, make adjustments, improve it, or use it as is. Honestly, again, I don't really have a complex answer for this. Just simple, just hey, here's the stuff, and then you can move it or use it going forward.
Yeah, so you've achieved what your customer wanted, and you're handing it off and ready to hope that it achieves for them what they needed of it.
Yeah, like we're not really trying to like change the world or be super innovative.
No.
We're just simply designing for our customer. That's it.
Great, thanks, Aaron. That's a perfectly reasonable answer. So maybe I could come on to Team Y.
Yeah, so briefly, the project's next steps will be to continue testing on a large-scale wind tunnel, because right now it's just calibrated. So a lot of tests could be done using Ronald Hanson's wind tunnel, and then individually learned so much this year. Probably the first project we spent 8 months working, largest team. So we all took a lot from this, and it was a great experience.
Great, thanks, Jordan. Team AF. Who'd like to pick up the question on Team AF of what's your project legacy, or what's the thing that you take away from your experience on Capstone that
Yeah, you can hear me now, right?
Yes, thanks.
Okay. Yeah, sorry. Because we are actually cutting around 40,000 kilograms of carbon emissions for the environment, and we're having profits up to 2,000 a month, and that's all per truck. So that would let us hope that we see this project on the roads one day. So before September, I was just barely seeing the trucks on the roads, but after October, I cannot not see the trucks on the roads. And every time I see a truck, I look at that part, at the front of the trailer. Is there a refrigeration unit there, or is it just a normal truck? So the steps that we are taking to pursue that, we are going to do some tests in the summer, more tests and more improvement to our prototype. And we are planning also to join some entrepreneurial programs or pitches like the Best Lab or somewhere else. And then later, after probably everything is complete, we are gonna join some competitions, like project competitions. And after that, if everything went well, we can start like a startup with our project. Yep.
So there we go. Thanks, Yusuf. So anybody in the audience who wants to reach out to Team AF, they are definitely interested in ongoing support as they move to the. So thanks for that.
Thanks.
And I think last but by no means least, Team P.
So our next steps, as Calvin mentioned before, is to branch out to other industries, as he said, like not just the medical industry, foods, meats. And apart from that, our next steps would be just refine our project a little bit. Like the internal electrical system, like it's a bit messy, as like we would say. Yeah. So like just getting that like made a bit better, and like just reducing the cost of the manufacturing, and that comes with bulk. As we start making more and more of these, the cost will eventually come down by itself.
Yeah, and basically to talk more into like the sustainability aspect, we did take out the alkaline batteries, put in a lithium-ion battery, so it's not a one-time use item. It can be used in many different industries multiple times. So I think branching out to other industries, what Savik said, is a good option for us.
We also talk about the modularity of the product system that we plan on. So we plan on making the product system a lot more modular, so that in case a part fails, a component fails, we can essentially just remove that part and then replace it with a newer one, and the product's going to function.
And I think Capstone, the legacy of Capstone is mainly not what we built, but what we learned along the way. I think we're going to use that in all our future endeavors.
Wonderful. So it sounds like you two are interested in connections to anybody who wants to help you maybe get to that next step.
Yeah, sure. We're looking forward to it.
Yeah, wonderful. So thank you, Team P. And we're almost at the end of the panel. So I have one final question for every team, which is if there's something that you haven't had a chance to say that you want to say to those watching, what is it? Or if not, what's the one thing you want people to remember of your project as they leave the room? And this group has had probably the more amusing short clips out of the groups, but we've had a mixture of projects. But if we could think about what's the thing that you want people to take away from this panel about your project and what that looked like. So I'll do them in order again. So we'll start with AF. What would you like the room to take away from your project?
I think we'd like the room to take away that, we're all about teamwork and about making a project that is, technical in nature, very technical in nature, but also very, we're a very enthusiastic bunch, and we really want to, show Lassonde that you could also be a little bit creative and a little bit, charismatic with the way that you deal with technical projects. So I think that's the big takeaway for us as Team Hot AF, as we like to call ourselves, is, is stay light and, have a little bit of personality with every project. And I think that, it goes a long way.
Great, thanks, Mohammed. And I appreciate that you've had so many of the team answer the questions as well. So thank you for that. Team O. Who'd like to pick up the question on Team O? What do you want the room to take away as you finish this panel? Amit there? We can't hear you. I think there we go.
Sorry, my mic was muted too. So
yeah, no worries.
With us, it was we went to great projects. That teamwork was a huge thing for Capstone overall. And we had a huge group of 8 people, so working together was amazing, and we made new friends the whole way. And we learned these kind of skills that we can use in our future pretty much.
Right. Thank you. Thanks. On to Team P. What would
what we'd say is probably just constant innovation is doing small steps to make your prototypes better and better is the fastest way to innovate and design new parts.
Like our supervisor said, keep the ball rolling, right?
Yeah.
Yeah, that's a great line to finish with, Team B. Thank you for that. Team R.
Yeah, I don't really have any philosophical answer or anything. I'm just gonna have to keep it really basic, but
well, good.
You learn good things in the program and whatnot, and you can apply it, and just if you work with people and you have a lot of time, you could actually make some really cool things. Maybe at the beginning of my first year, I never thought you could go on your own and make an entire car and do an analysis on it, but now you actually can. So yeah, you learn really cool things and you can apply it and do what you need to do.
That was well said. Thank you, Aaron. That was a good answer. I like that. And Team Y.
Yeah. So the one thing that we really took away from this project is to spend as much time as possible on the research and development phase. When we first started the project, our supervisor gave us 10 to 15 research papers that were 40, 50 pages long. And we did go through each and every one, and we did realize it was very important to actually understand what was said in those papers, because if you don't truly understand the problem that you're trying to solve, you'll probably get nowhere with it. So it's really, really important to truly understand what you're trying to solve and come up with different ways and then narrow it down to see what the best way is to actually solve that problem.
Thanks, Gurdeep, and thank you, our panelists in panel 4. If we could put the poll up for panel 4 right now, that would be great. I just want to take the time to thank again panel 4 for a great panel. Team Hot AF, the fuel efficiency enhancement system for a refrigerated truck. Team O, the solar vehicle project. Team P, the ultra cold refrigeration system. Team R, the front suspension system for the Lassonde Motorsports, and Team Y, the pressure-based 3D velocity probes. Thank you very much, Team Panel 4. We will shortly be going on to our lunch break. For the lunch break, we will have a reflection video being played in this Zoom room, so do hang around to watch the reflection video. These are reflections from all the students on what they would have told their September selves if they could wind back the clock and tell one key nugget or a few key nuggets of what to do at the start of this journey. Some really important insights will come from that. And so go grab some food. Those of you who are at the watch party, there is food available. We will be back with panel 5 at 1:20. We'll start a little bit before. So if those of you in panel 5 could be here at least 5 minutes ahead of that at 1:15, that would be great. And we will get the panel 4 poll closed at this time. And if we could now roll the reflection video, and we'll see you after lunch.
What would I say to my September self 8 months ago?
So one thing I would tell my September self is to not hesitate to try out a variety of new tasks. So even if things are unfamiliar to me or I feel myself lacking the needed skills, just by taking up the challenge, you give yourself an opportunity to learn something new. And all in all, I would say that my capstone experience has been very rewarding because I got to meet a talented team of future engineers, and together we were able to create a project that has real potential to help the healthcare industry. And I think that's very satisfying.
Some things that I would tell my September self is to not be afraid and try something outside of your comfort zone. Have faith in your teammates. Remember that you're all sharing the same goal, that you each want to succeed and build something awesome. Overall, it was emotional, it excited me, and it beat me to the ground. But in the end, I gained some amazing friends, experiences, and memories that I will never forget and I will hold on to for life.
I would tell my September self that it's extremely important to stay on top of your work. Having a good team effort goes a long way, so make sure to divide work evenly in the starting. I also learned about myself that I tend to get overwhelmed fast, but this can be overcome with good time management strategies and communication with the team.
I learned that I'm a lot more productive when I'm able to go to campus or just get out the house and work somewhere else. I realized that no matter how complicated or smart your design is, sometimes you just forget the most basic things. For example, I forgot that plastic can't go through plastic. Don't ask me.
I want to tell my September self to kind of set deadlines and to really be on top of those deadlines, because it really helped me finish up my parts of the project and to finish up small little details instead of procrastinating or saving it for a different week. So I learned that I needed to be more confident and that I needed to kind of show my ideas to my team, and they were lovely and helped me really gain that confidence.
What I would tell myself in September is that even though you have 8 months and it's a lot of time, it can go by pretty quickly, and it's easy to think you have more time than you do, especially when you factor in all the other courses and meetings with other people, especially if you have a big group.
I would have told my September self that setbacks will happen, and they did actually happen, and it's okay even if things don't go planned the way we initially envisioned. You have to be very flexible and adaptable to changing circumstances, and you have to plan accordingly if things don't work out.
Something I would have told myself in September would be that keeping things simple, especially when it comes to planning or design, is always best, and that productivity suffers when things get too complicated. It's easy to lose sight of this, so always make sure that your goals and priorities are in check.
I would say to my September self, enjoy the process. Don't worry about the learning curve. Everything will work itself out in the end.
Overall, Capstone has been really challenging, but also extremely rewarding. It was interesting to work in such a large group and see a long-term project from start to finish.
In terms of something I learned about myself during this whole process or just this course in general, is that I learned that I'll be great at working in a smaller team rather than a bigger team, and I'm glad I worked with the team I did.
I would tell my September self that you're going to be working on an amazing project with super awesome people. And there will be a learning curve. With perseverance, you can achieve all your goals.
I would tell myself to pace myself. A year is quite a long time,
And I would also remind myself to simply enjoy the ride, as this is one of the final courses.
Over the last 7 months, I've probably learned more than I learned in all 5 years that I spent with Lassonde. I would say, research your project thoroughly before choosing it. Yes, picking the right team members makes doing the project work much more enjoyable, but not even the perfect team is going to be able to overcome the mountains of challenges that come with a loosely defined, unplanned project. Reflecting back on my capstone experience, I would say my favorite part was hanging out with the team, man. Hanging with the boys.
If I could give my September self a message, it will be to speak up when something doesn't seem right. Often our group members will be stubborn when approaching a project when trying to find a solution, while other members will be hesitant to speak and challenge their opinion.
If I could give my September self any advice, it would be to be more forthcoming with my own ideas and proposals.
Before capstone, I preferred working individually, but after having multiple brainstorming sessions with my team members, I learned that it was easier to accomplish challenges collectively. Although our topic was a little challenging, it was very interesting and noteworthy. I got to collaborate with wonderful people, and the skills that I gained during these last 2 semesters will stay with me for a long time.
If I had the chance to go back to my September self, I would tell myself about all the exciting and unexpected changes to our design that kept our team on edge and eager to succeed. At first, I believed that this project would be straightforward and that our design would work from the first iteration. However, now I realize that things don't always go the way you planned, but that's okay because there's always a solution on the other end.
I would say don't plan things so rigidly. In such a long-form project like this, I feel like you need to allow for some flexibility when planning, because things don't always go as planned. Finally, some reflections on the capstone project as a whole. I would say communication is definitely key. If, for example, if you run into roadblocks, you don't have to wait for your weekly or your sprint meetings to bring it up. Just contact your group members, and getting those roadblocks out of the way quicker, or just communicating with your group in a timely manner, can help out a lot.
Throughout this course, I've been challenged to learn new things, apply my knowledge, work in a group, especially considering the circumstances of being online for most of the 2 semesters, and applying our strengths, our ideas, using them to find them, develop on them, create solutions into the product.
Looking back on my September self, I would tell myself to budget more time for the individual work packages. Each individual work package will likely take longer than you anticipate, and it's important to have some buffer room in terms of time so that you can handle any unforeseen problems that come up. Also, by having more time, you can have time to reach out for help and have a better chance of actually meeting your goals and resolving the issues.
So what would I say to my September self? I would say just take a step back and make sure you're just kind of soaking in the capstone experience. It's a really fantastic time, and so it's gonna go by a lot faster than what you would expect. So just make sure you're just kind of taking a step back and just enjoying the ride every so often. So what did I learn about myself? I feel like I learned that I really enjoy working on these long-term projects. It was a really awesome experience to see how much our project evolved and progressed over these past few months. It felt it was fantastic to watch and participate in.
What did I learn about myself is that I need to slow myself down. I'm someone that wants to quickly jump into getting work done.
If I could talk to my September self, I'd tell myself that capstone isn't like any other school project. There's a reason they give you a full year, and then you really have to make best use of your time within that time period. Don't procrastinate and gradually build up your project.
Going into capstone, I was genuinely worried. I had heard from friends stories of strife, conflict, deception, and even incompetence. But looking back at the time on capstone, I wish I could just reassure myself that everything's going to be fine. Capstone made me question what I had wanted to pursue as a career, and it's honestly an experience I won't forget, that's for sure.
I know you're intimidated a little because you aren't too familiar with the students you're going to work with. But don't worry, you're going to make friends with this group of talented, like-minded young people, each with their unique skills and interests. You're going to feel defeated and insecure at times, but you're going to feel accomplished and proud at the end. You're going to be frustrated and exhausted. You're also going to be excited and relieved. You're going to face puzzles and difficulties. But with the help of your group members, you're going to defeat all your obstacles. Be diligent and don't be afraid to ask for help.
Going into Capstone, I was expecting it to just be another project course, so I was pleasantly surprised when we started working on a real, marketable product. It was an experience coding in a production environment, and I got to learn when to focus on the big picture and just push something through, versus when to slow down and really polish the small details on whatever I was working on.
It's been really interesting and very rewarding for us to be in charge of our own project because, at least for me, it taught me what it takes to manage an engineering project from start to finish. I got to work with an amazing team and each member brought a different set of skills to the table, and I think because of that we were able to really zero in on our strengths and weaknesses, which allowed us to be very realistic when it came time to thinking about the feasibility of some of our designs. I think if I could give my September self one piece of advice, it would be to get comfortable with being uncomfortable. And I say that because comfort is a dangerous illusion in Capstone. The projects we build in this course are really meant to push us to be the best engineering students we can be. But by the end, it was clear that those uncomfortable decisions that we made helped us to come up with the best possible solution for us.
Capstone has been more than just a project. It has been late nights and early mornings, code sprints and YouTube tutorial marathons, annoying bugs, and some really fun moments spent with my teammates. If there is anything I have learned about myself in these last 8 months, it is that I really enjoy working on technically challenging problems, rapidly prototyping, and working with an extremely competent group of people toward a common goal or objective.
Capstone was a great experience. I was able to work with a great team in a startup-like environment. We were able to work together to design and build the entirety of a multiplayer end-to-end system. This project made use of many software technologies, strengthening my skill set. I was able to learn from my teammates as well as build confidence in my understanding through teaching others.
If I were to go back and speak to myself in September, I would tell myself a lot. I would tell myself to research the projects available for Capstone in more detail, and to narrow down my choices based on what aligns with my personal interests, what projects are going to have stakeholders that are willing to communicate with us, how useful this project will be come post-graduation, as well as to manage my time more efficiently and to follow work breakdown packages more rigidly once they are created.
If I could go back to September and give myself some advice, I would say to make more contingency plans. Don't just make one contingency plan, make a plan for those contingency plans because things are not always going to go as you'd hoped.
I would say to myself, start early. And don't underestimate the project. It's a lot harder than you think. It's very difficult to get everybody on the same page and working all the time, but when you do, you can really create a magical project. So I was appreciative that Capstone gave me the project that I wanted and the experience to actually learn like project management in a school setting, and I hope to leverage that one day.
Some stuff that I would tell myself if I could go back to September and do this project again would be to first of all focus on the initial gates and put a little bit more of some work into them because they're a lot more important than we think, especially documenting everything and making sure everything is organized in the beginning, because when you move on and you get to the later stages of the project and you didn't start off as strong and you don't have everything organized and ready and documented, then it becomes a lot more difficult.
What I would say to my September self is that Capstone projects feel rather long and burnouts are likely to happen to you. My advice to avoid them is to try and have a good balance between the time you spend on and off the project. Don't try to define, execute, and report a task within a day just so you can forget about it for the whole week. Take the time to organize and reflect on your ideas so that you don't end up creating poor documentation. I also want to add that the first official meeting you have with your team members will set the tone as to how future meetings will proceed. So make an effort to set a standard that you want.
There are 3 things that I would say to my September self. Number 1, choose your topic wisely. Number 2, choose your group members wisely. Number 3 is take it easy and enjoy the process.
First of all, what would I say to my September self? I would tell her to be more outspoken, irrespective of if I feel like my idea isn't the best. And I would tell her to keep being her and not give up, irrespective of the obstacles.
So what would you say to yourself in September? Well, I would try to get as much done in the first semester, since, especially at the end when everything has to come together right before exams. There's so many other projects and other assignments you have to deal with. It'd be nice to not have Capstone thrown into that mess. And overall, Capstone has been a really cool experience as it gave me a chance to work with engineering disciplines on a really cool project where if I was in a full-time programming job, I wouldn't really get exposed to something like this.
So, right off the bat, I just want to say that the experience I've had from Capstone has been nothing short of extraordinary. I've had the good fortune of working with wonderful people, and our team functioned really well. We took every challenge with a positive attitude, and I would say we have done an extremely good job. So I'm proud of my teammates. It has been an absolute pleasure working with you all.
Capstone has been a very interesting course, and it taught me many things that I'm thankful for. It pushed me to test my limits and to always be on the lookout for an opportunity to improve or gain experience with something I'm not familiar with.
I have learned many things throughout these 8 months, things that have taught me how to challenge myself in difficult situations, and things that have showed me where I lack the most and how I can improve upon them. And one important thing that I've learned about myself that I would like to share is how determined I can be to finish a task when given, despite other difficult things I may have to do at that time and challenges of that task.
After a year full of ups and downs to the capstone journey, there are 3 key takeaways that I want to talk about. The first one is something that I would like to tell my September self, which is try to be as communicative as possible while also trying to work on the UI elements of the things, as I've been more of a back-end kind of guy who has been handling the project management aspects of the capstone journey as well. The final thing is the reflection on the capstone experience, which has been a great experience. It feels like I'm working in a startup, and that really helps for me because I want to start my own startup. Hence, it has been a great journey and I would do it again.
If I think about something I will tell myself in September, it's probably going to be, it's okay if I don't know everything, and I will learn everything during this journey with the time.
If I had to go back to my September self, I would tell him 2 things. First, project management should fit the team, and if the method being used for project management is not working for the goals your team has, it's okay to change it. For a team of this size, focusing on the way the project is being managed is far less important than the outcome of the management. Secondly, I would tell him to be more thorough in documenting decisions made by the team so that it's easier to look back months later and figure out why we decided to go a certain route.
Working on this team has been an incredibly rewarding experience. We have faced a lot of challenges over the past 7 months. The main challenge was figuring out how to implement our design with another piece of equipment used in a lab under a highly constrained environment. One thing I learned about myself is that I don't like CAD modeling as much as I thought I did. I would describe Capstone as the ultimate challenge of an engineering student, like the final boss battle you must beat before you go out into the real world.
To my September self, I would say before doing any piece of work, take a moment to determine what you're doing, why you're doing it, and what outcomes you expect to achieve. It's something easy to neglect since we're always given concrete instructions and pre-cooked problems in undergrad, but it's something that really helps build momentum.
Throughout my capstone journey, I have become more aware of my strengths and weaknesses. One of the weaknesses would be my communication skills.
It's really tempting to redesign your capstone multiple times to make it a little bit more efficient. And finally, I got super lucky. I had an amazing group. And yeah, it definitely makes the whole experience awesome, a lot more pleasant, and definitely easier. So get yourself a good group.
For my September self, I would tell myself to honestly live in the moment, not stress about so many things, because I'm only now realizing how much I'll miss the everyday student life. And in terms of capstone, I would actually tell myself to ration my time properly and think ahead of time before doing anything else.
Don't underestimate yourself. You and your teammates are going to grow so much together. You're going to learn so much from each other. And I may be saying this because of the high of recently completing it, but I don't think anything is out of your reach. You have the knowledge, you have the background, you have the tools. Just go and try the craziest thing because you can make it work some way, somehow.
What would I say to my September self 8 months ago?
So one thing I would tell my September self is to not hesitate to try out a variety of new tasks. So even if things are unfamiliar to me or I feel myself lacking the needed skills, just by taking up the challenge, you give yourself an opportunity to learn something new. And all in all, I would say that my capstone experience has been very rewarding because I got to meet a talented team of future engineers, and together we were able to create a project that has real potential to help the healthcare industry. and I think that's very satisfying.
Some things that I would tell my September self is to not be afraid and try something outside of your comfort zone. Have faith in your teammates. Remember that you're all sharing the same goal, that you each want to succeed and build something awesome. Overall, it was emotional, it excited me, and it beat me to the ground. But in the end, I gained some amazing friends, experiences, and memories that I will never forget and I will hold on to for life.
I would tell my September self that it's extremely important to stay on top of your work. Having a good team effort goes a long way, so make sure to divide work evenly in the starting. I also learned about myself that I tend to get overwhelmed fast, but this can be overcome with good time management strategies and communication with the team.
I learned that I'm a lot more productive when I'm able to go to campus or just get out the house and work somewhere else. I realized that no matter how complicated or smart your design is, sometimes you just forget the most basic things. For example, I forgot that plastic can't go through plastic. Don't ask me.
I want to tell my September self to kind of set deadlines and to really be on top of those deadlines, because it really helped me finish up my parts of the project and to finish up small little details instead of procrastinating or saving it for a different week. So I learned that I needed to be more confident and that I needed to kind of show my ideas to my team, and they were lovely and helped me really gain that confidence.
What I would tell myself in September is that even though you have 8 months and it's a lot of time, it can go by pretty quickly, and it's easy to think you have more time than you do, especially when you factor in all the other courses and meetings with other people, especially if you have a big group.
I would have told my September self that setbacks will happen, and they did actually happen, and it's okay even if things don't go planned the way we initially envisioned. You have to be very flexible and adaptable to changing circumstances, and we have to plan accordingly if things don't work out.
Something I would have told myself in September would be that keeping things simple, especially when it comes to planning or design, is always best, and that productivity suffers when things get too complicated. It's easy to lose sight of this, so always make sure that your goals and priorities are in check.
I would say to my September self, enjoy the process. Don't worry about the learning curve, everything will work itself out in the end.
Overall, Capstone has been really challenging, but also extremely rewarding. It was interesting to work in such a large group and see a long-term project from start to finish.
In terms of something I learned about myself during this whole process or just this course in general, is that I learned that I'll be great at working in a smaller team rather than a bigger team, and I'm glad I worked with the team I did.
I would tell my September self that you're going to be working on an amazing project with super awesome people. And there will be a learning curve. With perseverance, you can achieve all your goals.
I would tell myself to pace myself. A year is quite a long time, and I would also remind myself to simply enjoy the ride, as this is one of the final courses.
Over the last 7 months, I've probably learned more than I learned in all 5 years that I spent with Lassonde. I would say, research your project thoroughly before choosing it. Yes, picking the right team members makes doing the project work much more enjoyable, but not even the perfect team is going to be able to overcome the mountains of challenges that come with a loosely defined, unplanned project. Reflecting back on my capstone experience, I would say my favorite part was hanging out with the team, man. Hanging with the boys.
If I could give my September self a message, it will be to speak up when something doesn't seem right. Often our group members will be stubborn when approaching the project when trying to find a solution, while other members will be hesitant to speak and challenge their opinion.
If I could give my September self any advice, it would be to be more forthcoming with my own ideas and proposals.
Before Capstone, I preferred working individually, but after having multiple brainstorming sessions with my team members, I learned that it was easier to accomplish challenges collectively. Although our topic was a little challenging, it was very interesting and noteworthy. I got to collaborate with wonderful people, and the skills that I gained during these last 2 semesters will stay with me for a long time.
If I had the chance to go back to my September self, I would tell myself about all the exciting and unexpected changes to our design that kept our team on edge and eager to succeed. At first, I believed that this project would be straightforward and that our design would work from the first iteration. However, now I realize that things don't always go the way you planned, but that's okay because there's always a solution on the other end.
I would say don't plan things so rigidly. It's such a long-form project like this. I feel like you need to allow for some flexibility when planning, because things don't always go as planned. Finally, some reflections on the Capstone project as a whole. I would say communication is definitely key. If, for example, if you run into roadblocks, you don't have to wait for your weekly or your sprint meetings to bring it up. Just contact your group members, and getting those roadblocks out of the way quicker, or just communicating with your group in a timely manner, can help out a lot.
Throughout this course, I've been challenged to learn new things, apply my knowledge, work in a group, especially considering the circumstances of being online for most of the 2 semesters, and applying our strengths, our ideas, using them to find them, develop on them, create solutions into the product.
Looking back on my September self, I would tell myself to budget more time for the individual work packages. Each individual work package will likely take longer than you anticipate, and it's important to have some buffer room in terms of time so that you can handle any unforeseen problems that come up. Also, by having more time, you can have time to reach out for help and have a better chance of actually meeting your goals and resolving the issues.
So what would I say to my September self? I would say just take a step back and make sure you're just kind of soaking in the capstone experience. It's a really fantastic time, and so it's gonna go by a lot faster than what you would expect. So just make sure you're just kind of taking a step back and just enjoying the ride every so often. So what did I learn about myself? I feel like I learned that I really enjoy working on these long-term projects. It was a really awesome experience to see how much our project evolved and progressed over these past few months. It felt it was fantastic to watch and participate in.
What did I learn about myself is that I need to slow myself down. I am someone that wants to quickly jump into getting work done.
If I could talk to my September self, I'd tell myself that capstone isn't like any other school project. There's a reason they give you a full year, and then you really have to make best use of your time within that time period. Don't procrastinate and gradually build up your project.
Going into capstone, I was genuinely worried. I had heard from friends stories of strife, conflict, deception, and even incompetence. But looking back at the time in capstone, I wish I could just reassure myself that everything's going to be fine. Capstone made me question what I had wanted to pursue as a career, and it's honestly an experience I won't forget, that's for sure.
I know you're intimidated a little because you aren't too familiar with the students you're going to work with. But don't worry, you're going to make friends with this group of talented, like-minded young people, each with their unique skills and interests. You're going to feel defeated and insecure at times, but you're going to feel accomplished and proud at the end. You're going to be frustrated and exhausted. You're also going to be excited and relieved. You're going to face puzzles and difficulties. But with the help of your group members, you're going to defeat all your obstacles. Be diligent and don't be afraid to ask for help.
Going into capstone, I was expecting it to just be another project course, so I was pleasantly surprised when we started working on a real, marketable product. It was an experience coding in a production environment, and I got to learn when to focus on the big picture and just push something through, versus when to slow down and really polish the small details on whatever I was working on.
It's been really interesting and very rewarding for us to be in charge of our own project because, at least for me, it taught me what it takes to manage an engineering project from start to finish. I got to work with an amazing team and each member brought a different set of skills to the table, and I think because of that we were able to really zero in on our strengths and weaknesses, which allowed us to be very realistic when it came time to thinking about the feasibility of some of our designs. I think if I could give my September self one piece of advice, it would be to get comfortable with being uncomfortable. And I say that because comfort is a dangerous illusion in capstone. The projects we build in this course are really meant to push us to be the best engineering students we can be. But by the end, it was clear that those uncomfortable decisions that we made helped us to come up with the best possible solution for us.
Capstone has been more than just a project. It has been late nights and early mornings, code sprints and YouTube tutorial marathons, annoying bugs, and some really fun moments spent with my teammates. If there's anything I have learned about myself in these last 8 months, it is that I really enjoy working on technically challenging problems, rapidly prototyping, and working with an extremely competent group of people toward a common goal or objective.
Capstone was a great experience. I was able to work with a great team in a startup-like environment. We were able to work together to design and build the entirety of a multiplayer end-to-end system. This project made use of many software technologies, strengthening my skill set. I was able to learn from my teammates as well as build confidence in my understanding through teaching others.
If I were to go back and speak to myself in September, I would tell myself a lot.
I would tell myself to research the projects available for Capstone in more detail, and to narrow down my choices based on what aligns with my personal interests, what projects are going to have stakeholders that are willing to communicate with us, how useful this project will become post-graduation, as well as to manage my time more efficiently and to follow work breakdown packages more rigidly once they are created.
If I could go back to September and give myself some advice, I would say to make more contingency plans. Don't just make one contingency plan, make a plan for those contingency plans, because things are not always going to go as you'd hoped.
I would say to myself, start early and don't underestimate the project. It's a lot harder than you think. It's very difficult to get everybody on the same page and working all the time, but when you do, you can really create a magical project. So I was appreciative that Capstone gave me the project that I wanted and the experience to actually learn like project management in a school setting, and I hope to leverage that one day.
Some stuff that I would tell myself if I could go back to September and do this project again would be to first of all focus on the initial gates and put a little bit more of some work into them, because they're a lot more important than we think, especially documenting everything and making sure everything is organized in the beginning, because when you move on and you get to the later stages of the project and you didn't start off as strong and you don't have everything organized and ready and documented, then it becomes a lot more difficult.
What I would say to my September self is that capstone projects feel rather long and burnouts are likely to happen to you. My advice to avoid them is to try and have a good balance between the time you spend on and off the project. Don't try to define, execute, and report a task within a day just so you can forget about it for the whole week. Take the time to organize and reflect on your ideas so you don't end up creating poor documentation. I also want to add that the first official meeting you have with your team members will set the tone as to how future meetings will proceed. So make an effort to set a standard that you want.
There are 3 things that I would say to my September self. Number 1, choose your topic wisely. Number 2, choose your group members wisely. Number 3 is take it easy and enjoy the process.
First of all, what would I say to my September self? I would tell her to be more outspoken, irrespective of if I feel like my idea isn't the best. And I would tell her to keep being her and not give up, irrespective of the obstacles.
So what would you say to yourself in September? Well, I would try to get as much done in the first semester, since, especially at the end when everything has to come together. Right before exams, there's so many other projects and other assignments you have to deal with. It'd be nice to not have Capstone thrown into that mess. And overall, Capstone has been a really cool experience, as it gave me a chance to work with engineering disciplines on a really cool project, where if I was in a full-time programming job, I wouldn't really get exposed to something like this.
So, right off the bat, I just want to say that the experience I've had from Capstone has been nothing short of extraordinary. I've had the good fortune of working with wonderful people, and our team functioned really well. We took every challenge with a positive attitude, and I would say we have done an extremely good job. So I'm proud of my teammates. It has been an absolute pleasure working with you all.
Capstone has been a very interesting course, and it taught me many things that I'm thankful for. It pushed me to test my limits and to always be on the lookout for an opportunity to improve or gain experience with something I'm not familiar with.
I have learned many things throughout these 8 months, things that have taught me how to challenge myself in difficult situations, and things that have showed me where I lack the most and how I can improve upon them. And one important thing that I've learned about myself that I would like to share is how determined I can be to finish a task when given, despite other difficult things I may have to do at that time and challenges of that task.
After a year full of ups and downs to the Capstone journey, there are 3 key takeaways that I want to talk about. The first one is something that I would like to tell my September self, which is try to be as communicative as possible while also trying to work on the UI elements of the things, as I've been more of a back-end kind of guy who has been handling the project management aspects of the Capstone journey as well. The final thing is the reflection on the Capstone experience, which has been a great experience. It feels like I'm working in a startup, and that really helps for me because I want to start my own startup. Hence, it has been a great journey and I would do it again.
If I think about something I will tell myself in September, it's probably going to be, it's okay if I don't know everything, and I will learn everything during this journey with the time.
If I had to go back to my September self, I would tell him 2 things. First, project management should fit the team, And if the method being used for project management is not working for the goals your team has, it's okay to change it. For a team of this size, focusing on the way the project is being managed is far less important than the outcome of the management. Secondly, I would tell him to be more thorough in documenting decisions made by the team so that it's easier to look back months later and figure out why we decided to go a certain route.
Working on this team has been an incredibly rewarding experience. We have faced a lot of challenges over the past 7 months. The main challenge was figuring out how to implement our design with another piece of equipment used in a lab under a highly constrained environment. One thing I learned about myself is that I don't like CAD modeling as much as I thought I did. I would describe Capstone as the ultimate challenge of an engineering student, like the final boss battle you must beat before you go out into the real world.
To my September self, I would say before doing any piece of work, take a moment to determine what you're doing, why you're doing it, and what outcomes you expect to achieve. It's something easy to neglect since we're always given concrete instructions and pre-cooked problems in undergrad, but it's something that really helps build momentum.
Throughout my capstone journey, I have become more aware of my strengths and weaknesses. One of the weaknesses would be my communication skills.
It's really tempting to redesign your capstone multiple times to make it a little bit more efficient. And finally, I got super lucky. I had an amazing group. And yeah, it definitely makes the whole experience awesome, a lot more pleasant, and definitely easier. So get yourself a good group.
For my September self, I would tell myself to honestly live in the moment, not stress about so many things, because I'm only now realizing how much I'll miss the everyday student life. And in terms of capstone, I would actually tell myself to ration my time properly and think ahead of time before doing anything else.
Don't underestimate yourself. You and your teammates are going to grow so much together. You're going to learn so much from each other. And I may be saying this because of the high of recently completing it, but I don't think anything is out of your reach. You have the knowledge, you have the background, you have the tools. Just go and try the craziest thing because you can make it work some way, somehow.
What would I say to my September self 8 months ago?
So one thing I would tell my September self is to not hesitate to try out a variety of new tasks. So even if things are unfamiliar to me or I feel myself lacking the needed skills, just by taking up the challenge, you give yourself an opportunity to learn something new. And all in all, I would say that my capstone experience has been very rewarding because I got to meet a talented team of future engineers, and together we were able to create a project that has real potential to help the healthcare industry, and I think that's very satisfying.
Some things that I would tell my September self is to not be afraid and try something outside of your comfort zone. Have faith in your teammates. Remember that you're all sharing the same goal, that you each want to succeed and build something awesome. Overall, it was emotional, it excited me, and it beat me to the ground. But in the end, I gained some amazing friends, experiences, and memories that I will never forget and I will hold on to for life.
I would tell my September self that it's extremely important to stay on top of your work. Having a good team effort goes a long way, so make sure to divide work evenly in the starting. I also learned about myself that I tend to get overwhelmed fast, but this can be overcome with good time management strategies and communication with the team.
I learned that I'm a lot more productive when I'm able to go to campus or just get out the house and work somewhere else. I realized that no matter how complicated or smart your design is, sometimes you just forget the most basic things. For example, I forgot that plastic can't go through plastic. Don't ask me.
I want to tell my September self to kind of set deadlines and to really be on top of those deadlines, because it really helped me finish up my parts of the project and to finish up small little details instead of procrastinating or saving it for a different week. So I learned that I needed to be more confident and that I needed to kind of show my ideas to my team, and they were lovely and helped me really gain that confidence.
What I would tell myself in September is that even though you have 8 months and it's a lot of time, it can go by pretty quickly, and it's easy to think you have more time than you do, especially when you factor in all the other courses and meetings with other people, especially if you have a big group.
I would have told my September self that setbacks will happen, and they did actually happen, and it's okay even if things don't go planned the way we initially envisioned. You have to be very flexible and adaptable to changing circumstances, and you have to plan accordingly if things don't work out.
Something I would have told myself in September would be that keeping things simple, especially when it comes to planning or design, is always best, and that productivity suffers when things get too complicated. It's easy to lose sight of this, so always make sure that your goals and priorities are in check.
I would say to my September self, enjoy the process. Don't worry about the learning curve. Everything will work itself out in the end.
Overall, Capstone has been really challenging, but also extremely rewarding. It was interesting to work in such a large group and see a long-term project from start to finish.
In terms of something I learned about myself during this whole process or just this course in general, is that I learned that I'll be great at working in a smaller team rather than a bigger team, and I'm glad I worked with the team I did.
I would tell my September self that you're going to be working on an amazing project with super awesome people. And there will be a learning curve. With perseverance, you can achieve all your goals.
I would tell myself to pace myself. A year is quite a long time, and I would also remind myself to simply enjoy the ride, as this is one of the final courses.
Over the last 7 months, I've probably learned more than I learned in all 5 years that I spent with Lassonde. I would say, research your project thoroughly before choosing it. Yes, picking the right team members makes doing the project work much more enjoyable, but not even the perfect team is going to be able to overcome the mountains of challenges that come with a loosely defined, unplanned project. Reflecting back on my capstone experience, I would say my favorite part was hanging out with the team, man. Hanging with the boys.
If I could give my September self a message, it will be to speak up when something doesn't seem right. Often our group members will be stubborn when approaching a project when trying to find a solution, while other members will be hesitant to speak and challenge their opinion.
If I could give my September self any advice, it would be to be more forthcoming with my own ideas and proposals.
Before Capstone, I preferred working individually, but after having multiple brainstorming sessions with my team members, I learned that it was easier to accomplish challenges collectively. Although our topic was a little challenging, it was very interesting and noteworthy. I got to collaborate with wonderful people, and the skills that I gained during these last 2 semesters will stay with me for a long time.
If I had the chance to go back to my September self, I would tell myself about all the exciting and unexpected changes to our design that kept our team on edge and eager to succeed. At first, I believed that this project would be straightforward and that our design would work from the first iteration. However, now I realize that things don't always go the way you planned, but that's okay because there's always a solution on the other end.
I would say don't plan things so rigidly. In such a long-form project like this, I feel like you need to allow for some flexibility when planning because things don't always go as planned. Finally, some reflections on the Capstone project as a whole. I would say communication is definitely key. If, for example, if you run into roadblocks, you don't have to wait for your weekly or your sprint meetings to bring it up. Just contact your group members, and getting those roadblocks out of the way quicker or just communicating with your group in a timely manner can help out a lot.
Throughout this course, I've been challenged to learn new things, apply my knowledge, work in a group, especially considering the circumstances of being online for most of the 2 semesters, and applying our strengths, our ideas, using them to find them, develop on them, create solutions into the product.
Looking back on my September self, I would tell myself to budget more time for the individual work packages. Each individual work package will likely take longer than you anticipate, and it's important to have some buffer room in terms of time so that you can handle any unforeseen problems that come up. Also, by having more time, you can have time to reach out for help and have a better chance of actually meeting your goals and resolving the issues.
So what would I say to my September self? I would say just take a step back and make sure you're just kind of soaking in the Capstone experience. It's a really fantastic time, and so it's gonna go by a lot faster than what you would expect. So just make sure you're just kind of taking a step back and just enjoying the ride every so often. So what did I learn about myself? I feel like I learned that I really enjoy working on these long-term projects. It was a really awesome experience to see how much our project evolved and progressed over these past few months. I felt it was fantastic to watch and participate in.
What did I learn about myself is that I need to slow myself down. I am someone that wants to quickly jump into getting work done.
If I could talk to my September self, I'd tell myself that Capstone isn't like any other school project. There's a reason they give you a full year, and then you really have to make best use of your time within that time period. Don't procrastinate and gradually build up your project.
Going into Capstone, I was genuinely worried. I'd heard from friends stories of strife, conflict, deception, and even incompetence. But looking back at the time on Capstone, I wish I could just reassure myself that everything's going to be fine. Capstone made me question what I had wanted to pursue as a career, and it's honestly an experience I won't forget, that's for sure.
I know you're intimidated a little because you aren't too familiar with the students you're going to work with. But don't worry, you're going to make friends with this group of talented, like-minded young people, each with their unique skills and interests. You're going to feel defeated and insecure at times, but you're going to feel accomplished and proud at the end. You're going to be frustrated and exhausted. You're also going to be excited and relieved. You're going to face puzzles and difficulties. But with the help of your group members, you're going to defeat all your obstacles. Be diligent and don't be afraid to ask for help.
Going into Capstone, I was expecting it to just be another project course, so I was pleasantly surprised when we started working on a real, marketable product. It was an experience coding in a production environment, and I got to learn when to focus on the big picture and just push something through, versus when to slow down and really polish the small details on whatever I was working on.
It's been really interesting and very rewarding for us to be in charge of our own project because, at least for me, it taught me what it takes to manage an engineering project from start to finish. I got to work with an amazing team and each member brought a different set of skills to the table, and I think because of that we were able to really zero in on our strengths and weaknesses, which allowed us to be very realistic when it came time to thinking about the feasibility of some of our designs. I think if I could give my September self one piece of advice, it would be to get comfortable with being uncomfortable. And I say that because comfort is a dangerous illusion in Capstone. The projects we build in this course are really meant to push us to be the best engineering students we can be. But by the end, it was clear that those uncomfortable decisions that we made helped us to come up with the best possible solution for us.
Capstone has been more than just a project. It has been late nights and early mornings, code sprints and YouTube tutorial marathons, annoying bugs, and some really fun moments spent with my teammates. If there's anything I have learned about myself in these last 8 months, it is that I really enjoy working on technically challenging problems, rapidly prototyping, and working with an extremely competent group of people toward a common goal or objective.
Capstone was a great experience. I was able to work with a great team in a startup-like environment. We were able to work together to design and build the entirety of a multiplayer end-to-end system. This project made use of many software technologies, strengthening my skill set. I was able to learn from my teammates as well as build confidence in my understanding through teaching others.
If I were to go back and speak to myself in September, I would tell myself a lot. I would tell myself to research the projects available for Capstone in more detail, and to narrow down my choices based on what aligns with my personal interests, what projects are going to have stakeholders that are willing to communicate with us, how useful this project will become post-graduation, as well as to manage my time more efficiently and to follow work breakdown packages more rigidly once they are created.
If I could go back to September and give myself some advice, I would say to make more contingency plans. Don't just make one contingency plan, make a plan for those contingency plans because things are not always going to go as you'd hoped.
I would say to myself, start early. And don't underestimate the project. It's a lot harder than you think. It's very difficult to get everybody on the same page and working all the time, but when you do, you can really create a magical project. So I was appreciative that Capstone gave me the project that I wanted and the experience to actually learn like project management in a school setting, and I hope to leverage that one day.
Some stuff that I would tell myself if I could go back to September and do this project again would be to first of all focus on the initial gates and put a little bit more of some work into them because they're a lot more important than we think, especially documenting everything and making sure everything is organized in the beginning, because when you move on and you get to the later stages of the project and you didn't start off as strong and you don't have everything organized and ready and documented, then it becomes a lot more difficult.
What I would say to my September self is that Capstone projects feel rather long and burnouts are likely to happen to you. My advice to avoid them is to try and have a good balance between the time you spend on and off the project. Don't try to define, execute, and report a task within a day just so you can forget about it for the whole week. Take the time to organize and reflect on your ideas so that you don't end up creating poor documentation. I also want to add that the first official meeting you have with your team members will set the tone as to how future meetings will proceed. So make an effort to set a standard that you want.
There are 3 things that I would say to my September self. Number 1, choose your topic wisely. Number 2, choose your group members wisely. Number 3 is take it easy and enjoy the process.
First of all, what would I say to my September self? I would tell her to be more outspoken, irrespective of if I feel like my idea isn't the best. And I would tell her to keep being her and not give up, irrespective of the obstacles.
So what would you say to yourself in September? Well, I would try to get as much done in the first semester, since, especially at the end when everything has to come together right before exams. There's so many other projects and other assignments you have to deal with. It'd be nice to not have Capstone thrown into that mess. And overall, Capstone has been a really cool experience, as it gave me a chance to work with engineering disciplines on a really cool project, where if I was in a full-time programming job, I wouldn't really get exposed to something like this.
So, right off the bat, I just want to say that the experience I've had from Capstone has been nothing short of extraordinary. I've had the good fortune of working with wonderful people, and our team functioned really well. We took every challenge with a positive attitude, and I would say we have done an extremely good job. So I'm proud of my teammates. It has been an absolute pleasure working with you all.
Capstone has been a very interesting course, and it taught me many things that I'm thankful for. It pushed me to test my limits and to always be on the lookout for an opportunity to improve or gain experience with something I'm not familiar with.
I have learned many things throughout these 8 months, things that have taught me how to challenge myself in difficult situations, and things that have showed me where I lack the most and how I can improve upon them. And one important thing that I've learned about myself that I would like to share is how determined I can be to finish a task when given, despite other difficult things I may have to do at that time and challenges of that task.
After a year full of ups and downs to the Capstone journey, there are 3 key takeaways that I want to talk about. The first one is something that I would like to tell my September self, which is try to be as communicative as possible while also trying to work on the UI elements of the things, as I've been more of a back-end kind of guy who has been handling the project management aspects of the Capstone journey as well. The final thing is the reflection on the Capstone experience, which has been a great experience. It feels like I'm working in a startup, and that really helps for me because I want to start my own startup. Hence, it has been a great journey and I would do it again.
If I think about something I will tell myself in September, it's probably going to be, it's okay if I don't know everything, and I will learn everything during this journey with the time.
If I had to go back to my September self, I would tell him 2 things. First, project management should fit the team, and if the method being used for project management is not working for the goals your team has, it's okay to change it. For a team of this size, focusing on the way the project is being managed is far less important than the outcome of the management. Secondly, I would tell him to be more thorough in documenting decisions made by the team so that it's easier to look back months later and figure out why we decided to go a certain route.
Working on this team has been an incredibly rewarding experience. We have faced a lot of challenges over the past 7 months. The main challenge was figuring out how to implement our design with another piece of equipment used in a lab under a highly constrained environment. One thing I learned about myself is that I don't like CAD modeling as much as I thought I did. I would describe Capstone as the ultimate challenge of an engineering student, like the final boss battle you must beat before you go out into the real world.
To my September self, I would say before doing any piece of work, take a moment to determine what you're doing, why you're doing it, and what outcomes you expect to achieve. It's something easy to neglect since we're always given concrete instructions and pre-cooked problems in undergrad, but it's something that really helps build momentum.
Throughout my Capstone journey, I have become more aware of my strengths and weaknesses. One of the weaknesses would be my communication skills.
It's really tempting to redesign your Capstone multiple times to make it a little bit more efficient. And finally, I got super lucky. I had an amazing group. And yeah, it definitely makes the whole experience awesome, a lot more pleasant, and definitely easier. So get yourself a good group.
For my September self, I would tell myself to honestly live in the moment, not stress about so many things, because I'm only now realizing how much I'll miss the everyday student life. And in terms of Capstone, I would actually tell myself to ration my time properly and think ahead of time before doing anything else.
Don't underestimate yourself. You and your teammates are going to grow so much together. You're going to learn so much from each other. And I may be saying this because of the high of recently completing it, but I don't think anything is out of your reach. You have the knowledge, you have the background, you have the tools. Just go and try the craziest thing because you can make it work some way, somehow.
Great, well, wonderful reflections we've just had. Hopefully you've all had a chance to grab some food. We're still 6 minutes out from the start of the afternoon panels. So do take the chance to grab a drink, grab whatever you need for the afternoon. We have 2 panels still to go. If you are in panel 5, do start raising your hand so we can get you promoted into panelist. We will get onto that shortly. Just to let you know, the 2 panels we still have coming. The first starts at 1:20. We will get going at 1:20 with panel 5. We have 6 teams. The focus of panel 5 is environmental challenges. We have a team looking at household appliance for plastic recycling. We have a team looking at a buoy system to meet government needs for water monitoring. We have an offshore oil skimmer project. We have a climate controller for a large greenhouse. We have a second ocean water cleaning project, and we have an underwater ROV project. So a number of water-based environmental projects and some others in panel 5. In panel 6, we have 4 teams. That's our final panel of the day. Mechatronics and Instrumentation. So we have a team that has built an industrial clothing shredder. We have 4 teams who are looking at robotics-based projects. 2 looking at soil sampling, soil collecting for a rover, and 2 who've looked at a robotic wrist for a rover. So that's our panel 6. After 3 o'clock, we will have a deliberation by our judges, and we will in parallel have a trivia quiz that you are encouraged to stay for. The judges will disappear into a different Zoom room, and in the main room we will have our trivia quiz. We will then start the awards at 3:45. So we've still got 2 exciting panels to go. Just a reminder of who our judges are for today. We have Anton Gallego, John Unnusoy, who's a past student, Gabriel Decoteau, Jason Thomas, Josh Abraham, who's also a past student, Kishon Webb, Steve Jar, Tom Granat, and Hania Ali, who's also an alumna. So that is our list of judges, and we're very grateful for their support for the activities today. If there are any people in panel 5 who have not yet been promoted to panelist, do raise your hands. We've got most of you in, but we do want to make sure that we get all the panelists for panel 5 in ahead of time. So raise your hands now virtually in Zoom if you are one of the students in panel 5, and we'll make sure you get promoted to panelist. We will kick off the video shortly. We've got another couple of minutes before we get going. A reminder, hopefully you've had a chance for a good lunch. We've had a chance to meet up some of the students who are here on campus. It was great to see them all. The video that we watched at lunch was really some inspirational words that people were sharing on what they learned from this journey, what they wanted to share. with their September selves that hopefully future students can take away and learn from. And we will be getting started shortly. The panel 5 is focused on environmental challenges, panel 6 on mechatronics and instrumentation. Just a reminder, at 3:45 we will have the Lassonde Awards ceremony. It's combined between civil engineering and ENG 4000, so we'll have all the engineering students together. And then at 4:15 we will join up with the YCN Awards group to have the campus-wide awards. There are 2 awards available for ENG 4000, the ENG 4000 Capstone Prize and the PEO Award. And we will also have a couple of civil engineering awards before we move over to the YCN Awards at the end of the day. And don't forget the trivia game whilst we're off judging. We have Sogand and the IT support hosting, and we have some fun things to look forward to during that. And it is 1:20, so if we could kick off the introductory reel for panel 5.
The ocean is massive, terrifying, and nearly endless for someone lost at sea. These helpless people wish of being found in time by search and rescue operations. The Canadian Coast Guard, in collaboration with Lake Wet Dry Telematics, can help. The Lake Wet Dry SLDMB is a zero leeway device that can drift due to ocean currents and find lost parties, essentially saving lives. The SLDMB uses state-of-the-art design with no solid waste parachute that a traditional SLDMB has, which is discarded into the ocean and could harm wildlife. The buoy also utilizes an effective drogue flap system, which conveniently folds into the body and when deployed will catch underwater currents and drift in the sea. At Lake Wet Dry, we save lives and look good doing so because we hate big buoy.
For our project, we are doing an oil skimmer and our team name is Skim Skimmer. This is our team. We have Andre, Tristan, Gordon, Santosh, Herman, Ahmed, and Adrian. Time is the utmost factor when it comes to oil spills. With every hour after the aftermath of an oil spill, the concentrated patch of oil starts to split off into smaller pieces and disperses itself further away from the point of origin. This effect becomes so prominent that if the cleanup process does not happen quick enough, the square area of the oil spill increases significantly, and this greatly affects ecological life. The Canadian Coast Guard is the lead federal agency responsible for ensuring the cleanup of any pollution spills into the waters under Canadian jurisdiction. As per the Canadian Coast Guard contract, our group will be developing an oil skimmer to meet their requirements.
And here's a quick look at our final design. Thank you for watching.
Hi, we are Team M, and our project was to make an underwater ROV to clean the ocean water. Our first task will be related to replacing a dirty mesh net of a sea bin under the ocean. To do this, we need to first disconnect the power and bring it back up to the surface. After that, we needed to replace the dirty mesh net with a fresh new clean one. After the mesh net replacement, we needed to connect the power plug back.
Our next tasks focus on remediation. We start by collecting floating debris on the ocean surface. We then move on to removing ghost nets from mid-water level. To do this, we first disconnect a pin, which simulates the cutting of the ghost net, which allows the ghost nets to float upwards, and we collect both the pin and the ghost net from the surface. After this, we collect plastic debris from the bottom of the ocean floor.
For decades, the world has been coming up with solutions to remediate the marine debris crisis, as there are over 5 trillion pieces of plastic debris in the ocean. Of that mass, 269,000 tons float on the surface, while some 4 billion plastic microfibers litter the deep sea. Among the countless existing solutions, Team N has also joined the ocean cleanup movement with their own underwater remotely operated vehicle. The 65 by 40 by 30 centimeter ABS piping constructed vehicle is equipped with 6 thrusters, of which 4 is facing forward and 2 facing upwards to allow complete control of the ROV across all 3 axes. Additionally, the ROV includes a high-definition waterproof camera for full vision underwater, as well as a claw to manipulate and extract items both on and under the water. Controls and live camera feed are wired to the master controller and displayed on a user interface that can be displayed on any electronic device with a Wi-Fi connection. Although the ROV is a lot less significant and smaller scale than other solutions, Team N is eager to take this first small step into what can become a bigger project. After all, no matter what solutions are out there, everyone is trying to clean up our ocean, one marina at a time.
Thank you, panel 5. So we've had our introductions to this group. We have 5 projects very much focused on environmental issues. 1 project that has sort of dual purpose, can really think about search and rescue support in terms of the buoy that meets those needs as well. So to kick off panel 5, I'd like to ask all the teams really what makes your project an important part of either an environmental solution for 5 of you, or that bigger solution around supporting search rescue and so on for Team F. So Team AC, why is this household appliance for plastic recycling an important part of addressing environmental issues?
Hi, Franz.
Hi.
I think for Team AC, I think our design is very important for the environment, as we basically tackle the large issue of plastic recycling, and we bring that to the household level. Not a lot of people realize, but I think something like 10% of plastic that gets sent to the recycling facilities actually get properly recycled. So that's a very big issue. And what our design does is it tackles that at the household level, so that we can try to allow for these specific materials to be like compacted in a certain way, so that once they get delivered to the recycling facilities, they can properly be recycled.
Thanks, Brody. So really allowing individual households to play a part, recognizing this is a big part of that environmental footprint that we have.
Yeah.
Okay, so Team F, thinking about your project, in what way does this fit into a bigger system of protecting our waters?
So I think that by making a low-cost solution for the buoy, we think that the Canadian Coast Guard will be able to deploy more, which should increase their rate of success on their search and rescue missions. Since it's so cost effective, we believe, like, just from volume, they should be able to gain more data, because they never know what their what like terrain or environment they're going to go into for each mission. And from doing some background research, they have, like, in around 2020, they have around 950 Coast Guards that are just dedicated to search and rescue missions. So we believe that by increasing more, by giving them like a way to gain more data, it should also like help with their like
their like lack of like manpower, I guess.
Yeah, thanks, Jen. So the whole idea around having a larger set of data available to them to know where things are drifting and to know where to find people who need help. Great, thank you. Team G, in what way does your oil skimmer really change the landscape in a way for addressing offshore pollution issues?
So as mentioned in my video, we do know oil spills do cause detrimental effects on ecosystems. For example, or one of the main examples over the last decade is the BP oil spill. We know that that was one of the biggest oil spills like in the world. And it did have large detrimental effects to the ecosystem, killing a lot of fishes, sea turtles, and etc., and actually damaging the ecosystem. So time is obviously an utmost factor to clean up the oil spill as fast as possible to prevent this damage to the ecosystem. So our whole main reason for building this project is the Canadian Coast Guard submitted a bid out to build an oil skimmer as their equipment was aging and it wasn't up to par to today's standards. So for our specific oil skimmer, what we're trying to do is we're trying to provide a more updated and more advanced model to that of the Canadian Coast Guard oil skimmers. So one of the main things that separates our oil skimmers to other ones in industry is we do have an added autonomy section, also modular components, and increased oil collection rate. And on top of that, it's also very feasible and cheap to create.
Yeah, so the ability to deploy a lot of these autonomously at a low cost could really change the amount of oil that we could collect rapidly after a, yeah, thanks, Gordon. Okay, Team K, thinking about large greenhouse climate control, in what way can you have an impact on the larger global effects? Who wants to take it up for Team K?
Yes, so by using the controller, we'd hopefully be able to minimize the inputs to food production and as well as reducing the amount of distance that food needs to travel, which would hopefully eliminate a lot of wasteful inputs that aren't productively used in the food production process.
Yeah, so by basically providing a solution that could work in a local context to manage that in more extreme environments, then you can both have a relatively energy efficient and local solution for that. Thanks, Ashar. Team M, in what way is your ROV addressing water pollution issues?
Yeah, so overall, the goal of our project was to focus on the remediation aspect of cleaning up our oceans, because as we all know, the root problem of cleaning up the oceans is a big issue that will take like a combination of government policies and a lot of money and a lot of time. So the way ours affects the global scale is actually doing the small parts of cleaning up what we already have. There are bigger scale solutions on how to clean up some of the, or how to lessen the pollution in the ocean already. But we're focusing on remediating and helping those things. So for example, something like a sea bin, which is already collecting trash and making sure that doesn't go to the ocean, our ROV would be something that's assisting those bigger solutions and cleaning up everything around it.
Yeah, and we know realistically that we'll need these solutions for the foreseeable future, as you say, because to get those policies in place will take some time. Great, thanks, Team M. And on to Team N.
So as we know, ocean pollution is always a major issue in terms of environmental risk and damages. It's very much so up there with air pollution. And the effects and damages from this pollution can result in irreversible changes for ocean ecosystems. So our ROV does not really it can apply to both oceans or any sort of smaller bodies of water. It just has to be scaled up or down in terms of power consumption, thruster power, things like that. But its garbage collection can apply to all sorts of bodies of water. So we wanted to really try to implement a design that could be placed in different types of scenarios. And with our ROV being easily accessible, low cost, the design can be implemented in all these areas where ocean pollution basically greatly affects multiple ecosystems.
Yeah, so recognizing the need for a solution that can cover parts of the sector that other solutions aren't necessarily focusing on. Thanks. Okay, so in the second question, what I'd like to do is explore some technical aspects of your project. So I think each of you have had certain areas where your project has struggled. So what was your biggest technical challenge, and what would you say you would do to address that going forward, or how did you address it if you've managed to resolve it? And I'll go in reverse order for this one. So back to you, Team N. What was your biggest technical challenge in designing your ROV, and how would you address it going forward?
I think one of the struggles we had with regards to the design was the claw. We only really had one claw design that we actually had on the final prototype. And I think it failed almost immediately when we started testing in the pool. So had we planned a little bit better in terms of, I don't know, possible other designs you could have used, or just having multiple iterative tests just to test the claw, would have been great. I mean, the one disadvantage we had was we had very limited time with the Tate McKenzie pool to actually test our whole ROV. So realistically, we probably only had one chance to test a claw anyways. That was one of the more, I think one of the biggest technical challenges was just that claw.
Thanks, Jay. So over to Team M. What was your biggest challenge, and what would you do to address it?
Hi. So the greatest challenge we faced 100% was waterproofing. Like naturally, if any water leaked into our electrical components, it could cause like any damages and major setbacks, which we really couldn't afford in both the time and financial sense. In addition, a lot of our components were only available online, and for some of them, the shipping time was simply too long to arrive in time. Another disadvantage of like water leaking in is, aside from, you know, actually just water damage, is water leakages could also impact our ROV movement. So our ROV is specifically calibrated for a specific weight and relies on buoyancy to move upwards. If any water would leak into our device, the overall weight of the ROV would also increase. And eventually it would reach a point where basically our ROV could not move upwards anymore. In addition, the increased weight would prevent the ROV from moving in the horizontal plane as fast as it should, and would be much harder to move. So in order for us to like waterproof our ROV perfectly, we used project boxes. So essentially our project boxes would contain a rubber gasket. The rubber gasket would act as a watertight sealant and prevent water from getting into our waterproof boxes. In our waterproof boxes, we would contain all our electrical components like our motors, our camera, anything that couldn't get water on them. In order to connect the project boxes to each other, for example, if one project box has a battery, one has a component that requires power, we would first drill a hole into the project box, connect the PVC watertight connector, and connect the hose between the two ends of the waterproof connectors. So essentially, if we had a box with batteries and a box with electrical components, we would place the wires through this PVC hose and have a connection between the two. In addition, just to make sure everything was like 100% waterproof, anything water related, we coated in a layer of silicone or electrical tape, just in case anything went wrong and just in case water started leaking in, we wanted to be 100% sure that no water damage would occur.
Thanks, John. I've lost track of which team we're on. We've just had Team M, so if we could come to Team K next. What was your biggest?
The thing we struggled with the most was dealing with our project as an integrated system. Because we were all developing things on our own and we had our subsystem that we were each working on, we didn't really consider the difficulty of integrating it all into a single functioning whole. Had we realized this, we would have started off with a more cohesive framework within which we could have implemented our subsystems and tested as we went along, as opposed to developing piecemeal and hoping that everything fit together and interlocked nicely.
Yeah, so that integration piece, thinking about it right from the beginning all the way through.
Mm-hmm.
Yeah. Thanks for that, Ashar. For the Team G, the oil skimmer team, what was your biggest technical issue?
So we faced a couple issues when we were doing our project. One was manufacturing. So one thing we realized when we were doing manufacturing was not only the assembly, but some of the components that we bought were quite weak material. So when you see our product, we use a storage bin as our main container to be the main body to assemble all the components together. But we realized the plastic that we purchased at that moment was too weak. So we would have to buy other components to replace the bin. Some motors, a motor that we purchased to rotate the drum, we realized was too fast. We can control that with like a voltage controller or something like that. But we realized that even if we try to change the sensitivity from that, it wouldn't have an overlasting effect. We would have to use a weaker motor to get the proper speeds that we need. Another big factor was, as we all know, COVID has been lingering around us all the time. So a lot of our members, they get COVID, which affected us to grab components or give each other stuff. So when we come to assembling or manufacturing our actual final product, that took quite a little longer to get everything together.
Yeah, thanks. So thinking about maybe material strength and finding off-the-shelf components that fits that, and then thinking about some of those practical issues with the team dynamics. Yeah, thanks for that. Team F, what was your biggest challenge?
Yeah, so our biggest challenge was definitely the electronics. We're like a smaller team of 4, and we're all mechanical engineers. So doing the electronics was definitely pretty difficult for us. But the way we sort of addressed that was trying to buy as many pre-built solutions that we could. So we bought a temperature sensor that was very simple to use. We used a Raspberry Pi because our supervisor was able to help us using that. And then we actually had initially bought a GPS sensor that used a serial input, and that was pretty difficult to use. And then it actually ended up malfunctioning pretty late in the project. So luckily we were able to purchase a USB sensor, which was very, very easy to use in comparison. And so that was sort of the way we kind of worked around that challenge and kind of overcame that one.
Yeah, so really thinking about where are the strengths within the team. For the areas that are weak, go for those off-the-shelf solutions to meet the need, and work with solutions that you've got previous knowledge or somebody can give you that knowledge on. Great, thanks, Josiah. And Team AC, what was your biggest challenge?
We are also all mechanicals in our group, so we also had some challenges on the electrical side of the project. Our main challenge was supplying enough current to heaters. We tested all the heaters like one by one in the testing phase, but when we actually implemented it, when we were running all of them at the same time, we saw that we couldn't heat them up to the required temperature. So what we had to do was changing the code so that each heater would run like sequentially, one small heater would run and then the large heater would run, so that we could seal the final product, the sides of the compacted plastic bag. We still couldn't solve the problem like thoroughly. We still had like only 2 sides covered and sealed up, but it was a good solution, even though it didn't solve the whole problem. Yeah.
Yeah, so even though thermally you knew what you wanted, the electrical challenge of getting that power distributed to you is the challenge. Yeah. Great, thanks, Idris. So what we're going to talk about next is for the water-based teams, question of power sources, and for the Team AC, I'll dig into different types of materials. So for the water-based teams, I'd like you to think about what was your choice for power source and what would you need to do as a power source if you were to be able to be independent in a water location, knowing that some of you have tethered solutions. What would you do to make that untethered? And those of you who have it powered remotely, what challenges did you have around powering in a water environment? So if I can maybe start with Team N on that one. Who wants to take it?
Hey, yep. Hello, Professor.
Hi.
So you're asking pretty much about the how we kind of got around powering our ROV without like
damaging any of the connections or anything? Is that the question?
So thinking about, because you had a tethered solution, if I remember rightly.
Yes, yes.
So what would you have to worry about if you were to move that to an untethered solution?
So I think the untethered solution would be a lot more complicated because that has to rely on either like a Bluetooth or like some sort of wireless interface communication from essentially our control board to the onboard electronics. We'll probably have to consider installing like multiple lithium-ion batteries that of course have to be waterproof, and we'd have to, and like those batteries might not even last very long, so we need to figure out pretty much a better way of allowing the ROV to travel long distances while maintaining that connection with our controls, as well as ensuring that it's not going to just like shut down on us because there's no more power from the batteries. So I think that's how we would kind of approach a wireless ROV.
Okay, thanks for that, Justin. Same question to Team M.
So for us, we actually faced this problem already. So since our initial power supply of 12 volts was not nearly enough to power all of our motors, we had to switch into individual power sources for each of the motors. So we selected a cheaper alternative, even though it's less environmentally friendly, but the batteries we picked were SLA batteries, which are sealed lead acid batteries. So for each propeller, we had a 12-volt battery connected to the rover. So this solved our problem of the tethered power, but it introduced our very basic problem again, which was waterproofing. So our project revolved around the fact that the batteries would be in the rover itself, and we would keep the box waterproof. And again, while testing, we realized this was much more difficult than we thought it would be. And if we were to go for a completely wireless solution, our project would work if waterproofing was available, or if we could manage to do it properly, because the Arduino boards that we implemented already had a Wi-Fi module available, and we could have easily implemented it if we needed to. But since our guidelines did not require us to, we used a 25-foot tether.
Okay, great. Thanks, Shahan. And same question for Team G, in terms of managing that autonomy. What were the challenges around that, making it standalone?
Yeah, so for our team, like the main problem we had with power was really just waterproofing and making sure that our design would run, all the time. So we had to split our power supply similar to other teams. The controls, like the controls power versus the operation power. So the operation is, pumping the oil, and the controls is just moving the oil skimmer around in the water. So those have two separate systems. And also, we also made sure that, we got quote unquote big enough batteries. Like, you don't want to get huge batteries, because if those fail, it's also very expensive to replace for the design and whatnot. So we got, decent sized batteries for the project. Waterproofing was another issue with power in general, but that was taken care of by the mechanical design. We had our design had like waterproofing like in the mechanical design, so we didn't really have to do anything too special for waterproofing. All of our electricals were stuck in a box somewhere, so that was pretty nicely done.
Yeah, thanks, Em. And of course, nominally you're skimming the water in relatively calm conditions on the top, so that's a benefit as well. But yeah, thanks. So for team K and AC, I've got a slightly different question. For AC, how well does your system handle different bag types or sizes or thicknesses, or what does your design do to address that? Problems of heating notwithstanding. Who in AC would like to pick up that question? How do you deal with different types of bag, different sizes, different thicknesses?
I'll take that question. So we catered our design to be specifically towards LDPE plastics, which is type 2 in the little triangular symbols that you see. So we catered our build towards that type of plastic, and we know that each plastic has a different melting point, has a different density, so they all have to be handled differently. Our design as a whole, we used steel for the compression chamber, and we knew that this type of plastic wouldn't stick to the walls. so we wouldn't have any problems there. And we also catered our temperature towards that specific melting point, so that we can seal the sides around our final product. But as a whole, our design could be implemented towards other types of plastics. It would simply be a matter of changing the temperatures, changing the force from the actuators and how much they compress and densify the product, and potentially changing the material that's actually used within the compression chamber if there's issues with sticking, as I mentioned earlier.
Yeah, great. Thanks, Brody. Those are the key constraints that you would have to. Great, perfect. And so for Team K, thinking about unintended consequences, how have you thought about addressing failures in your system to avoid, flooding a greenhouse or making it too warm, too cold, issues like that? Who in Team K would like to pick up that question? Or I will pick on somebody. So thinking about failure management in your system design, perhaps I can put that question to Tristan.
For failures, we mostly relied on the PID control to monitor the greenhouse, but for overflooding, for overflooding and all that stuff, we didn't really take that into account because we didn't implement any sprinklers.
Yeah. So what would you do to address? What would you have to do to your design to actually handle monitoring for failures based on what it currently does?
That's something I have to think about.
Okay, no worries.
Yeah, we didn't really take that into account, so that's why.
Okay, no worries, Tristan. You have a design that's designed for a nominal case, so that's okay. So my next question, I actually want to dive into a little bit on project management process that you went through over the year. So I believe all the teams in this panel went through the waterfall design process. So where did you find the biggest challenges in running a waterfall project, and where did you find the project management was working well for you? And if I could start with Team G on this one, what was working well on your project management? Where did you have challenges?
Yeah, so definitely for waterfall, for the project management style for waterfall, there are a lot of pros and cons. And one of the cons we experienced is we didn't actually start building the project until I think maybe gate 5 or gate 6. And obviously when you're trying to develop a product, right, when you start building, that's when you're going to find a lot of the problems. Obviously we've done our due diligence to do calculations and whatnot and do research, but there were some aspects that we couldn't really test with calculations. And that's when we found a lot of our issues, such as Adrian, when you mentioned before about manufacturing and whatnot. So those were the main cons for waterfall. But one of the pros I would say is we definitely were on track for a lot of our gates. We've done all the research and whatnot and everything according to according to schedule. And if we were to do anything differently, I'd obviously suggest that we were to do agile, just because we would do testing a lot more earlier and we'd be able to fix a lot of these problems earlier in the project, whereas later in the project, we'd have less time and less resources to actually make a feasible product.
Or for example, recognizing that risk of failure in testing earlier and do prototype-based testing back in phase BC type of thing. Yeah. Thanks, Gordon. Okay, same question to Team K. So how did the project management process run for you, and where were some of your challenges and successes?
So when we started off with the schedule and the Gantt chart at the very beginning of the semester, we thought we had a pretty good grasp of how things would flow just based off of our research of how complex things would be and how much resources we would need to allocate. But unfortunately, as we started like developing in January, we realized soon that some of the tasks which we thought would take a certain like duration of time, we definitely had to try to pivot simply because a lot of the like tasks required a lot more knowledge than we currently had, or there was just a lack of documentation. So definitely if we were to do an agile approach and just start like development earlier on with our coding, I definitely felt like we would have been able to avoid a lot of the issues which we were facing in February and the month of January.
Yeah, so recognizing that the size of the scope that you were trying to take on and the work that was actually needed, it was when you actually hit that phase that you realized it was a lot more than you'd perhaps anticipated.
Yeah, exactly.
Yeah, okay, thanks, Brandon. So for team F, what was your biggest project management realization over the year?
So the biggest something that we realized is that we didn't account for like how long the testing phase was actually, and we also didn't really take into account like the difficulties in getting like the facilities to conduct our tests. Like for example, like one of our difficulties was like I think like the winter lasted a bit longer than we anticipated. So one time like when we went to test, like the outside like the pond outside of Lassonde, like the pond was still frozen, so that was not doable. So we had to like push our testing of the buoy back like a couple of weeks when the ice started melting. And then yeah, so I think something we could have improved on was to include more slack in our testing for the future. And that and usually like like you never know, like like your design might not go the way you plan it to be. So I think that's one thing I think we did I think that we did do pretty well, because we did have like many like backups or like backup scenarios that we accounted for, so that way we could pivot in the case of any like failures or things not going our way. And yeah,
so having some of those contingencies gave you options when things hit, but in some cases having a few more of those contingency backup solutions could have been helpful. Thanks Jan. On to team M.
Okay, so this was our first time going through a waterfall-based project, and to be honest, none of us really knew what it was. As we went through it, we realized that waterfall is a much more structured approach, and everything has to be done in steps. And this was a big problem for us because all of us had the ROV basically designed in our head, what we would do, every motor in place, what boards would be used, but we never broke it down in steps, which meant that we would not have a backup plan for failures. And dividing the gates was a very big problem because we did not have any simulation work, again, because we already had the original as-built in mind. This made designing a lot harder, and having an as-built that would fit our design was also harder because, again, as we went through the waterfall-based project, we realized that things don't go accordingly, right? And the testing phase, as other teams reflected, was a very big portion of the project that we pushed back to a much later date, which should not have been done. We feel like we could have done this in early February, maybe, if we did the other gates properly. So yeah, but on the pro side, waterfall is very structured, and at the end of the day, everything is well timed. So if we followed along the guidelines and we were able to finish in time, basically. Yeah.
So going in with a predefined solution actually created some challenges because you were trying to fit your design to your predefined solution.
Exactly, yeah.
Rather than actually let the design process identify problems and things like that. Yeah.
Exactly.
Yeah, thanks, Shahul. Team AC, how did the project management process work for you as a group?
So it actually worked for us pretty well because we did the research phase very well, and even our design phase, we took a long time to come to our final design, but it was very well done because in the end, everything, we kind of got lucky and we didn't have to change much to our design, make many changes. And yeah, so that worked. But then the testing phase definitely needed more time because especially the integration part of it, because we tested our different components separately and everything worked. But then when we were integrating and like putting them together, we came across so many errors and issues. So yeah, we definitely needed more time for that.
Yeah, it's interesting. Integration is one of those things that is often, oh, well, if it works separately, it'll easily just go together. And that's often the place where you get bitten in the process. So yeah, great. Thanks for that, Genji. Great reflection. Team N, what was your reflection on the project management process?
I think from like a grand scheme of things, we pretty much followed the waterfall project pretty well. But something that came as issue for us is at the beginning, when we're kind of laying out like what needs to be done, it was really hard to figure out everything that needed to be done. So there's obviously things that are missing, and there's like no way we can think of it until the thing actually happens. So like, we kind of did consider it, like, yeah, like this, there's going to be things that we're not going to think of. So we obviously have these for times, right? But there's obviously so many like others uncontrollable like variables that come into our project, which pretty much delayed, just progressively delayed our each step of the waterfall project. And in the end, I think pretty much what everyone's been saying throughout this panel is like testing was basically a lot shorter than we wanted it to be. And like we got a working prototype, which was good, but like I feel like if we had more testing time, we would have actually made the prototype a lot better.
Yeah. And going in, you don't know what you don't know, and you can only have so much slack in there to account for that. So yeah,
exactly.
Yeah, thanks, Justin.
Yep.
Okay, so what I'd like to pivot to next is unintended consequences of your design. So you've gone in to this project trying to create something that could have a positive impact on the environment or society. What could the potential remaining risks of your project be? What could go wrong with it that could cause an unintended negative consequence, if you were to reflect on it? Or how do you think you've tackled that question within your project design? So if I could start this one with team F.
Yeah, so some of the unintended consequences that we can think of, one being sending like false data. If there's any sort of like malfunction with any of our components and it starts uploading data that's not accurate, that could be catastrophic for search and rescue missions, right? If they're relying on this data to be able to find people who are lost at sea, or then having that false data would lead them to the wrong spot and ultimately completely negate our design. And then the other sort of unintended consequence, lots of these other buoy companies that we researched, they use disposable parachutes to slow the fall as they drop it out of a plane. And so when that parachute detaches, it just floats about in the ocean. And I don't even think most of these companies use biodegradable parachutes or anything like that. So, it just adds to that problem that another group is even solving, right? Adding that component of, polluting the ocean. And so our design actually was able to solve that by using an innovative solution by slowing the fall using idle propellers. And so that was sort of something that we actually thought of ahead of time, an unintended consequence that we'd have thought of that we solved in the process.
Right, thanks, Josiah. Great examples. So thanks for that. Team G, what are the potential unintended consequences of your design, or how did you try to address some in the design?
Hi, Professor Franz. How's it going?
Yeah, very well. Hi, Tristan.
Good, thank you. So our main consideration when it came to our implementation in the water is, especially when it comes to harming ecosystems and whatnot, is our interaction with the actual wildlife. So our main consideration, especially with our design being very heavily mechanical focused, is with those moving parts, are they going to harm any surrounding wildlife or anything that would interact with it in any way? And that also includes with the handling of the actual device from operators themselves. And so what we did is that we actually tried to figure some sort of design considerations that would protect the wildlife from any rotating mechanisms, i.e. like the rotating drum or any of the motors and whatnot. And in terms of our final as-built design, we kind of closed it off as well as we could. We actually had our framework involving the PVC pipes and whatnot actually kind of aimed to barrier off a lot of the rotating mechanisms and whatnot, so as to still allow it to skim as much oil as possible, but so that, say, if a small fish or whatnot would actually interact with the drum, it wouldn't cause any harm in the operation.
Great, another great example. Thanks, Tristan.
Thank you.
What would the unintended consequences potentially be of your design, or how did you account for those? We've already talked about failure cases, but what about unintended other consequences? Who'd like to take that up for Team K? Maybe I can come to...
I can speak to that. Yeah, so because it is fundamentally a tool that you can use, that the end user can deploy for whatever they want, a real danger is that you could use this greenhouse to grow something that is potentially unsuitable for the climate. And so instead of minimizing inputs, you're actually overworking the system and actually using far too much energy for what it's for. It's not necessarily a drawback to the system, but any tool can be misused in these particular ways.
Yeah, so you could be enabling people to be less energy conscious by encouraging growing plants easily in an environment that requires a lot of energy to do so well. You growing things in a more appropriate environment. Yeah, that's a great example. Thanks, Sasha. Team M.
Yeah, so we had originally come up with some unintended consequences like way back in the earlier gates that we wanted to address later on in the project. So one of the big ones was, like how I said before, since we are in the ocean and the whole point is to, remediate the ocean for ocean life, it was important not to damage ocean life at the same time. So we have exposed propellers on the outside of our design, and they're pretty fast and powerful. So if certain small animals would go in there, they would be damaged or killed. Originally, we had a design which would have like this kind of cage around each of the propellers that would minimize any animals going in. However, during the actual building, we never actually got to that part, even though we had originally designed it. But if we had more time, we could have implemented that to at least save them from that part. Another thing we also had was some of the materials we were using. We wanted to make sure they were also environmentally friendly, since that was our whole point. We mentioned earlier that the batteries we had originally decided to use were supposed to be more environmentally friendly than the ones we ended up actually using, but that was more because of the power issue that we had for supplying all 5 propellers. One of the things we did end up getting pretty environmentally friendly was the actual material used to build the frame, which was the PVC pipes. We found out those were pretty recyclable, and so building this on a large scale, that's a material you can use to build this if you want to build like a lot more of our product.
Thanks for that, Atif. Good examples. Team N.
Yeah, just to quickly cover, most of what's already been talked about directly applies to our group as well. Just one thing, since we were creating an ROV to eliminate garbage in the water, in creating that ROV, eventually it's going to run out of its use case and will become garbage at the end of the day too. We didn't necessarily have a disposal plan, but that is an unintended consequence. In completing this project, we are inevitably creating more garbage as well.
Yeah, so thinking about the full life cycle upfront and thinking about how to source materials that could more easily be returned or reused at the end could be an interesting future reflection. Yeah, great. Thanks, Jane. And Team AC.
Hello?
Yep.
Yeah, for us, it's mostly speculation for the consequences, because we are just assuming, and our design is mostly taking care of the consequences, but we are like thinking that maybe the consumer will use a lot more plastic bags, and that may release some toxic fumes, unintended toxic fumes than intended. The other thing is like the consumer may improperly use it. Like he may not follow the guideline of which plastic bags to insert in, and that may just rule the whole recyclability. And I think like overall, we basically limited every consequence, and these are the only ones which come to mind to me right now.
Yeah, so people thinking, oh, I can now use plastic bags as much as I want because I'll be able to squash them down and that's okay. And people putting maybe inappropriate things in there and either creating hazardous fumes or other issues from improper use of the system. Yeah.
Yeah, exactly.
Good examples. Thanks, Sahid. Okay. On that note, I think we are at the end of panel 5. So if we could bring up the poll for panel 5, that would be great. And I just want to take the opportunity again to thank all our panelists in panel 5, Team AC, Wall-E 2, which I thought was very appropriate, the household appliance for plastic recycling, Team F, the buoy to address search and rescue needs, Team G, the skimmer team looking at skimming off offshore oil from ocean surfaces, Team K, looking at the greenhouse climate controller, Team M, the first of our 2 ROV teams, and Team N, our second ROV team. So thank you for that. If you are in panel 6, if you could raise your hands and we will get you promoted to panelists as quickly as possible. And huge thanks again to panel. So as we get panel 6 promoted, don't forget to raise your hand if you're in our final panel of the day, panel 6. We will now close our panel 5 poll. And at this point, we will roll the reel for panel 6.
Transport Canada requires an industrial shredder that is capable of shredding clothing, flotation equipment, hard hats, leather boots, and safety glasses. Some requirements that Transport Canada requested were simply out of scope of what could be achieved with the limited time, budget, and team. Our team decided to design and build a mini version of what Transport Canada requested, with slight modifications to the requirements so that they were attainable. Through an iterative design process which included thorough calculations, simulations, and CAD models, we were able to define important parameters within our system, such as materials and dimensions. This process served as a blueprint to bring our design to life. Through rigorous machine shop work, the shredder is not just a design on paper or a computer simulation, but is getting ready to shred away at our requirements. Stay tuned for the finished product.
Across Canada, rovers compete against each other in the Canadian International Rover Challenge, where an assigned task such as land speculation is carried out by the rover. In efforts to study the foreign world around us and the potential habitability of human life, and eventually set to explore beyond where no human can reach. Introducing our project. We are a group of 3 mechanical, 1 space, and 1 electrical engineers. Together, we are Team T, the explorers, and we are designing the soil sample collector. We've created a modular design, starting with the soil drilling module, capable of penetrating the ground. The soil transfer module that carries the sample from the drill to the next device, which is the soil storage module rotating for each of the 9 removable storage units. We welcome you to our capstone journey.
Do you ever think about going to space? We are Team U. We're a group of cross-disciplinary engineering students that came together to build a robotic wrist for the York University Robotics Society. The wrist we designed and built will be used on their Mars rover. The rover will participate in competitions against other universities to complete various missions mimicking those in space exploration. Some missions include equipment servicing and extreme object retrieval and delivery. Our wrist uses 2 motors and a differential gear mechanism to rotate the end effector in pitch and roll directions. Our wrist allows for continuous rotation of the end effector, which permits the use of screwdrivers. Our wrist is also capable of position control and live footage, so that a remote operator can see the end effector and make precise movements to retrieve important items. Overall, our robotic wrist will help facilitate the completion of the missions.
Mankind has always been intrigued with the idea of going to space, which is being fulfilled by the likes of NASA rover missions. However,
hey man, just get to the point.
All right. This is where the CRC competition comes into play. The goal of the competition is to design a robotic rover that can complete various tasks in rough environments. The goal of RoboStone is to design a robotic wrist for the York University Robotics Society. This wrist will be the link between the arm and the gripper and will give the gripper the capability to pitch and roll, allowing it to manipulate and lift various objects and equipment. Our wrists consist of 2 parallel DC motors, driving belts which drive bevel gears. Depending on whether the motors work in the same or opposite directions, pitch or roll are produced. Stay tuned for the full video. In Zoom Theaters, April 15th.
Thanks for that introduction to panel 6. So we have 4 teams who've worked on the rover components and 1 team who've been focused on an industrial clothing shredder. So my first question for each of you is focused in on the broader uses of the tool or technology that you built. So each of you has built something for a specific defined purpose. In the case of the shredder, per a contractual description. In the case of the soil samplers and the robotic wrists for that York University Robotics Society competition rover. But where do you see the broader application of the technology that you designed for Capstone? And if I could start with Team H on this one.
So our shredder can be used for like many purposes. Instead of just being used at Transport Canada, it can be used for any purpose that can involve shredding materials to like a smaller size. Any place that requires any sort of recycling prep can be used. Matter of fact, like after we were done our project, we had a few people inquiring if they could actually take our shredder off our hands because we actually had no use for it anymore. So yeah.
Wonderful. So you've already been approached about possible local uses for your shredding equipment. Great.
Yeah.
Thanks, Ismail. Team S, thinking about the soil sampler.
Yeah. So our team, we started making just a soil sampler that collects 9 samples of soil, but we realized that this thing can do a lot more. It can collect any sort of particulate matter, and it's fully automated at the same time. So one thing we came up with was to potentially attach this to a, for example, in an agricultural sense, we could attach it to a tractor in the farm that would automatically sample soils or collect samples of soils in a large large acreage of land at different parts, and it could be remotely automatically done. And then we could analyze the soil to make sure that everything is evenly and properly being taken care of. So that was one case we came up with, but this actually, it can be taken with any sort of particulate matter, including like even in the case of food industry, like flour. So yeah, so that's what our use case is, an automated particulate collector.
Yeah, great. That's a great reframing of this project in a much broader sense. Thanks for that, Scott. Team T.
So while our project was initially intended for collecting soil samples in outer space, we found that we can still use it for agricultural processes. So instead of going clockwise for collecting the soil, we can go counterclockwise, and we can actually use it to plant different types of seeds or agricultural deposits that need to be made. And it doesn't necessarily need to be limited to scoping in space. We can also use it within Earth for areas that may be restricted for humans, that may be considered radioactive or just difficult to access. So we found we can use it for other stuff as well.
Yeah, and thinking about that, reversing it as a drill rather than a collector is useful reflection as well. So yeah, thanks for that, Matt. Team U.
I can answer that question. So since our capstone project is on robotic wrist, there's a bunch of applications in medical. There's surgical bots. There's also prosthetics that require wrist movement. So these are some applications. There's also use case in assembly lines as well in the factory, where there's a lot of automations being done. So a lot of these wrist mechanisms can be a basis to develop more complex mechanisms and enhance our automation there.
Yeah, thanks for that, Donghyun. And finally, Team V.
Yeah, so our design is pretty simple. It has like 2 gears and then a main gear that's being driven. We were given constraints such as like the 1 kilogram mass constraint and the dimensions, but this can be expanded if you include, for example, automation in factories. We got these huge robots moving cars, but because this design is much compact, it can be projected into those designs and say, for example, reduce the size and weight when needed.
Yep, so thinking about scaling and sizing of those larger robotic arms. Yeah, great, thanks. So that's a great question to then flow into. For all of your projects, materials choice has been a key consideration. And so thinking about both the application that you're designing for and some of these add-on applications that you can imagine, what issues would you say you have with your current materials choice, and what choices would you make differently in terms of the materials that you've used or would use for your solution? And I'll start that one back with Team V.
That's a great question. It's some of the things that we struggled with, especially with something that's 1 kilogram, but can lift 8 kilograms. So that the weight ratio is really not that fair. The main issue that we've had was basically 3D printing issues, where you got extrusion problems, you got material problems. If you choose one roll, you got to stick with it because the material properties is not the same. We tried experimenting with nylon carbon fiber. That didn't go so well. The carbon fiber kind of extruded on itself. So you have this blob of carbon fiber. So definitely this could be, some parts could be machined. Like for example, this part could be machined. The gears could be machined, but there's laser sintering machines that could be used to manufacture or produce the smaller gears.
Okay, great, thanks. Great answer, Kasha. Team U.
So I guess this is relevant to a lot of the groups. Just because of our short time span, we had to iterate through many designs that we don't really know. We don't have a previous expertise in robotic design. So a lot of our material basis is on 3D prints. And what comes with it is just the mechanical strength properties, because we don't know what exactly would work in the dimensioning. So although we know that steel gears on a lot of our gearbox applications are more, they're stronger and they're more durable would likely last and wouldn't require replacement. It was a little difficult to use that because we don't have an idea and we need to quickly iterate through. And with the state of COVID-19, it was a little difficult there was a lot of lead time in procuring parts. So I guess what was prevalent in our design was that a lot of the gears would constantly shear, and this was all within our. We did it knowingly, but this was to really get to learn that what design worked, and it was sort of necessary. But yeah, steel gear would definitely be a really good replacement for our material choice. Yeah, we know that that's a drawback with our design.
Yeah, and prototyping with plastic 3D materials is a great way of checking your design and then making those other choices later on. Metal 3D printers are going to be more prevalent in future, but we're not quite there yet. Although soon Lassonde will have one, but it probably won't be readily available for Capstone quite yet. So maybe in a few years' time. Yeah. Right. Team T.
I think material choices were mainly considered in the prototyping stage because our initial design included most of our components to be 3D printed. However, we soon realized that we have a lot of constraints with 3D printing as material properties. The other problem we ran into was time, cost, and sizing constraint because lots of the large components cannot be 3D printed successfully. So we had to pivot and choose more standard components. We ended up going with aluminum extrusions because aluminum is readily recyclable, so it would reduce the environmental impact. And most of the connectors are 3D printed. Because our main application is for space exploration, we thought that using 3D printer as much as possible is desirable since most of the spacecraft should have it. So they can maintain the part, replace the broken or worn out parts. And that was our main consideration.
Yeah, so that's a great point that, thinking about the remanufacturability in situ, actually having the 3D printed parts is an interesting concept so that you can show how you could repair the components in situ. Yeah, thanks for that, Kia. Team S.
Yeah, thank you, Professor. So we've already obviously developed a pretty big discussion about 3D printed parts. Our design is no different. However, within our initial design, we still considered using metal parts for a lot of our key components, load-bearing components. For example, our auger is made out of metal. Our rack is made out of metal. So we already have that going for us. But so that's sufficient for the competition. But like you said, looking forward for agricultural purposes, you're obviously going to be outside. You're going to be rain, weather, any kind of you need to have some kind of protection from that. And that's where your other metal cast aluminum parts come in for these non-load bearing components.
Yeah, so you'd already done judicious selection for the purposes of the competition. Exactly. And you know where you would make those edits for different applications at the end of the day. Yeah, great. Great, thanks, Purushan. And finally, for the shredder, Team H, what were your main material choice issues or concerns?
So for our project, we didn't really have any constraints like the other teams in terms of weight or dimensions or anything like that. So originally through calculations, we wanted to use some aluminum alloy for all components for the shredder, but our biggest constraint was the budget. So due to that limiting factor, we decided to go with steel. So all our components were made out of steel, which increased the weight and whatnot, but it was still a good choice because it helped to maintain the rigidity of our system.
Yeah. Thanks, Ismail. So for the next section, I'd like to talk about the project aspect of your the project management aspects of your projects. So as we've talked about in previous panels, you've obviously gone on this project journey. You've all been working under waterfall design. How did that work for you as teams, thinking about the nature of the products you were making? In what way did a waterfall project process work successfully or not so for each of you? And if I could start with Team T on this one.
Yeah, I can take that as well. So waterfall is quite suitable for mechanical project because it has all the steps required to design a reliable system. The main thing we struggled with was our time management, since waterfall only allows for certain flexibility in a scheduling. If one stage is fallen behind, it would essentially push back every component of your remaining task. So that's what happened with us. Since our manufacturing part in the prototyping stage was uh, took longer than we anticipated, it pushed back testing and system integration, and that's where we fell short at the end. So if I were to take something out of project management, I would say that we should leave more time for iterations and allow for like fallbacks and stuff like that.
Yeah, so ensuring you have sufficient margins on each of your
Yeah.
earlier on. Yeah, okay, thanks for that.
Especially integration part, I say.
Yeah, integration is the thing that kills a lot of teams for sure. Yeah. Team S.
Yes, thank you again. So waterfall, it tended to be very document heavy, and it relied on having really strong documents in the beginning, from which the project blossoms. However, we found out later on within the project that some of these documents that we created weren't the best, and so we kind of missed a lot of integration work. However, we did come back at the end, and we're like, you know what, all hands on deck, and we really were able to bring it back. So, but that was definitely an issue that we had with the waterfall approach.
Yeah, so a new respect for the value of those documents earlier on.
Right.
Getting them solids that you have the right information for the build. Yeah, great. Thanks, Karushan. Team U.
Yep, I can answer that. So the main challenge of the waterfall is that there's a little bit of rigidity in the structure. So there's a tendency that you're stuck with certain ideas. But we sort of needed that order of things to get the robotic wrist build going. And to really counteract that rigidity, we started our prototype phase early. So our first prototype was fabricated in November. So that gave us a lot of opportunity to keep iterating through design. And design is an iterative process. So there was a lot of learning we took away. There were some calculations that we didn't do correctly. There were some material fabrications we had to do it redesign, and some mechanisms that did not work we have to fix. So a lot of these enabled us to do it still within the waterfall. So at the end of the day, it worked out. The structures did help us to lay out the order of things, doing the calculations, preliminary design, and then going forward step by step. But at the same time, doing multiple iterations within that one large stage, so that we get as much of an input as possible, and really just not be afraid to go back and fix things.
Yeah. So recognizing that, even within the waterfall structure, there's absolutely a place for early prototyping, for risk reduction and things like that, and making use of that iterative space as an important piece of a good waterfall structure. Yeah, thanks for that, Tom. Then we'll go to Team H.
Sorry, could you repeat the question again?
Yeah, absolutely. No worries, Ismail. So in terms of the project management process, how did it work for you? Where were the challenges with it? Where did it seem to sort of really help you, if at all?
So we found the waterfall aspect very beneficial to our project because of the steps that we needed in order to reach our goal. One issue that we found was maybe we didn't follow it as closely as like it was laid out, kind of pushing back the dates of when we should complete things, or kind of going over certain steps and not following them as closely as possible, which kind of hindered our timeline in which we could complete our project. So I guess if an issue we had was not following as closely as we should have.
Yeah, so maybe again, a slight newfound respect for some of that gated process to really ensure that you're going through the gate in a way that ensures that you're ready for the next phase of activity potentially.
Exactly, yeah.
Yeah, okay, great. Thanks, Ismail. And finally, Team V on this one.
Yeah, so I think we'd want to reiterate what Team S said in terms of waterfall being very documentation heavy. And so we noticed that a lot of our time was spent working on the documentation and making sure we had written up everything that we needed. And so we struggled a lot to find time and just manage our time appropriately. Having enough time for testing and prototyping was our biggest issue. We got to the end of the testing phase and we found that we needed more time to go back and make alterations to continue working and meet some of our requirements that we weren't able to meet right away. And so things like that, I think management scheduling was one of our biggest troubles.
Yeah, so thinking about sort of scoping so that you left yourself the slack for things and getting a better sense of the duration of different phases and things like that. Yeah, great. Thanks, Team V. So 4 of the teams here have been focused in on pieces of a rover project. So for you 4, I've got one question. I'll ask H a different question, but for the 4 of you, how would you want your work to be taken up by the rover team now moving forward? So what's the hope for the project legacy at this point as you move forward within the York University rover team? And if I could go to Team S first on this one.
Yeah, so we actually, so we talked to the rover team and we are going to work with them over the summer as well to finish our and make sure our module is attached to the rover and is tested on top of the rover. And we think that our design concept is is perfectly functional. And even if the parts are completely changed out, the concept, the operation concept itself can be carried forward and made better by adding additional sensors to calculate the exact depth, for example, or see exactly how much weight is being lifted up. But yeah, I think our operation concept is can be carried forward several years because it's tried and tested essentially.
Yeah. So you got some ideas around additional sensors to monitor some additional things, and you've got a plan for the integration. Yeah. Okay. Thanks, Bart. Team T, what are your thoughts around the legacy of what you've created?
Okay, so I guess this is a problem by having 2 teams working on the exact same thing. So our answer is going to be very similar. We are also talked to the rover team about future opportunities of working together, and we also suggested them, since we know they are doing they were doing a redesign on the rover because they were facing some problems and they were changing it. We told them if the dimensions don't match or if any of the component is better on the other team, you can as well take parts of the concept of the drilling side or the transformation or the storage and use it separately to include it in the design. Because as we know, one design usually is not the best at everything. So I think a combination of, we would be 11 brains is always better than combination of just 1 group or 5 brain. So yeah, that was what we talked about with the stakeholders, which is our rover team.
Yeah, and it's similar in a way to the Spencer group that we had earlier on today, where we had 4 groups working on a very similar set of components. And as you say, finding the optimal mix and match, and maybe carrying a couple of the concepts forward into even a competition to see which work best in a competition environment could be an interesting solution as well. So thanks for that, Pedro. Team U.
Yep, I can answer this. What we would like to see them go forward, the YURS go forward with our design is first, they can procure steel parts for the low bearing components. That's the first thing they should do. Since they already have the dimensions from our project documents, they can go through that. Another thing is the rover is to do challenges regardless of any weather conditions. So it's going to be rain. So we need them to build a water resistant housing so that the electrical components are protected, as well as we currently built the software electrical communication system in serial. That needs to be converted to their Canvas system, which is how they're controlling their rover. So that's another area that they should be working on. And we really would like to extend them to help and guide them through if they have any questions regarding our documentation. so that they are able to reach the full range of strength testing required for a rover challenge.
Yeah, that's a very clear list of steps that would be needed, including that training step, which is important, and the outreach that really helps the handoff be successful. So thanks for that, Team U. Thanks for that, Donghyun. And finally, Team V on out of this group, and then we'll come back to H in a second.
So we mentioned in a previous point that the report was well documented. We went through the many stages of testing just to make sure that we're on the right page with the Robotics Society. And we've had continuous contact ever since, the preliminary stages to the final stages to say, well, for example, you got motor 1, motor 2. Well, they may not be strong to lift 8 kilograms, but it's still a working functional prototype. So we made recommendations for the motors. We made recommendations for the belts. And those are the main components that we feel that needs to be addressing. We haven't had issues with the housing or the waterproofing, because the design was very simple, is that you built a box, you extruded or cut out some components, and then that housing fits all the electronics, and you can just put a lid on it and cover it. So taking this forward, we made it very simple to be integrated with the arm, so they can take this model, inspect the individual components like the motors and belts, and they can upgrade them. And that's how I feel it should be taken from, going forward.
In particular, as you mentioned, that belt issue that you flagged earlier on as well. So yeah, thanks, Team V. So for Team H, you mentioned at the beginning that you've had some interest in, what to do with your hardware now that you've created it. But what would you want that legacy or handoff potentially to look like? Have you got thoughts as to what might happen to the actual hardware, or what you would like to happen with the design?
For me personally, I would like to see the design kind of evolve. So like some things that we weren't able to do was like add like a way for the material to go into the shredder like by itself. So adding like a conveyor belt or whatever at the top and at the bottom. Also having something to analyze like the speed at which it's like rotating at that current time of its operation. So kind of seeing the system itself evolve would be something that I would want to see it moving forward.
Yeah, so thinking more of the end-to-end system solution and thinking about some of that safety monitoring and things like that. So
exactly.
It would be a great suggestion for a future capstone team to maybe think about integrating it into a more complete solution. So thanks for that, Ismail. So I now want to move on to your individual capstone journeys. So what were some of the biggest surprises for each of you individually? And I don't need multiple answers per team, but maybe somebody in the team who wants to speak up. What's the thing that you are going to take away from capstone individually that you weren't expecting to maybe at the start of this journey? And I will start with Team S on this one.
So I think the biggest surprise for us, sorry about that.
Yep, no worries.
So I think the biggest surprise from us from the project management side was how difficult it really is to run a 7-person project. Even though we had a lot of help with it, we really struggled managing so many people. From the technical side, the wiring kind of really threw us off. Putting together the actual end product, it took a lot of effort. Thankfully, though, we did have a lot of relevant expertise, and even ex-members from the rover team helped us, so we're okay.
Thanks, Bruce. Anybody else from Team S want to jump in, or?
Yeah, I can mention something. So one thing I realized is from the start, I thought like I have a good like technical expertise, so I tried to just lead over the design and give like directions to move in to the mechanical members of my team. But later on in the project, I realized that because I have the actual experience, I should have lead design from the start and done the design myself from the start, essentially, instead of trying to offload the work and work on project management. So yeah, I think like if you have the technical experience, just work on technical directly. That was one thing I learned from capstone experience. Yeah.
Yeah, and it's always that wearing multiple hats. Which one do you prioritize? And,
exactly. Yeah.
Thanks for that, Spot. Team T.
So for us, the biggest surprise was how soon we all synced up together as a team, because I remember like our first meeting was during the pandemic, and we decided to go to a Starbucks and have a in-person meeting to develop that personal connection. And from going forward, it helped us develop a good team dynamic. We were comfortable with each other. We shared our concern, personal issues, and support each other. That made us catch up with a lot of work when one team member was down or not available for whatever reason. Also, as I told earlier, that 3D printing all the components were challenging. The another surprise was how you 3D print, like the orientation of 3D printing affects the mechanical properties drastically. So if because layers are very easy to separate, so your part will fail easily, and that force us to go back to board and redesign some components to be printed in a better way to be more stronger and reliable. So that was the biggest challenges, surprises, and we learned good stuff from it.
Great, thanks for that. Anybody else on Team T want to jump in on that question?
I just can add something more personal. As you know, Franz, because you were the professor, for second year space engineering student before didn't have an ENG course, and we had our specific ENG that we wouldn't really tackle a project like they do nowadays. So there's no big project that everyone has to do. And I really didn't have an experience with working in a project that may take an entire year, such a big scale. So I was kind of scared starting because I wasn't sure how I can add to these people who have a lot more experience than me, especially the mechanical people. But they were very welcoming. They helped me, they made me grow, and I really appreciate that.
Right, thanks for that, Pedro. Okay, Team U, same question.
So the biggest surprise for the project management side was that in the beginning, we thought it was such a trivial thing. So we didn't even include it in the work breakdown structure. We thought it could just be, melted into the mechanical work or software work. It's just basic, just do things in order and to keep track of things. It wasn't like that. We quickly realized that a lot of our stuff wasn't being as organized as we thought. So we even took the effort to include project management into the work breakdown structure midway through. We realized that there was a lot of cross-disciplinary talk that was required. We couldn't just finish the mechanical part and assume, hey, electrical can just pick it up from here. We had to always keep them in the loop. They had to always keep us in the loop. And there was a lot of those cross-disciplinary talks that was required. And of course, another struggle related to that is a lot of struggles meeting on time because we have different schedules.
Yeah.
And that was a lot of surprises in the project management side. How important it is to coordinate everything and how much of a headache it is to actually get this one going. Yeah.
Yeah, so definite appreciation for the project management role now.
Yeah.
Great, thanks for that, Donghyun. Anybody else from Team U want to jump in on that one?
I'll jump in real quick. When I first read the course description, I was expecting more of like a mini design project. And so, you have a task, you kind of complete your role, everyone puts it together, and then you have a product. And it was not like that at all. I wasn't really expecting much project management. And then I realized that like most of this course is heavy duty project management, organization, time management, stuff like that. So that kind of surprised me, but it ended up working out. So
yeah, this was your project to run and own and everything. Yeah. Great, great reflection, Agostino. Thanks for that. Okay, Team V.
So I think let's just kind of recap on what everyone said. Project management is it's a very important thing. What surprised us at the start is how easy it is to transition from not knowing what we're doing to knowing what we're doing. And I'd like to give a big shout out to the project management side of our team, Manaf and Hassan. They kind of they allowed us to do things and hit the ground running. So we knew when the deadlines were, we know what to submit, when to submit. We'd stay till like 9 p.m. doing our parts. And with the project management, we're able to kind of spread our wings. So those that were more on the technical side of things, they would, would capitalize on their skills to build this wrist. It was never easy. You can't say, oh, I'm going to put one motor, two motor. There's a lot of iterations and a lot of testing. And, that testing phase was easy to implement because we had a very good project management. We're able to take things, put them on, a Google document or something, put some dates, those need to be completed by then. And then we'd have some sort of a checklist, and we're here now. It's working, it's functional. And that's probably what surprised me the most is the transition.
Yeah, great. And I think we've got lots of really good quotes for next year for flagging to teams that project management component. So thank you for that. And I believe we didn't go to Team H. I think we started with Team S. So Team H.
So one of the biggest surprises we had was having one of the members kind of drop the course mid-semester. So kind of left our team with only 3 people to complete our capstone project. So in that case, we just all had to step up and kind of increase our workload to kind of get things done. So I guess we're proud that we were able to do that. Another thing that we were surprised about was like the accuracy that we needed for our CAD model. So in our case, we were kind of constrained on budget because of our materials. So we only had like one shot at like kind of putting our shredder together. So kind of our CAD model kind of had to be like very accurate. So kind of going through like the numerous design iterations and design reviews with supervisors and whatnot to get our thing ready was a surprise for me.
Yep, fair enough. And anybody else from Team H want to jump in? I'll take that as a no, and I apologize to Team V. I didn't give you more of an opportunity for anybody else to share, but you were all sat in the same room, so I took that as a group input. Thanks. Just to finish with, we're coming to the end of our final panel. I just want to give you each the chance to share anything that you haven't had a chance to talk about so far, and to share a leaving comment for the room. So what would you like the room to take away from your capstone experience, your activity, as we come to the end of panel 6? And we'll run these in order. So over to Team H first. Anything you haven't had a chance to say, or anything that you'd like to leave the room with on your experience?
So I think our capstone experience was amazing. Like we got to learn a lot, not just in terms of like technical stuff, but in terms of communicating, team management, interpersonal skills, kind of stepping out of your comfort zone. So a lot of things like helped us to grow as individuals and as engineers. So it was a great experience.
Wonderful. Thanks, Ismail. Great thing to finish on. Team S.
Right. So from us, it's probably communication, collaboration, and gratitude. We definitely would not be here without the help of our supervisors, without the help of yourself, Professor Franz, and just the York University Rover team as well for being fantastic customers for the purpose of this project. Yeah, communication, collaboration, work together with everyone, really talk to everybody in your group and be grateful.
Wonderful. Thanks, Purushan. Great sentiment to finish on as well. Team T.
So basically, when we started this course, we treated it as like a course, like just another thing that we would have to do. But slowly, we sort of realized, and we treated it more like an experience. And not to sound too philosophical, but it really did open our eyes to how to work with interdisciplinary fields. And more than that, just the friendships that we gained in this whole project is once in a lifetime experience. It was really something that I definitely wasn't expecting to get, but it was probably the best outcome of this project.
Huge. And again, a lovely sentiment to finish on. So thanks for that, Numan. And Team U.
I guess what I can share, with my team as well, is that learning the importance of being spontaneous, doing things on your own, and really taking ownership carries really far. And just being on a common ground, agreeing on accomplishing something awesome together, because we have spent 4 years learning different disciplines, and this is a really great opportunity to put that to test. And taking ownership and just making sure that we're all accomplished something together was a really enlightening experience. And on top of that, doing this all within a stressful circumstances, because we were all through a heavy course load. That was definitely a rewarding experience, I'd say. Yeah.
Never mind in a pandemic as well. So
yeah.
Yeah, thanks, Duncan. Great sentiment as well. And last but by no means least, Team V.
Yeah, so I guess one thing like takeaway is the amount that you have to learn, the work you do to learn on your own, just like things that you're using basics of things you've learned in school, but then the extra steps you need to do to learn various components of the project, and then also learning certain parts from each different discipline, and you understand how it all fits together, and all of that really you get an idea of a whole project as a whole and how various things come together to finalize it in the end.
Yeah, great sentiment. And this is the end, not just of this year-long capstone, but for many of you, the end of your undergraduate learning journeys. So big chance to reflect, but some great replies there. Huge thanks again. At this point, we'll open the poll for panel 6. And when that is open, I will take the opportunity to thank once more our panel 6. So we had Team H, the shredder, the industrial clothing shredder team, Team S, the first of our 2 rover soil sampler teams, Team T, the explorers, our second soil sampler team, Team U, the first of the 2 robotic wrists, and Team V, Robostone, the second of the robotic wrists. So thank you again. Panel 6, huge thanks for your participation. Huge thanks to everybody who's been a panelist or an attendee so far. We are shortly going to move into the judges doing their deliberation, and we will have our trivia activity happening in this Zoom room. The goal of that will be a bit of light relief for 45 minutes whilst the judges go off and make their final decision. The course directors are not judges for this. We have our esteemed panel of expert judges from outside who will be making their final decision on the awards. And then we will all meet back again at 3:45 to announce the Lassonde Awards. So we've got those things to come up. We'll give it another minute or so on the panel 6 voting, so make sure you vote for your favorite panel 6 team. And we will be making sure that the judges know where to go for their judging room. If any judge doesn't know where to go, one of the team members can point you to the right Zoom room for judging. And I will be handing over shortly to, let me check.
It'll be me for this moment. I'm the in-between. So.
Okay. To Claudia, huge thanks to Claudia for the judging. What we'll do at this point is we will close the panel. The poll, rather, the final poll is now closed. And Claudia has posted in the hosts and panelists link the Zoom link for the judges to go to, and that will be by invitation only. So we will get the judges moved over there very shortly. You can move there right now if you're ready. And I will hand over to Claudia. I will be helping out in there, and I'll be back and see you shortly at 3:45 after your trivia.
So thanks again and see you soon.
Hi, everyone. Just give me 1.5 seconds. Okay, so we do actually have one more poll to do. So thank you so much, everybody, for all your votes. We've gotten them throughout the whole thing, but now we have to do a top overall favorite panel. So I'm going to find that top overall, launch that. And so sorry, could everyone? Okay, okay. Very impressive. We're gonna do the top 6, the overall before Sybil arrives. So these are your top teams from each panel, so vote away. Okay, so I'm going to end the poll in another few seconds. So get your votes in, call your friends. Let's see who wins this top award, which is a high five. I'm gonna end it in about 5 seconds, 4 seconds, 3, 2, and 1. Actually, it's so close what I'm seeing happening. I'm gonna give it another couple seconds. And let's see, we have results. It's very close. It looks, is it team J? Okay, actually we have a tie. This is a capstone first. Congratulations to team J and to team Z. You are the crowd favorites. And so sorry, I'm literally actually hearing 2 different Zoom rooms going on in my headphones. So what we're going to do now is put up just, another little bit of an intermission while we wait for the civil webinar to join us. And then we have our lovely host here, Sogand. If you're an N4K, you know her as your TA. She will guide you on this journey of seeing what random things you know and don't know. And it'll be kind of just like the votes where you can just vote, vote your answer that you think is right. And again, this is just kind of really a bit of fun until we get to the actual award ceremony. Again, the prize is bragging rights inside the, Zoom chat or whatever possible class chat you may have. I'm also going to be playing, I think, I saw the first 3 questions, so I kind of have a head start. But so again, I will let you know once we start getting some civil students into the room. For now, I'm just gonna go on a intermission. We can go camera off until then, so everyone can take a bio break or get a drink and come back. All right.
Sounds good.
Okay, we'll begin in about 1.5 minutes. Get your brains ready to think and win this trivia. Alrighty, everyone. So we are going to start our trivia. It is just purely for fun and for your own bragging rights. As soon as we start sharing the screen, that would be great. All right. Well, as you can see, it is your chance to prove how many random facts and sometimes non-random facts that you know. So let's get started. Thank you. Well, the answers are going to be anonymous. This is, again, just for fun. If you're on Zoom, I think we're going to have a quick poll that you can answer after each question. If you're watching on YouTube, hi, please click like and subscribe. I don't know. Just write down in the comment section, I guess. And yeah, so it's going to be a fun time. Just however you can communicate your answers to the void, do it. Question 1. Which country has the most vending machine per capita? A, China, B, Thailand, C, Taiwan, and D, Japan. It would be also a cool question to know which school has the most vending machines per student at their universities. That would be interesting. All right, so the correct answer is Japan. Actually, I'm just reading what you guys can see, but the manufacturers lend vending machines free of charge, and that's why they're so popular in Japan. And anyone can install a vending machine as long as they have permission. So that's pretty good. Next question. Oh, there you go. That's a beautiful Japanese flag. Now, the second question is, what is the name of the biggest technology company in South Korea? A, Samsung, B, LG, C, Yamaha, D, Skyhawk. And I sincerely apologize if I just misread that. I am so sorry. Fun fact, my piano is from Yamaha, and I know they also make like little engines, which, I mean, who knows?
very broad spectrum company right there. Alrighty, so the answer is, we don't really have drum rolls, but the answer is Samsung. They're the biggest South Korean technology company, and they're worth just a little bit lower than my net worth, which is $330 billion. Am I supposed to talk over the music? Can anyone hear me? So, what was the year that the very first model of iPhone was released? 2015, 2016? Oh gosh, sorry, 2005, 2006, 2007, or 2008? This is a close one. I can see what your answers are, and two of the years are very close to each other. Well, as you can see, they're just 1 year after the other one. All right, and the correct answer is, should we give more time, or do you guys think we can go to the correct answer? 2007. And here's a picture of Steve Jobs and the first iPhone, and Apple in the background. All right, so question 4 is, the background song belongs to which TikTok trend? A, hope. What is the background song? Do I have to sing it?
I was listening to the ocean. I saw a face in the sand, but when I picked it up, then it vanished.
Well, this one
I'm
is
surprised
easy.
at how everyone's getting it. This took me so much longer to get. Everyone seems
had
to
a
know
dream
it.
I was 7, climbing my way.
All right, I think we already know the answer to that. I actually had it on my Spotify. So the answer is B, the runaway aurora trend. Yeah, it's very peaceful, very wonderful. You know, you can do ballet, you can dance, and you can play with your dog. You can do everything with this song. Very universal. It's kind of like beige furniture. You can use it with anything. All right, so question 5 is, in this popular 80s song, what was Jenny's phone number? What was Jen? Who is Jenny?
I already know the answer without having to hear the song.
You know, everyone asks what was Jenny's phone number, but no one asks who is Jenny or how is Jenny doing. So A is 777-9311. B is all right, and the correct answer is
8675309.
Claudia, you go ahead.
This is one of my favorite songs. Like, actually, sorry, the chorus is one of my favorite parts. I don't actually know the rest of the song, so.
Go ahead. How do you say this phone number? Because I was going to say 867.
Oh, that's so cute. 8675309.
Okay.
Actually, funny enough, I was trying to read it while I said it, and that threw me off from saying it the right way. So,
yeah. All right, question number 6. Which Survivor song was the theme song for the 1982 movie Rocky III? A, Gonna Fly Now. B, Redemption. C, Eye of the Tiger. And D, The Final Bell. I'm just gonna admit it, I just know one song on this whole list. And I hope it's the correct answer. Yeah, there you go, it is the correct answer. Eye of the Tiger. the song was actually specially written for Rocky 3, a fact that I did not know before this trivia. So I'm learning too. Look at that tiger.
This is Capstone Day. It's great.
Oh, look, they're like little people in his eyes. That's cool. And it was #1 in the USA. So, alrighty, question 7. How long is the longest movie ever made? A, 35 days and 17 hours. B, 121 days and 2 minutes. C, 5 hours. D, 3 days. I don't know if I'm comfortable with like the discrepancy between like 3 days. Why can't it be like 3 the number days? Because the 35 is days. It wasn't spelled out. That's a whole other thing. Now, the question is asking you what was the longest movie ever made. Now, not how long it felt like watching something. Which some lectures.
That's a valid distinction.
Yeah, which some lectures can feel like 121 days and 2 minutes. But they're only 2 minutes. I'm joking. Of course, none of the professors we have on this call. All right, Logistics. It's a Swedish art film and it's 35 days and 17 hours long. The more you know.
I would love to know if anybody has seen this longest film. Although I did learn, my brother actually was aware of this film, that it's basically, this is the exact film that you're watching a cargo ship just come, go wherever it's going. So all the AliExpress items that we order, we're watching them arrive. So that was kind of interesting.
Wow. It's really cool, actually. Okay, question 8. Which Avenger is the only one who could calm the Hulk down? Oh, come on, we already know this. A, Black Widow. B, Rick Jones. C, Thor. D, Iron Man.
Rick Jones, guys, Rick Jones.
Okay, I feel like I'm publicly shaming myself, but who is Rick Jones? The Quiet. Hold on, I'll Google it. Well, it was a Black Widow, and it was established in both Age of Ultron and Thor Ragnarok that Natasha and Hulk had some sort of a friendship / relationship, and she was the only one who could calm him down. Great. So question number 9. Which Infinity Stone was located on Vormir? I think I'm saying it right, but probably not.
I honestly haven't seen it, so I don't know.
I know where it is. I just don't know. Well, obviously, it's
isn't it on the? Okay. Oh my God, I'm gonna embarrass myself. Isn't it on the purple guy's arm? I'm just saying, like, there's a purple guy.
Yeah.
Yes. I agree. It's also Rick. Thank you.
Well, I think Vormir was like a planet, wasn't it? It was like a location. I mean, the space engineering professors can probably chime in here, but the Soul Stone, it was the Soul Stone, yeah. Well, that was when he sacrificed his daughter, right? Thanos sacrificed his daughter to get the Soul Stone. Is that correct? Someone in the captions.
I'm gonna call a lifeline.
Oh, the
to figure it
widow.
out.
Oh, okay, yeah. Oh goodness. I promise I've watched all these movies. Okay, how many Lords of the Rings films are there? 3, 4, 5, or 7? This is pretty easy. We're not counting any of the hobbits. They're in the same universe. We're not counting them. All right, and the answer is I'm assuming A, right? The answer is 3 movies. There were 3 books. Please, someone click. I don't have access.
Sorry, I missed that. What was the? Oh, okay, she got it.
No worries. Okay, yeah, there are 3 Lord of the Rings movies. Beautiful, wonderful movies, by the way. definitely go back and binge watch them after Capstone. And question 11, which popular TV show featured Targaryen and Stark? A, Harry Potter, bold to assume it was a popular TV show, but okay. B, Game of Thrones. C, Lord of the Rings. D, Princess and the Frog.
I have a question because you kind of giggled at the question when reading it off. Do you have a connection to one of the to the correct answer of this? I feel like weren't you? I think what was it? The last time you were in person for Halloween. Was that your costume?
I might have dressed up as a character in Game of Thrones, and I might have had a Starbucks cup in my hand.
Nice.
Actually, Game of Thrones, and a couple of the folks on this call, they had because you need like Crave or something like that to watch Game of Thrones. So when the last season was coming out, we all went to, I think Daniel Sugar, if you're on this call, thank you for giving us free access to Game of Thrones the last season when it was coming out. Who would have thought? Look at us all here years later. All right, question 12. Who's often credited with creating the world's first car? Carl Benz, Henry Ford. Okay, I don't know how to say this, the first name, but Bugatti, I'm assuming that's how you say the last part of the car. Ferdinand Porsche? Oh, goodness. I can see Professor Newland is just going like the comedy is her reading things. All right, and the correct answer is Carl Benz. He had his middle name was Frederick, and he was a German engine designer and automotive engineer. Cool, and he made his first motor car in 1885. Interesting. Wow, very stylish. You know, they don't make the cars like this anymore. That's what I want to drive. You can drive this inside of Burj, actually, now that I think of it. Probably can fit in the lobby. All right, question 13. How many parts, screws and bolts included, does the average car have? 30,000, 25,000, 40,000, or 20,000? Mechanical engineers, you know, you're at the end of your degree. Show that the, you know, probably $60,000 in tuition was worth something with this question. You know, I can tell you how many screws and bolts are included in a spacecraft. Actually, now that I think of it, that's not the safest thing to do, but that's a whole other thing. All right, the answer is 30,000. Oh, cool. Oh. Is that what happens when you click on expand view on SolidWorks and just like everything goes and you see the whole car? All right, question 14. What country won the first FIFA World Cup in 1930? A, Italy, B, Uruguay, C, Spain, and D, Argentina.
Anybody know where the next FIFA Cup is?
I actually was going to ask that. Does anyone know that? We accept answers on the
Type it in the chat. It adds to your pubs. That's what I thought. This is the Qatar one. Did they end up building that like air conditioned? Like I remember that was the discussions when they first gave it to them that they would have to build an air conditioned soccer field because it's so hot.
Yeah. Maybe it's like, you know, when you're playing video games, the levels get more difficult, and they were like, next year it would be soccer on Mars. Let's see
They
which
built,
team dies
okay.
from lack of oxygen first.
So I have confirmation that it was built, and then
nice.
I also just got the greatest idea for the next capstone project.
Soccer on Mars?
To have them, that's even better, yes.
Alrighty, the answer is Uruguay. And most of the people actually got it right. 45% of people got it right. Well, the first World Cup with 2 U's. Yeah, and it was after a public holiday. After the Celeste became became the first world champions by defeating their neighbors, Argentina, 4-2. They look very happy. All right. Question 15. Which boxer was known as the greatest and the people's champion? Joe Louis, Muhammad Ali, Sugar Ray Robinson, or Mike Tyson? They don't have me in there, fortunately. Sorry, folks, I have the Teams chat open, so if you hear any notifications, it's probably just that. All right, and the answer is Muhammad Ali. He was the first American professional boxer and activist, nicknamed the greatest. He's widely regarded as one of the most significant and celebrated sports figures, and is frequently ranked as the greatest heavyweight boxer of all time. Question 16. What was the name of the group Justin Timberlake used to be a part of? Oh, I think I know this. I think I'm not old enough to know this, but I do know this. So A, NSYNC, B, Boyz II Men, C, Westlife, D, O-Town.
I think if you sing one of each of their songs, it'll help the audience guess.
Oh, is it like the one that says, what was the thing? It's like he was asking if he's original, if he's something. It's like,
that's like the current, like little, I don't want to say current TikTok trend, because it's probably old, but yeah. That's part of the, what is the song title?
Questioning things that you should be asking your therapist. Am I original? You never know. You have to find, you can't get that answer from other people, folks. You need to, you know, dig deep inside yourself and figure it out. And the answer is NSYNC was an American boy band formed by Chris
Kirkpatrick.
Thank you. In Orlando, Florida. That's where the Harry Potter world is, isn't it? In 1995. Well, I was born 2 years after that. That's why I was enjoying. I didn't join the band.
All
right, and Justin Timberlake. Oh my God! Look at those hair. Oh gosh, I'm so glad I was born 2 years after that.
That is, it's a lot of bleaching.
That's a lot. So, you know. All right, question 17. What genre of music did Taylor Swift start in? A, country, B, pop, C, rap, D, hip hop. Now, I assume everyone has watched Miss Americana on Netflix, the documentary. So this should not be.
I'm adding that to my list now. I don't think I've heard of this one though. Is that about Taylor Swift, or?
It's just about like her life and things like that. It's mostly. Yeah. All right, and the answer is obviously country. Swift was able to tap into the teen country fitness market and become an overnight success. Well, we all know who Taylor Swift is, so good job, Taylor. She should drop a lipstick brand. I've been telling everyone, like, look at those red lipsticks. Who would not buy a Taylor Swift red lipstick?
I think it's on the way now.
I know, I'm just like Taylor Swift, contact me. This was obviously my idea first. All right, question 18. How many? What? Oh, sorry. I read that as how many Germanys does John Legend have? I was like, I'm pretty sure
That's a better
country.
question.
Already, how many Grammys does John Legend have? 9, 10, 11, 12. 9
Isn't
or
John
10 or-
Legend? I think he's an EGOT, I believe, also.
Oh, I wouldn't be surprised. Yeah. Is
Yeah.
Lin-Manuel Miranda EGOT yet? No, not yet. Is he?
No, because he wouldn't get. Oh no, but he does act. I haven't
He
watched.
hasn't won an
anything
Oscar.
in-
Or has
Yeah,
he?
I was gonna say I don't imagine him getting the Oscar. This is based on me only seeing trailers. I have not watched anything he's in. So sorry to whoever I offended. That is a massive fan.
All right, and the answer is when John. What's the answer? Oh, 12. Wow, that's amazing. He has 12 more Grammys than me. Who would have thought? I have level 6 Royal Conservatory piano, and I'm offended that I don't have my 12 Grammys yet.
You're on the way. Don't worry.
I can there is no music here, but I can hear his voice. It's like butter, just beautiful. All right, question 19. The American designer born in 1937 as Ralph, Claudia, please help me. You have to say this one. Is better known as what?
Ralph Lifshitz. Oh, sorry, Lifshitz. Yeah, no, that's what I said. Lifshitz.
Yes.
Yeah.
Or anyone
And
else?
that's a guess. Yeah.
Oh, cool. So, is he Ralph Rucci or Rusi? Ralph Lauren. That's where Rachel from Friends worked. Ralph Grossell or Ralph Gregg? Ralph Lauren. Yes, American fashion designer, philanthropist, billionaire, businessman, and I have some sweatpants from Ralph Lauren, and they're very comfortable. So good on him. I wasn't expecting to see his face right after, but good job.
Nice surprise.
I know. All right, question 20. Where did Bagamon originate? Is that
Bagamon, also known as backgammon. Depending, it depends on which part of Canada you live in. So like Southeast Toronto, Bagamon, Northeast Toronto, backgammon. No problem.
So A, United Arab Emirates, B, India, C, Iran, D, Afghanistan. See, I did the thing because with Iran and Afghanistan, you say it like in like a Western way, but the way properly to say it, it's none of them are correctly said it. But then when you want to say it properly, when you're talking English, you just seem so out of place, and you seem kind of a little like, oh, show offish. So I don't. Anywho.
I experience the same issue when I speak Farsi, so no worries.
And the answer is Iran. According to Shahnameh, which is a very epic Persian poem. By the way, Shahnameh has like phoenix, like a bird that's kind of like phoenix inside of it. It's really cool. So I watched Dumbledore, The Secrets of Dumbledore, a couple of days ago, and you know how the phoenix, like the little. Anyways, just go and Google it. It's pretty cool.
That was a great description. I loved it though. Actually, I didn't know that either.
You know what's funny? I had no idea that's what it was called. Like, I didn't know what backgammon meant. I just pretended like I knew because I thought it was. But now I see what, like, I have one of these at home. And you know, the other side you can use it as a chessboard. 2 in 1.
Money well spent, yes. Sorry, just to interrupt really quickly. One, yes, Iran represents, but just to let anybody know who's in the chat, at this point of the day, if you've completed your panel, which you all have, you are done with the required portion of Capstone Day. So I know I got a couple messages, but I have to run to work. You can feel free to run to work or wherever, start your weekend, start your summer break. After finish trivia, we're just going to do the awards. And again, none of this is required. So please don't feel obligated to stay here. So, but also please do stay, those of you who can, and play trivia with us. And you may continue. Apologies. Yeah, I just saw a few messages asking me that.
No worries. Question 21. How many cards are there in a deck of Uno? 108, 110. See, now I want to say 1, but it's 100 and 105.
I just realized I would never have known the right answer for that.
Yeah, it seems like, see, 100 would make sense to me, but then the question becomes, why would you add a couple more? But a lot of people are saying 108. So I wonder what the answer is. It has 108 cards. Oh, because there is 76 number cards, 24 action cards, and 8 wild cards. Uno, okay, has 4, yeah. Cool, interesting. Question number 2. Which planet in the solar system would be the size of the Minecraft world if it was real? Hello? Come back. Mercury, Venus, Earth, or Neptune? So the question was, which planet in the solar system would be the size of the Minecraft world if it was real? Mercury, Venus, Earth, or Neptune? Now the answer is, did someone say, I'm sure these are all real planets?
Yeah, that was me. Because it said if it were real, so I thought, wait, all the planets are real.
No, I mean, Professor Newland can jump in here, but as a recent grad of Space Eng, I can assure you the Earth is real and round. Who knew?
But what about Neptune?
Well, Neptune is just a conspiracy theory, honestly, at this point.
I know Franz agrees.
Franz is like, so. He doesn't want to go on record saying it, but everyone in the community knows. No, I'm joking. All right, and the answer is Neptune. If Minecraft was a real place, it would be the size of Neptune. That's nice. See, I've never played Minecraft. It seems pixelated to me. Like we have so much better, but I'm just gonna move on because I don't want to lose friends. Question number 23.
So sorry, one more interruption.
Yeah, go ahead.
I see the question in the chat. If you're looking for the Lassonde Award ceremony, you found it. It will be actually right here. We're just finishing up the last 2 things. And then once it's ready, we'll stop trivia and then start the Lassonde Awards. So no worries, you're in the right place. Go ahead, Sophia.
Yeah, who knew? The real awards are the friends we made along the way. So question number 23 is, what is the best-selling game console of all time? PS2, PS4, Xbox Series X, or Xbox Series S? Now you have Xboxes, or you have PS2s or 4s, or then you have which one do you guys like? No, what is the best selling? What's the best? The question is not what you like. The question is, what's the best selling game of all time? And the answer is game console. Sorry. Good. It's PS2. That's with 159 million units sold worldwide. That's good. Good job, PS2. All right, now what is the most played video game of all time? A, Fortnite, B, Call of Duty, C, Genshin Impact, or D, Apex?
It's solitaire because it's on everyone's computer when they first get it. Thank you.
That's true. You guys remember, like, with the old phones, there was a little worm that was supposed to like eat something and then it couldn't touch itself and then it would get so big.
I do remember that, yes.
Yeah.
Yeah, snakes. There we go.
Yeah, there you go. And the answer is Fortnite. It's the most played video game and it has 3.8 million game players. It's great. See, was that the same for? No, that was Minecraft. Sorry. Oh, and here's the thing, folks. I actually practiced all these questions, and this is how wrong I'm getting them. So, question 25: who was Canada's first French-speaking prime minister? A, Stephen Harper. B, John Turner. C, Paul Martin, or D, Wilfrid Laurier? I feel like you need to like know how to speak. Oh, like, does that mean like first French descent, or does that mean first French speaking? Like they were able to do.
Ooh, that's a good question.
Yeah, because I feel like
Justin Trudeau, he talks mostly in English, but he can speak in French. So like, is that? So I guess as long as they're able to.
Yeah, I thought it was a requirement that you need to be able to speak French. Maybe not an actual. Yeah, maybe it's like a soft requirement.
Actually, that's a good question. Does Stephen Harper? I wasn't living here when he was, but does he speak French?
I mean,
or did he speak French?
I mean, theoretically speaking, all of us should be able to speak French since it was forced on in high school. But you know, bonjour, je m'appelle Sogan, and that's it. Have a good day. All right, and the answer is. All right. Yeah, Wilfrid Laurier. And he was a lawyer, he was a statesman, he was a politician. He could just fry the best chicken of all time. Like he could do it all. And he was prime minister from 1896 to, was that 1911? I think so. And here's a picture of him looking very happy. He was like, look at me. Look at me. I can fry chicken. I can be a businessman. I can be a lawyer. Accomplished. But was he an engineer? I think not. I think only we can do.
Nice.
All right.
Okay, so
yeah. Sorry. Go ahead.
I believe we hit time. So this will be the last question. Franz, I can see your picture. If you're ready to go, let me know after we do this last question. Well, while we make sure you know he can do it, go ahead and finish this last question.
Go for that question. I'm just starting up Zoom on my PC again, and I'll be with you in a minute.
Okay, so we'll do another question. If you just give us or just come in with the mic and we'll pause.
Just all right. Question 26. In which year did Canadian women win the right to vote in elections? The 1900, 1918, 1892, or 1754? The answer might shock you. 1918. Oh, it's been around 104 years now?
Not long enough.
Not long enough, yeah. It's like, you know, the thing that it's like the woman was too stunned to speak that it wasn't an earlier date. Alrighty. And the next question. So question number 27, when did the Toronto Blue Jays win their first World Series? 2001, 1981, 1921, or 1992?
Okay, please nobody be upset, but aren't the Blue Jays the team that, thank you, yeah.
They're basically.
There's the team that just kind of never wins, and everyone in Toronto's like really heartbroken.
You can also say that.
Maple Leafs, I just
too, but that's
It's the Maple Leafs. Okay.
All right. And by
It was
the
a
way,
genuine question. No, somebody said no shots, nothing fired. I don't watch sports. Okay. You know what? This is the perfect timing, perfect way for me to leave any ability to speak anymore.
And the answer is 1992. That's great. And by the way, the Jays have a game this Wednesday, and it's on Star Wars Day. So they're giving out cool Star Wars merchandise. Yeah. On May the 4th, be with you. Alrighty, everyone. Thank you so much for being here and for answering all the questions. And yeah, have a great capstone day. And we're moving on to award presentations.
So huge thanks again for animating that. That was excellent. We were following along in the background room, and that was great. Just to let people know, if you do want to come down to Vary Hall A, if you're on campus, that'll be a great place to watch the awards, the YCN Awards. We're about to start the Lassonde Awards though, so if you want to stay put where you're at for the Lassonde Awards, that's okay. As we start the awards presentation, I want to actually start by welcoming all our civil students who've joined us in this Lassonde Awards ceremony now. So we've got all the engineering students from Lassonde in our one virtual space. And I also want to take the opportunity to welcome Poulin. So Poulin, do you want to just say hi to everybody?
Sure. Thanks, Franz. So first of all, congratulations all the engineering capstone teams and students for your hard work in last 8 months. And most of you are now waiting for next phase. So again, big congratulations. And thanks for your participation, making this event successful. Yeah, so with that, I will ask Franz to move on to the awards session.
Wonderful, thanks, Poulin, for that. So we're actually going to go through the 2 ENG 4000 awards, and then we will go through the Civil Awards, and then we'll have a wrap up before we move over to the York Capstone Network room. As Poulin just said, thank you all for all the hard work that you've put in over the whole year. This has been a tough year for all of us, some much tougher than others. And I'm always blown away by the quality of what you're able to produce, and the things that we've seen today, the things that we've seen over the last few weeks are really a testimony to the hard work. So to Sogan's comment during the quiz, the biggest award that you've taken from this is hopefully the friends that you've made along the way. I thought that was an excellent comment. And but we do have awards available on Capstone Day. We have 2 awards for the ENG 4000 class. And we do have winners who the judges have been working diligently to select. They've watched all the videos and they've selected a winner for our 2 categories of ENG 4000 prize. So if we can go to the slide for the first of our 2 awards. So the first award is the ENG 4000 Capstone Prize, which is for the project with the potential to positively impact human well-being with maximum and immediate benefit. And we had a number of teams who were very close on this. We had a number of teams who did some very interesting things to address this. But we are pleased to announce the winner for the ENG 4000 Capstone Prize this year is Team X, our team who developed the low-cost device for detection and quantification of THC in oral fluid. So congratulations to Team X. Sergio, Daphne, Derek, Noor, Antonia, Shadan, and Alex. Really good work, and thank you very much for all the work over the year. So you are our ENG 4000 Capstone Prize winner. And I couldn't do the drum roll. I'll see if I can do it for the next one. So our next award is the PEO Award. The PEO York chapter sponsored this award. It's for the project that created, developed, and promoted a product with the greatest commercial potential. And again, on this one, there was a clear leader, a team who clearly had a product that was ready for great commercial potential. And on this note, I'll see if I can do the drum roll. And we have Team J, the venue team. So congratulations to Team J, to Amer, to Matthew, to Julia, to Ash, to Daniel, to Sean, and to Ziki. Excellent work. And we're hopefully not going to have to run another virtual capstone day, but we hope to be able to integrate venue into a future Lassonde event at some point. That would be really exciting to see. On that note, I hand over to Poulin to announce the Civil Awards.
Thank you, Franz. So first, congratulations to those ENG 4K teams for winning those 2 prizes. Now for Civil, there are 2 announcements. One is GeoSovl Innovation and Sustainability Award. So this award is for the capstone project with the most innovative and sustainable design solutions in the capstone design project. The winner for this award is Team 8, Oli Consulting. They worked on Highway 150 corridor improvements. So congratulations to Juan, Ariel, Jiwan, Mohammedian, Bilkis, Vanessa, and Vinay. Congratulations to all of you. Nice work. Now for the next award, CSCE National Capstone Design Competition, I would like to invite our, so by the way, I see Mark is here. So Mark Tigler is the president of GeoSovl. Actually, I wanted him to announce this award. Maybe there was some technical difficulty. Mark, do you want to say something? First of all, thank you for sponsoring this award. Maybe you could also congratulate the team and say something to our teams.
Yeah, no, could you page back one page? Yeah, great. No, and congratulations to the team. We're pleased to do this award on behalf of GeoSovl for the first time this year, and we're going to try to continue this annually. And I actually had the pleasure of serving with Ariel, one of the, so this was not rigged, just so you know, I did not vote on this, but Ariel was on the York advisory board for the civil engineering program, and I've been on that board for a while. So I'm pleased to be part of this fantastic school in a number of different ways, and really want to congratulate this team on the win, and in general for being students at York. I think there's a lot of really great things going on. I've had the pleasure of being able to watch the program grow over the last few years, served as the chair of the advisory board for a period of time. So yeah, I'm just really happy to be here and to be part of this. So congratulations to all the team members on the project, and be interested to see what that was all about, because I never learned too much more about the capstone. But if there's an opportunity for me to talk to anybody about the project, it sounds really interesting. So anyways, congratulations, and that's all I have to say for today. Have a good weekend.
Thanks, Mark. The competition was very tight. So this is our winner team, but the competition was really tight. So we had several teams that are very close to each other. So we'll move on to the next award. So our UPD, Dr. Peras, will announce the winner of our nominee team for national competition.
Thanks very much. This is the Canadian Society of Civil Engineers. They hold a design competition every year, and so the top team from our civil program will be going on to Whistler, BC, 2 members of the team. So we'll move to the next slide to announce the winner. Team 11, CN Consulting. This is a backyard conversion at a ravine lot. So Omar, Abdul, Esteban, Afnam, Peter Rim, Farid, and Wento. Congratulations, job well done.
Thanks, Dr. Perez, for this announcement. Again, congratulations, Team 11. We will contact with you for the further details for the national competition. So again, thanks all the teams, all the civil teams, as well as all the engineering teams. I would like to thank our TAs, all the advisors, and then all our sponsors and industry partners to help with our programs, and especially the capstone. And especially I thank the IT team for their hard work. And finally, Gayatri, Claudia, and Melissa, and also other, they have done fantastic work to make it happen. So thanks, everyone. I would like to now hand to Franz for the final words.
Thanks, Pulin. And I want to follow up again with those thanks. So thanks again to our ENG 4000 partners, our supervisors for all the projects. Thanks to the behind the scenes team today, without whom we couldn't have run the session, and their hard work, not just today, but over the last few weeks, getting everything ready. It's been a lot of work, and we've had a really good, a wonderful session as a result of it. Thanks to Gayatri and to Claudia, without whom Capstone as a project would not be what it is. They really are the thing that makes Capstone what it is, and we couldn't do this without them. So huge thanks to them. Thanks to my fellow faculty for helping us run this crazy journey that is Capstone. But first, but mainly thanks to all of you. You've worked so incredibly hard all year. And this is, for, as I said earlier on, for many of you, the end of your Lassonde journeys. So it's such a bittersweet moment when we see you go off and do exciting things. We will be reaching out to you. Claudia has your email addresses. She will be contacting you to follow up for future years. We're excited to find out what you do in future. We're excited to see what that future brings. And based on what we saw today, I think we can definitely say we're in good hands with you going out and doing great things beyond this. So on that note, we do still have one more session of awards to go. So we will be ending the Lassonde webinar shortly, and we will then be moving over to the York Capstone Network Awards. And we have a number of civil and ENG 4000 teams running for YCN Awards this year. So it's important to make sure that you swap over to the new link so that you don't miss out on the YCN Awards ceremony, that you can celebrate along with us the success of the York-wide Capstone Network winners. And that'll be a great thing to follow along. For those of you who are on campus and want to follow along that final celebration, the awards presentation starts at 4:15, so you might have time to get over to Vary Hall A. We will be heading there and see you there to follow along the YCN Awards. Are there any other notices or messages I need to share? We've got the link to the awards ceremony in the chat. Did I miss anything? Claudia? If not, huge thanks again. And we will see you shortly in the YCN Awards room. And you will hear from us early next week with final grades. So.
Thanks, everyone.
Thank you.
Congratulations, everyone. Thank you so much. Have wonderful, wonderful weekends of rest.
And you, Claudia.
Of course.
I'm already half asleep now, so don't worry.